Being proficient with an enterprise Linux distribution usually contributes to your success and/or higher salary in the IT industry. Possessing certifications or experience with enterprise Linux will almost guarantee this. This course covers essential training for Red Hat Enterprise Linux version 8. Each chapter focuses on specific technologies such as system configuration, iSCSI, authentication services, networking, DNS, web servers, and more. Most chapters conclude with a challenge, testing your skills in the focus area. In the past 2 decades, I've taught Red Hat Enterprise Linux to thousands of industry professionals who have gone on to work in the top technology corporations in the world. I'm sure you're excited to get started, and I'm excited to teach you, so let's get to it. In this course, you'll learn how to use Enterprise Linux version 8. If you have access to Red Hat Enterprise Linux version 8, that would be fine, but it's not necessary to complete this course. You can also use a clone of Red Hat Enterprise Linux, such as CentOS Linux, Rocky Linux, Alma Linux OS, or any other clone of Red Hat. When I refer to Enterprise Linux in this course, I mean any Red Hat Enterprise Linux version 8 clone. In fact, most tutorials will also work on Fedora Linux with very little modification due to its similarity to Red Hat Enterprise Linux. In this course, we'll continue to use the Linux installation that we created in the Foundation course in this series. In that course, we installed VirtualBox on both Windows and Linux hosts, created and optimized the virtual machine, installed Enterprise Linux version 8, and then installed VirtualBox guest editions and customized the Linux desktop to make our workflow faster and more efficient. If you created your VM in the Linux Overview and Installation course, then you can be sure that you have the necessary resources. If you did not, then you can double check them now. For the purpose of running virtual machines, you'll need an Intel or AMD 64-bit CPU with virtualization support. Intel CPUs with virtualization support will be advertised as having VT-X, and AMD calls it AMD-V. Be sure you have virtualization support turned on in your BIOS. For this course, you may also want to have high-speed internet for doing Linux operating system software updates. This is also handy for downloading large operating system ISO images. You will also want 30 to 40 gigabytes of free space minimum on your host computer's hard drive to give your VM room to operate. To run more than one VM at a time on a Linux host, you'll need to have at least 4 gigabytes of free system memory, but 8 will work much better. If you're using Windows as your host OS, you may need 8 to 16 gigabytes of free system memory. If you have more, then it will allow you to run more complex configurations with multiple virtual machines operating at the same time. This is useful, for example, when you want to learn networking or server client configuration. There are various operating systems that fit under the classification of Enterprise Linux. It may be advantageous to understand how Enterprise Linux is created to bring clarity to recent changes in the available choices. With that in mind, let's talk about how Enterprise Linux is developed. The most recent versions of software as well as new experimental packages are combined into a distribution called Fedora. A fedora is a low, soft felt hat with a curl, which may make sense as the Fedora project was created by the Red Hat Corporation. In 2003, Red Hat chose to split Red Hat Linux into Red Hat Linux Advanced Server for the commercial market and Fedora Core for individuals. Later releases were renamed Red Hat Enterprise Linux and Fedora. Fedora Linux is managed by the Fedora Project, an independent community-governed project primarily sponsored by Red Hat. About a third of all contributions are made by Red Hat employees. Although governed by the Fedora Council, Red Hat retains legal liability over the Fedora project. In Fedora, software is downloaded by users, tested, and bug fixed, and once it reaches a sufficient level of stability, Red Hat starts building the next release of Enterprise Linux from those packages. This places Fedora upstream of Enterprise Linux as code flows downstream. Enterprise Linux is generally based on a previous, stable version of Fedora. For instance, when Fedora 28, 29, and 30 were available, Enterprise Linux 8 was based on Fedora 28. Although Red Hat Enterprise Linux is a commercial product, Red Hat makes the source code available, which other projects compile into distributions that are nearly identical to Red Hat's own. One of the most popular is CentOS Linux, which came out in 2004. The CentOS project removed Red Hat's trademarked images and created CentOS Enterprise Linux. This places CentOS downstream from Red Hat. CentOS makes an excellent foundation for learning Enterprise Linux because it is nearly identical to Red Hat Enterprise Linux. It is free, but is provided without support. It is common to have Red Hat Enterprise Linux servers on the front line backed by paid Red Hat tech support, and many CentOS servers in the background managed by in-house personnel. It may seem that admins are benefiting from Red Hat development without paying them. It should be noted, however, that Red Hat benefits as well. The widespread usage of CentOS in production environments results in countless bug reports and code submissions to make the enterprise platform even more robust, as well as increase its popularity. The relationship can, however, be a bit clumsy as code submissions to CentOS are applied downstream from Red Hat and then flow upstream. This means that code is going both directions, making it difficult to manage. Red Hat, who took over the CentOS project in 2014, took steps to mitigate this situation by creating CentOS Stream in 2019. Instead of being a downstream copy of Red Hat, CentOS Stream is placed between Fedora and Enterprise Linux. This means the packages from Fedora are first used to create CentOS Stream, where they undergo an additional level of testing before being folded into a new release of Enterprise Linux. All bug fixes are applied upstream of Enterprise Linux, making the development process simpler and some might say more streamlined. In December 2020, Red Hat unilaterally terminated CentOS development and support ended on December 31, 2021. CentOS Stream is to be the only supported CentOS remaining. So where does this leave you if you want to learn Enterprise Linux? Let's start by talking about Fedora. Fedora Linux allows you to gain familiarity with various tools and file system structures of Red Hat. It is not identical to Enterprise Linux, but is similar enough that the skills acquired can be useful, and in fact, you will be learning technologies before they're added to Enterprise Linux, giving you time to get accustomed to them. Note that Fedora is designed to be a software testbed, and not with enterprise-level stability in mind. I would not use it for a large commercial server installation. I would, however, use it for development and as a desktop operating system. CentOS Stream is perhaps a better choice as it is more similar to Enterprise Linux in both software package versions and stability. But caution has to be taken due to it not being considered a stable, production quality operating system. It is perfectly fine for learning Enterprise Linux, and in truth would be adequately stable for any small-scale projects that a user may have in mind. An added bonus is that you would be using the next version of Enterprise Linux before it's even released. A surprising replacement for CentOS is actually Red Hat Enterprise Linux. Red Hat offers the Red Hat Developer Subscription for individuals. The subscription is free and allows for installing Enterprise Linux on up to 16 machines, either real or virtual. Perhaps a good option to consider, however, limits are limits, so plan wisely. If you're looking for an exact replacement for CentOS in both functionality and freedom, then better choices may include Rocky Linux, which was created by one of the original founders of CentOS and named after another, or Alma Linux OS, which was created by Cloud Linux, makers of Cloud Linux OS. Both of these are binary compatible and track Enterprise Linux software updates, just as the original CentOS did. CentOS can be migrated to either Rocky Linux or Alma Linux OS by running scripts available on their websites. If you happen to be using Linux as your host OS, you will want to install VirtualBox for that operating system. If you're using Windows for your host OS, you can skip this video. We will be installing VirtualBox, but also installing a VirtualBox extension pack. Extension packs add additional functionality to VirtualBox. To install VirtualBox, we'll need to download it first from the VirtualBox website. Browse to virtualbox.org/wiki/downloads and hit enter. There are versions of VirtualBox for multiple operating systems. In this tutorial, I'm running a Linux computer, so I will download the Linux version by clicking on Linux Distributions. After clicking on Linux Distributions, you will get to be more specific about which distribution you're installing VirtualBox on. If your host OS was Ubuntu, Debian, OpenSUSE, or Fedora, you choose one of those links. Since I'm running Enterprise Linux 8, I will choose the first item. You can install the software package, but I like to save it first. Make sure Save File is selected and click on OK. Now click on the downloaded package and it will start the package installer GUI. Now I can click Install and the install process will start. The VirtualBox installer file that we downloaded will be installed in addition to any dependency packages that VirtualBox will need. These dependencies will be downloaded from the software repositories on the internet. This method does work, but I rarely ever do this. Using this GUI tool is a fairly slow process, and more importantly, this application gives you very little feedback while it's installing. A faster, more informative, and more reliable method is to use the command line. Now close this window and open a terminal by clicking on the Activities in the top left-hand corner and then typing terminal. Since we're going to be using the terminal more later, drag it to your application bar on the left. Now, whenever you want to start a terminal, you can just click on it. Do that now. You can also double-click the title bar to maximize it. To install the VirtualBox package that we downloaded, we'll need to change to the downloads directory. Type in cd:/downloads. Note that Linux is case sensitive, so be sure to include the capital D. Now type in ls to list the contents of the directory. We can see our VirtualBox package file in red. To install it, we'll use the dnf command and we'll elevate our privileges to administrator using the sudo command. Type in sudo space dnf space install space uppercase V and hit your tab key. Hitting your tab key will allow your terminal to fill out the line for you. Our shell has command line completion built in. Then hit enter and type in your password. Note that it does not show you any characters on the screen when you type in your password. The thing I like about the command line is that not only is it fast, it tells you what it's doing. Here we see that it's going to install VirtualBox 6.1, but also it's going to install 2 dependencies as well. Note the repository column. The VirtualBox package is coming from the command line, that is, the package we downloaded. But also note where the additional packages are coming from, a repository called AppStream. This is on the internet. The dnf command automatically figures out which other packages we need and downloads them from the online software repositories. It also tells us how much space the installation will take. Press Y to continue. Now we can watch the installation process. DNF downloads the dependencies and installs them first. Then after that is complete, installs VirtualBox. It will take a few minutes to complete and configure VirtualBox. Notice that we didn't have to answer any questions during the install. It just installs the programs. After the packages are installed, it tells us that in order to create virtual machines, our user needs to be in the VBox user's operating system group. This is for security reasons, as VirtualBox needs access to low-level resources. We can check our groups by typing in groups and hit enter. We can see that we are not part of the VBox users group. To add our current user to the VBox users group, we'll use yet another command. Type in sudo space gpasswd space -a for add space, and then our username, mine is user1, space, and then the VBox users group. And hit enter. Now type in your password. This will add the user named user1 to the VBox users group. Enterprise Linux also uses a highly secure, mandatory access control system called SELinux that keeps it safe from malicious code. We need to let SELinux know that we're using VirtualBox. Type in sudo space set sebool space -P space use _ VirtualBox space 1 and hit enter. This flips a Boolean and allows VirtualBox to function. If you don't do this now, you'll get notified later when attempting to use VirtualBox. To ensure the installation and modification of the system configuration went well, reboot your Linux host by going to the top right-hand menu, click on the power button, and then click on Restart. The extension pack adds additional functionality to VirtualBox. It adds virtual USB 2 and 3 devices, VirtualBox Remote Desktop Protocol, host, webcam, and PCI pass-through, Intel PXE boot ROM, and disk image encryption. These additional capabilities make USB devices faster, allow remote access to VMs, support passing through webcams and other real expansion cards to VMs, and encrypting the VM disk images for security. Future extension packs may add more features, but will be installed in exactly the same manner. Once your Linux host has rebooted, log in. Then bring up your web browser and go to virtualbox.org/wiki/downloads again. Scroll down to the extension packs and click on the extension pack for all supported platforms. Unlike the main VirtualBox executable, which is specific to each operating system, the extension packs are only specific to the version of VirtualBox you have installed. In our case, we have the latest version, so we will install the latest extension pack as well. When prompted, click OK to Open with Oracle VM VirtualBox. The VirtualBox installation window will appear. Click on Install. View and accept the license agreement and enter your password when prompted. This should complete the extension pack installation. Click on OK, and to verify the extension is installed, click on File, Preferences, and click on Extensions, and you should see it. And that is how you install VirtualBox on an enterprise Linux host. Before we can install Linux in a VM, we need to make one. Make sure the VirtualBox GUI is running on your host, and then click on the new icon. Name your VM RHOST1. This will be short for Red Hat host number 1. Change the type to Linux, and change the version to Red Hat 64-bit. These settings just change the preset defaults in the rest of the configuration wizard, so don't worry too much about them. Now click on Next. Although Enterprise Linux will run with less than 1 GB of memory, things go smoother with 1.5, so let's change the value in the field to 1500. And then click on Next. We need to create a virtual hard drive. Take note that this doesn't overwrite anything on your host computer hard drive, it only creates a file on your host that acts as a hard drive to your VM. Make sure Create a Virtual Hard Drive Now is selected, and click on Create. For the hard disk file type, leave the default selected, VDI or Virtual Disk Image. Click on Next. For the type of storage, selecting Fixed Size allocates all drive space now. This means that if you choose to have a 10 GB virtual drive, your host OS will allocate all 10 GB right now, so you'll be using 10 GB of your host hard drive space, even if the guest drive is empty. The upside to selecting fixed size is that disk access is slightly faster. Dynamically allocated means that the host OS will only allocate space on the host hard drive when the guest VM's drive starts to fill up. This is fantastic if we're running a lot of test VMs because the drives will be mostly empty. The disadvantage is that disk access will be slightly slower. For this course, we'll choose dynamically allocated. Now click on Next. Now we need to choose the size of the virtual drive. Technically, it is possible to get Enterprise Linux 8 to install in an 8 GB drive, but we have to manually configure our drive partitions, which is beyond the scope of this course. Change the size to 10 GB to make your life easier. If you have more free space available on your host computer hard drive, then you can increase this size if you wish. Choosing a larger size will allow you to install more software in your Enterprise Linux operating system. Remember that we chose dynamically allocated, so your guest virtual hard drive doesn't actually take up the space on the host computer until we add files to it, so there's really no downside to creating a larger virtual disk. Click on Create. Now we have a new virtual machine ready for Linux to be installed. To install Enterprise Linux from the full DVD, we need to download an ISO image from the CentOS website. We'll do this by opening a web browser and going to the download page at centos.org/download. Scroll down a bit and click on x86_64 and choose a mirror close to you for a faster download. If you don't know where any of these servers are, just randomly select one. At the time of this recording, the current version is 8.3.2011, but may be different when you watch this video. If you have a torrent client on your computer, you can click the .torrent file and the load will be shared among other torrent users and most likely download much faster. On my network, downloading via torrent takes about 26 minutes. Downloading the ISO file via web browser is over 1 hour. It may be worth the effort to install a torrent client just for these files. Now click the DVD1 ISO image. When the file dialog presents itself, save the ISO image to your hard drive. Once the ISO image has downloaded, select the VM named RHOST1 and click Start. In the next dialog, select the ISO image you downloaded by clicking the folder icon, then clicking Add and selecting the ISO image. Now click Start again. Now click on Open, and then click on Choose and Start. Highlight Install CentOS 8 with the cursor keys. Selecting the item turns off the auto start mechanism. You can choose the second option to test the install media instead. This is mainly for ISO images that have been burned to physical DVD disks. We don't usually have to do this for ISO images that reside on hard drives. Now hit Enter and wait for the system to boot. When you click inside the window, your mouse pointer will become captive. Sometimes your host computer mouse pointer does not line up with a mouse pointer inside the virtual machine. If this happens to you, then place the mouse pointer in all four corners and VirtualBox will center it. Now click on Continue. Now you should see the installation summary screen. This is where you will configure how the operating system will be installed. First, click on Time and Date and set your time and time zone, and then click on Done. You can also choose which keyboard you want CentOS to use, as well as which language you want CentOS to use. Now click on Software Selection and change it to Workstation. This configuration doesn't have a ton of packages installed, but still has a full GUI. Don't get too worried about installing software here, as it can all be done later. The only difference between these categories is the list of software packages that get installed now, as opposed to what we install later ourselves. Now click on Done. We can now choose our installation destination. Naturally, this will be the only virtual disk available. Make sure ATA VBox hard disk is selected. Under Storage Configuration, you'll see Automatic and Custom. If you choose Automatic, the installer sets up 3 partitions automatically. There's nothing wrong with this choice, as the default partition layout is good. If you choose Custom, you can set up the partitions manually. The advantage to choosing Custom is that you get to see what the installer will create, and you can modify those results if you wish. Let's click Custom, and then click on Done. This brings us into the manual partitioning screen. Here, we could create any partition scheme we want. However, we're going to cheat and click the link to create our partitions automatically. This will give us a good default partition layout. Clicking this link brings us to a new screen showing the proposed partition layout. The installer wants to create a small partition accessible as /boot, where our Linux kernel and other boot files are stored using the XFS file system. Second, it wants to create a much larger root partition where most of the operating system is stored, using the XFS file system again. It also wants to create a smaller swap partition for virtual memory. We can edit any of these configuration details on this screen. Let's just click Done and Accept Changes to accept the installer's suggestions. We don't need the network configured to install with a full DVD, but if you want to configure the network now, you could by clicking on Network and Host Name. Now we need to set the administrator's password. Click on Root Password. You want a very strong password for the root user, because in Linux the root user is all-powerful and the username is known, making it a target. If a hacker were to get this password, they'd have access to everything in the system. The installer tells you if the password strength is good or not. Use a combination of numbers, letters that are uppercase and lowercase, and symbols for your strong password. The installer will let you proceed with a weak password if you wish by clicking Done twice. However, it's not recommended. In Linux, we have the philosophy that the system designers should not force the users, but rather give them the freedom of choice, even if those choices are bad. Click Done. If the installer doesn't let you go on, then the two passwords probably don't match. It doesn't give you a lot of indication of this, but if you look at the bottom of the screen, you'll see the message. We don't ever want to log in as root, and especially not on the GUI. There's just too much power and too few safeguards. So on Linux, we always create a user. Click on User Creation. Enter user1 for the full name, and it will create a lowercase version of it for your username. We'll create a strong password here because we're going to make this first user an administrator by clicking on the checkbox labeled Make this user administrator. It's very important that you click the administrator box now, as the rest of our course depends on it. If you fail to click this box, you will need to log in as root after the install is finished and add this user manually to the wheel group. It's best to do it now. Click on Done. Now click on Begin Installation. The install will take between 20 minutes and an hour depending on your host computer's hardware. As soon as the install is finished, you'll be able to click on Reboot to reboot into your new VM. As soon as your VM reboots, you'll need to accept a license. Click on License Information, and then click the box at the bottom, I accept a license agreement, and click on Done. Now click on Finish Configuration. Now the system will continue booting to the login screen. Notice that root is not even given as an option on the GUI. You can specify any user if you click on the Not Listed link. However, I really recommend that you never do this. Log in as the user you created, which was user1. As soon as you log in, you'll be prompted to choose your language. I'll choose the default and click on Next. You will then be prompted to choose your keyboard. Again, I'll choose a default and click on Next again. Next, we can choose our privacy settings. By default, location settings are on. I'm going to turn them off and then click on Next. I will also skip creating online accounts by clicking Skip. Lastly, press Start using CentOS Linux. The next window we see is a Getting Started window explaining how the CentOS desktop works. For now, we can close this window. You can access this anytime you want by clicking on the Activities icon and then clicking on the Help ring, and then clicking on Getting Started with GNOME. Now, you have successfully installed CentOS Linux 8 via the full DVD image. It's a good idea to keep your system software updated, and even though we installed from the full DVD ISO, there will be quite a few software packages that need updating. The reason for this is that the DVD installer pulls its software from the DVD, which may be months old. Unless the DVD just came out, there will be newer software packages available. A network install takes longer, but will not have any packages that need updated because it installs the latest packages from the software repositories. Let's look at the various ways we can update all system software. One of these software updates may be the Linux kernel, so we'll want to reboot when we're done. Linux doesn't often need to reboot after system software updates unless there's a new kernel. Take note that networking needs to be turned on in order to update any software. Select the top right-hand menu and click on the connection called Wired and make sure it's on. To update your operating system via the GUI, put your mouse pointer in the top left-hand corner to go into Overview mode and type Software. And then click on the software icon when it appears. This application has just two jobs, updating and installing software. Once the software installer is running, click on the Updates button. If it says all software is updated, it may be because its list of available software is out of date. Click the refresh icon in the top left and wait. This may take a while. In my case, I have two updates labeled OS Updates and Firefox. OS Updates is not very descriptive, and I'm not sure what it includes, so I rarely choose to update using this method. Updating via the command line is faster and more informative. As the GUI programs are updating sources, downloading the updates and installing them, they tend to look like they're doing nothing. Close this application for now. My preferred way of updating the system software is through the command line. To update your operating system via the command line, click on Activities and either type in Terminal or click on the terminal icon on the dock. Type into the terminal sudo space dnf space update. The sudo command lets us elevate privileges to the root user for this one operation. The root user is the administrator in Linux. This is similar to the Run as Administrator menu in Windows. In order for this to work, we had to check the box during install that made our first user an administrator. If you didn't do this, you will get a scary error message saying you don't have the correct privileges and the administrator has been notified. It's beyond the scope of this course to remedy the situation. However, if you want to research it, you'll need to add your user to the wheel group and log out to make it active. Go ahead and hit Enter and type in your password. The DNF command is getting a list of packages needing updated, as well as all dependencies that these packages need. The software updater is now asking for confirmation to install the updates. Press Y to continue. Once it downloads all software packages, it will install them. Once it's done, it'll clean up. If it prompts you to accept GPG keys, say yes. This allows packages to be signed with GPG signatures for security. Once all software is updated, close the terminal window. Now let's create a new snapshot of the updated operating system. Press Host plus T, and let's name this one Updated OS. In the description box, add Fresh Install and All Updates Applied. And then click on OK. To reboot, select the top right-hand menu, select the power button, and then restart. VirtualBox guest editions are pieces of software installed in the guest operating system that give the guest OS a direct communication path to the VirtualBox hypervisor. This allows the guest to take advantage of faster drivers, better screen resolutions, and better integration between the guest and host, including a seamless mouse. I highly recommend installing guest editions as it makes the virtual experience smoother. Installing guest editions can be troublesome, but I think it's worth it. Before installing VirtualBox guest editions, there are a few prerequisites. All Linux operating system software has to be up to date. After the OS is updated, it needs to be rebooted, so we're using the latest kernel from the OS update. Note that shutting down the VM while restoring to a previous snapshot does not accomplish this. The VM has to go through the boot process. Networking needs to be turned on so we can install software packages from the remote software repositories to build the guest editions. You may have to manually turn the network connection on. For this exercise, your RHOST1 VM needs to be booted, and you need to be logged in as user 1. Now open a terminal by clicking on Activities, and then clicking on the terminal icon. Now let's update all software packages by typing in sudo space dnf space update space -y and hit enter. Enter your password when prompted. The sudo command allows us to elevate our privileges to the system administrator. The dnf command handles software installations from the software repositories. dnf has replaced the yum command if you're familiar with it. You can still type in yum, and it will still work. I've also passed the -y option, which will answer all questions with a yes. This way, we will not be prompted during the process. When it's done, reboot by typing in sudo space reboot, and hit enter. Do not skip the reboot step, or installations of guest editions will likely fail. After your VM reboots, log in, ensure the network is on, and then open a terminal. Now type in sudo space dnf space group space install space -y space double quote development space tools double quote and hit enter, and enter your password when prompted. This installs the Software Development Tools group. With Enterprise Linux 8, we also need to install one more package. Type in sudo space dnf space install space -y space elf utils -libelf -devel and hit enter. Whenever you see a package name ending in -devel, you know it's the source code for that package. Once that is done, insert the Virtual Guest Edition CD using the VirtualBox Devices menu. You will have to release your mouse pointer by pressing the host key. Then go into the Devices menu and go down to Insert Guest Edition CD Image. When the dialog box appears, click on Run and enter your password. This will take a few minutes as it has to compile a new kernel module. Once it's done compiling, press Return to close the window. You can also close your terminal. You can now choose a larger screen mode by clicking on Activities and typing in Displays. Click on Resolution and choose a larger screen mode. And click on Apply, and then click on Keep Changes. Now create a new snapshot by pressing your host key plus the T key. Let's name this Guest Editions. And in the description, type in Guest Editions Installed and click on OK. Now we have an updated VM with full screen mode and seamless mouse pointer. VirtualBox allows us to take snapshots of the virtual machine state. The purpose of a snapshot is to save a state or version of our VM. This includes the running state of programs and the contents of the system memory. We can have a number of snapshots that we can roll back to at any time. For this exercise, you'll want your RHOST1 VM running, so if it is not, start it now. Once it's booted up, log in and open a program. I'm going to choose the Files program on the dock. Whenever I install a new VM, I like to take a snapshot of the fresh install. This way, if I want to go back to a freshly installed operating system, I can just roll back to this snapshot without having to install all over again. I also take snapshots every time I install and configure anything major. For instance, if I installed and configured a web server, I would take a snapshot once I got it working the way I wanted. If later something goes wrong with the configuration, I could always roll back to the last working snapshot. This works in the case of malware as well. If I manage to be infected by a virus, I could roll back to the pre-infection snapshot in a matter of a minute. My rule is this: if I don't want to do it again, take a snapshot. Anytime we're using a VM and want to create a snapshot, we can just press the host plus T keys and the snapshot window will appear. We can do that now and give the snapshot a name, and if more details are necessary, use the description box. Let's call this one Base Install Finished. And in the description box, add no updates or guest additions installed. This will remind us that these items still need to be completed. Click on OK. If we want to restore to the previous snapshot, just click the Close gadget in the VM's window. You may need to press your host key to release your mouse pointer. A window will come up giving a few options: save the machine state, send shutdown signal, or power off the machine. The last choice has an option of restoring to the previous snapshot. If we select this, our VM will be rolled back to the last snapshot we took. Choose Power Off the Machine and make sure Restore Current Snapshot Base Install Finished is selected, and click on OK, and the VM will shut down very quickly. Once the VM has shut down, click on the Start button again and it will be restored. Notice that the operating system didn't go through the boot process. Even the Files program that I started earlier is running. Had the Files program been copying files, it would resume exactly where it left off, as if by magic. If you want to roll back to any other snapshot, you'll need to do it from the VirtualBox Manager window. In the VirtualBox Manager window, we can see that our VM is still running. To see the snapshots, we want to click on the icon to the right of the VM name and select the Snapshots menu item. If we click on Current State, we can click on the camera icon to take a snapshot. This is the same as pressing the host key plus T in the VM window. Let's create a few snapshots to play with. Let's name the first one Test 1 and click on OK. We'll create another one and name it Test 2 and click on OK again. This will give us a couple of snapshots to play with. If you want to delete any snapshot, just click on it and then click on the camera icon with the red X and then click on Delete. Notice the Restore icon is grayed out. This is because you cannot restore to a previous snapshot with a running VM. Shut the VM down now by clicking on the Close gadget, and then click on Power Off the Machine, and do not select Restore Current Snapshot Test 1, and then click on OK. Once our VM has shut down, we can see the Restore icon is no longer ghosted. We can click on any snapshot and click the Restore icon to roll the VM back to that state. Click on Base Install Finished and click on Restore. A dialog box will pop up with a checkbox asking if we want to create a snapshot of the current state. If we check the box, it will create a snapshot of the current state, and we can restore our VM back to the way it is now. If we uncheck it, then the current state will be lost. Uncheck the box, and then click on Restore. Now start up the VM by clicking on Start. This should happen very quickly, as it's not actually booting, but rather being restored into memory. VirtualBox is extremely efficient when it comes to snapshots, much more so than other hypervisors that are available. However, you may still end up with a lot of snapshots taking up disk space. At any time, you can delete the snapshots that you don't really need. For the purpose of this and other courses, it may be advantageous to create snapshots after you've completed each exercise. This will allow you to revert your VM back to before the exercise and complete it again. It's important to note that Red Hat ended support for CentOS 8 on December 31st, 2021. Part of the process involved changing the software repository URLs from CentOS.org to vault.centos.org. If you have a CentOS installation and it cannot install software from its repositories, execute these steps. If you're using Rocky Linux or Alma Linux OS, you can skip this video. First, make sure your networking is turned on by clicking on the top right-hand menu and clicking Wired Off. Now click on Wired Settings, click on the gear icon next to the wired connection, and click on Connect Automatically. Now click Apply, and click the slider gadget to turn it on. Now to fix the repositories, in a terminal type in cd/etc/yum.repos.d and hit Enter. Now comment out all mirror list lines by typing in sudo space sed space -i space single quote s / for the delimiter, mirror list, / hash mirror list, / G for global, single quote, space, capital C, lowercase e and t, uppercase OS, dash, asterisk, and hit enter. And type in your user's password. Now, change the CentOS mirror URL to vault.centos.org. We'll need to use the pipe symbol for the said delimiter because the URLs have / in them. Type in sudo space sed space -i space single quote, S for substitute again. This time type in a pipe symbol for the delimiter. Hash base URL equals http :/ mirror.centos.org. Pipe symbol base URL equals http :/ vault.centos.org. Pipe G single quote space capital C lowercase e and t capital OS dash asterisk and hit enter. Now update your system by typing in sudo space dnf space update and hit enter. Note that this makes your CentOS installation functional again. Since this version is no longer supported, there will not be any more software updates for it, but you will be able to install current software from the repositories. For now, this may be fine, especially for the purpose of learning. However, in the future, it may become a problem when trying to install newer versions of software. Once the update has been done, reboot your VM by typing in reboot and hit enter. To be able to update your CentOS system with new versions of software and security patches, you'll need to migrate it. A couple of options include migrating to Rocky Linux or Alma Linux OS. I will outline both processes in this video. You can do either both for educational purposes or choose one. Log back in, and then before making any changes to your VM, you should take a snapshot by pressing the host key plus T. Name the snapshot pre-migration and hit enter. To migrate CentOS 8 to Alma Linux OS, point your web browser to almalinux.org. And then click on the Migrate button. This will take you to their GitHub page. About halfway down the page, there is an Alma Linux-deploy.sh link. Click on it, and then click on Raw. And then right-click and select Save Page As. Choose your Downloads directory and click on Save. Once that's downloaded, go to your terminal and change to the Downloads directory. Type in cd space / downloads with the capital D and hit enter. Now run the script by typing in sudo space bash space almalinux-deploy.sh and hit enter again, and enter your password. Once the migration is done, reboot into Alma Linux OS. Another option is to migrate to Rocky Linux. To do so, you'll need to revert your VM back to the pre-migration snapshot again. Click the VM Close gadget, select Power off the machine, and select Restore Current Snapshot Pre-Migration and hit OK. Now click on Start to start your VM back up. Once it's powered back up, bring up a web browser and browse to rockylinux.org. And click on Migrate. This page contains the documentation concerning migration from CentOS. Partway down the page is a link for the GitHub project page for the Migrate to Rocky script. Click on that. Now click on Migrate to Rocky.sh, and then click on Raw, and right-click and click Save Page As, and save it to your Downloads directory. Open a terminal and cd to your Downloads directory. Type in cd space / downloads with a capital D and hit enter. And then run the script. Type in sudo space bash space migrate to rocky.sh space -r and hit enter. And enter your password. Once the migration process has finished, reboot into Rocky Linux. The differences between Rocky Linux and Alma Linux OS are minor and comprise boot images and backdrops at this point. Both of these are nearly identical to CentOS 8 and will receive all future software updates. Use whichever one you wish. In this chapter, we will produce and deliver reports on system utilization of resources. Resources such as processor, memory, disk, and network. We will also use shell scripting to automate system maintenance tasks. Keep in mind that I cannot teach you all of Bash scripting in one video. To gather statistics from the system, we're going to use systat. With systat, we can log information about system resources such as processor, memory, disk, and network. The systat command should be installed already, but if it's not, we'll install it now. For this exercise, be sure to be logged into your RHOST1 VM as user 1 and have a terminal open. To install systat, type in sudo space dnf space install space -y space systat and hit enter. Type in your password if prompted. If it's already installed, this won't harm anything. Now let's start the service and make it persistent. Type in clear, then type in sudo space systemctl space start space systat and hit enter. To make it persistent, bring your line back and change start to enable. Systat writes log files to the /var/log/sa directory. By default, data is written every 10 minutes, but this can be changed in the systemd timer file for systat. For the legacy Enterprise Linux 7, this is stored in a cron file in /etc/cron.d. Let's take a look at the Enterprise Linux 8 timer file. To do so, type in sudo space less space /usr/lib/systemd/systat-collect.timer. We can see in the timer section the systat activity collector runs every 10 minutes. Press Q to quit. Next, we'll take a look at the systat system config file. We'll use less again to view this file. Type in sudo space less space /etc/sysconfig/systat and hit enter. We can see options for how long to keep the files, when to archive them, and which archiver to use. We will not modify any settings at this time. Press Q to quit. Now that we have systat gathering data for us, let's create some reports from it. We'll use the sadf command to create a report. Let's see if we have any data files to process. In a terminal, type in ls space /var/log/sa and hit enter. If there is a file in there, then specify that for the next command. In my case, I have a file named sa10. This is for the 10th day of the month. Depending on when you're watching this video, your files will be named differently. Since I have a file named sa10, I'd type in sudo space sadf space -s space 00:00:00, which is the start time, space -e space 23:59:59, which is the end time, space /var/log/sa/sa10, and hit enter. This will consider all data from midnight to 11:59 p.m. in the sa10 file. It will then create a report and output it to the screen. By default, the data is created in a format ingestible by awk. If we want an XML file, we could just add the -x option, bring your line back, and append a -x to the end, and hit enter. If we specify the -d option, it makes it suitable for a database. Bring your line back and change the -x to a -d, and hit enter again. Currently, we're looking at all information in the report. If you want to be more specific, we can use SAR options to narrow it down. For instance, if I only wanted to see disk activity, I would bring my line back and change the option to --space -d. This looks similar to what we just did, but it's different. By putting the --@ at the end of the command, it ends the sadf options and allows us to append SAR options. In this case, the -d SAR option shows only messages specific to the disk subsystem. Go ahead and hit enter. Other possible SAR options are $B shows paging stats, -B shows I/O and transfer rate stats, -D shows disk activity per block device, which we talked about already, $X shows huge page utilization stats, $I followed by an interrupt shows stats on that interrupt, -M shows power management stats. You can also specify the subsystems such as CPU, fan, temp, and USB. Note that you need to pass the -S power option to SADC to collect this. "-N shows network stats. "-P shows per processor stats. "-Q shows queue lengths and load averages. "-R shows memory statistics. "-R shows memory utilization. "-S shows swap space utilization. "-U shows CPU utilization. "-V shows status of inode, file, or other kernel table. "-W shows swapping stats. And lastly, "-W shows task creation and system switching activity. For example, bring your line back and replace the "-D with "-U space 2 space 5. This utilizes the "-U SAR option, which shows CPU utilization every 2 seconds. If you wanted to show memory and network statistics, we'd bring our line back and replace the options with "-R space "-N space DEV and hit enter. See the SAR man page for more information on possible options. If we wanted to create itemized reports every single day to be used by other systems, we could create cron jobs that would execute SADF with the appropriate options and then redirect the output into a file. This is a quick introduction to using Bash for automation. We cannot cover all of the details of Bash scripting in one video, so instead we'll focus on how to automate tasks using Bash. For this video, we'll discuss a script that keeps track of who is logged in at any given time, how long they've been logged in, and what they're running currently, and type vi space userlog.sh and hit enter. The script starts with #bang/bin/bash, which calls the correct shell interpreter, in this case, the bash interpreter. We then assign the path and name of the log to the userlog variable. If this were a system script, we might want to save the log in /var/log, which requires root privileges. For this lab, we're writing it to our home directory using a variable which changes depending on who we are. Now, we're using the date command inside of command substitution to store the date. The +%B, %D, %T are formatting options. You can view the man page for the date command to learn more about available formatting options. Open another terminal tab and look at the man page for the date command. Type in man space date and hit enter. Then scroll down to the format section. Here we can see what the different sequences are. I used a lowercase b, which is the abbreviated month, a lowercase d, which is the day of the month, and an uppercase T, which is a shortcut for uppercase H, uppercase M, and uppercase S. This displays the time in hours, minutes, and seconds. You can close this tab now. The man page doesn't show any examples of these formatting options, so you might want to input the desired formatting options into my string to customize the output. Now we append the date and time string that we just set, plus the hostname, which is in the hostname system variable, to the user log file. The last uncommented line is where the bulk of the work is being done. We use the W command to get statistics on the user logged in and pipe the output to the tail command, which prints from the second line until the end of the file. This filters out the first line, which I didn't want. Then it takes the remaining output and pipes it into awk, which then prints a dash followed by the first through fourth fields as well as the seventh. This information is then appended to the user log file. Notice I have a commented out line that's nearly identical to the last uncommented line. The difference is I'm using sed to grab the second line until the end of the file. There's usually more than one way of doing things in Bash. Sed is more powerful than tail, but in this case, tail is fast, does what I want, and it's readable, so I chose it over sed. Now exit by pressing escape:*Q, ! And hitting enter. Now let's run the script a couple of times to see what the output is. Type in ./userlog.sh and hit enter. Bring your line back, run it a second time, bring your line back, and run it a third time. Now let's look at the output file, which should be in our home directory. Type in cat:/userlog.txt and hit enter. We can see that we have the date and hostname on the first line, and then indented is the table header, and then the user information. The next step would be to create a cron job to run the script automatically. Either we could create a system-wide cron job in /etc/crontab, or we could run the crontab-e command as root, and it will run as the root user. This would be useful if the log file was stored in a location that only root could write to. We could also schedule our task as a user such as user1, but the log file would have to be stored in a directory that user1 can write to. Just for the purpose of this exercise, let's create a root cron tab entry by elevating privileges using sudo. First, let's copy the userlog.sh file to /root/bin. Type in clear, and type in sudo space cp space userlog.sh space /root/bin and hit enter. Type in your password if prompted. Now let's create the cron tab. Type in sudo space cron tab space -e for edit and hit enter. Go into insert mode by pressing the I key and type in */10 for 10 minutes, space asterisk space asterisk space asterisk space asterisk. And for the command, type in space /root/bin /userlog.sh. That's the location where we copied it to. This will run the script every 10 minutes of every hour of every day of every month. You may want to adjust this depending on your needs. Save and exit by pressing escape:*X and hitting enter. By default, the script writes the log entries to the user's home directory. In our case, it would write to /root since we're a root. So you may want to change this in the script to /var/log. This basic process can be used for other automation scripts as well. You can change the data gathering section to use any command you wish. It could get user information, disk usage, dropped firewall packets, Apache access hits, or really anything. The rest of the process is the same. The last step would be to make the script react to those conditions either by texting, messaging, or emailing the administrator, or even reacting to the condition itself. I'm going to leave this up to you, the viewer, to explore. This chapter covers creating an iSCSI Storage Area Network, or SAN. In this chapter, we'll create the initiator and backstore. Then we'll create the logical unit number, or LUN, configure access control on the initiator itself as well as through the firewall, and then lastly, we will ensure that the target will mount automatically on boot. To install the iSCSI target and initiator packages, make sure both RHOST1 and RHOST2 VMs are booted. Different packages need to be installed on the iSCSI target and iSCSI initiator hosts. For the target, we will install the target CLI package on RHOST1. This will also install any package dependencies it may have. The target CLI package implements the open source Linux IO iSCSI target in the kernel and replaces the iSCSI target utils package that was used on Enterprise Linux 6 and earlier. To install target CLI, log into RHOST1 and open a terminal. Then type in sudo space dnf space install space -y space target CLI and hit enter. To ensure that the changes made in target CLI are persistent, we need to start and enable the target service. To start the target service, type in clear, and then type in sudo space systemctl space start space target and hit enter. To make the target service persistent, bring your line back and replace start with enable and hit enter again. Now, to install the initiator on the client, log into your RHOST2 VM. For the initiator, the software hasn't changed. We'll install the same package that was used on Enterprise Linux 6 and 7. It provides the iSCSI admin command. To install it, type into a terminal sudo space dnf space install space -y space iSCSI -initiator -utils and hit enter. This may already be installed in your configuration. If so, you can proceed. To start the iSCSI D service, type in clear, then type in sudo space systemctl space start space iSCSI D and hit enter. Let's also make it persistent by bringing our line back and changing start to enable and hitting enter again. In Enterprise Linux 8, by default, the iSCSI service is started only when used. If the root partition is not on an iSCSI device, or there are no nodes marked to start automatically, then the iSCSI service does not run at boot. If, however, we want to force the iSCSI D service to run and the iSCSI kernel modules to load at every boot, we'd use the systemctl force-start option. We're not going to utilize this option at this time. A second manager service exists called iSCSI.service that takes care of starting the iSCSI D service if necessary and unmounting devices. We want to start this service as well. To start the iSCSI service, type in clear, type in sudo space systemctl space start space iSCSI and hit enter. And to make it persistent, bring your line back and change start to enable and hit enter again. Now we have the target running on RHOST1 and the initiator running on RHOST2, so we can proceed. In Enterprise Linux 6, the term backing store was used for mappings created in the target. These are now called storage objects. In Enterprise Linux 7, we use the term backstore to reference different types of backing devices such as block devices and logical volumes. Backstores supported by the LIO iSCSI target include file I/O, block, PSCSI, and memory copied RAM disks. File I/O backstores are Linux file-backed storage. File I/O can be either write-back or write-through. Using write-back enables the Linux file system cache, which can improve performance. However, it also increases the likelihood of data loss, so write-through is recommended. To create a file I/O backstore, we'd use the /backstores/file I/O path with the create subcommand. We can disable write-back by adding the write_back equals false option for the device. Block backstores can be any block device that exists in /sys/block. This includes physical devices such as hard disks, solid-state disks, optical drives like CDs and DVDs, as well as RAID and LVM volumes. To create a block backstore, we'd use the /backstores/block path with the create subcommand. In this example, we're using the /dev/SDB block device to back it. The PSCSI devices are SCSI devices that are passed through. Any storage device that supports direct pass-through of SCSI commands without emulation and also has a device that exists in /proc/SCSI/SCSI can be used for this backstore. To create a pass-through backstore for our DVD drive, we'd use the /backstores/PSCSI path and specify the backend device of /dev/SR0. Due to the complexities with passing through SCSI commands to a device, it is recommended to use a block backstore if possible. In some cases, the complexity of SCSI pass-through is warranted. We can also create memory-backed RAM disk backstores. These are images in RAM which are usually not persistent across reboots, but are very fast. This allows us to have RAM disks with full SCSI emulation, which is good for very fast volatile mass storage when high IOs are needed. To create a memory-backed RAM disk backstore, we'd use the /backstores/RAM disk path and specify the size. To see how backstores work, let's create a file I/O backstore. Be sure that your RH host 1 VM is booted and you're logged in. In a terminal, run target CLI by typing in sudo space target CLI and hit enter. Type in your password if prompted. We'll start by listing all existing objects by typing in ls. We can see that we have no backstores, storage objects, or targets. To create the file I/O backstore, type in /backstores/file IO space create space file1, that's the name of it, space /tmp/disk1.img. This is the file on the drive that's going to back this backstore. Space 200 capital M, that's the size, space write_back equals false, and hit enter. In this case, we've turned off write-back, which is recommended. To view our backstore, type in ls and hit enter. Now we can see that we have a file I/O backstore named file1 that exists at /tmp/disk1.img. In the rest of this chapter, we'll create the other components as necessary. Previously in this chapter, we created a file I/O backstore. Let's verify this before moving on. Make sure your RH host 1 VM is booted and you're logged in. In a terminal, run target CLI using sudo. Type in sudo space target CLI and hit enter. Type in your password if prompted. If it's already running, you can skip this step. Now type in ls to verify that the backstore exists. Type in ls and hit enter. We see the file I/O based backstore, but no targets, LUNs, or ACLs. Let's create a target now. First, let's move to the iSCSI directory. Type in cd space /iSCSI and hit enter. Type ls to see a brief output showing only targets. In this case, we don't have one yet. Now create a target with the create subcommand. Type in create and hit enter. We see output on the screen telling us that it created a target with a very long name. It also created a target portal group. If you're using Enterprise Linux 7.1 or newer, it automatically creates a portal when you create a target. If you're using an older version, you'll need to create a portal manually. We will not cover creating portals in this course. Let's also see what this looks like in the hierarchy using ls. Type in ls and hit enter. We see that we have a target portal group, a portal but no LUNs or ACLs. If we want a target name that means more to us, we can specify it when we create it. Let's create a new target and specify the name this time. Type in create space iqn.2018-04.com.localnet : file disk1 and hit enter. We use the domain name for this course, which when reversed is com.localnet. Lastly, following an optional colon can be a string of characters containing an identifier. This identifier might be the product type, serial number, host identifier, or even a software key. In fact, it could be anything the administrator wants in order to identify the target. Note that the string can include most characters, including other colons. In this example, I chose to keep it simple and used file disk 1. The structure for the IQN is defined in RFC 3720 if you'd like to read more. To view the hierarchy again, type in ls. We can see that we now have two targets, the auto-created one and our user-defined target below that. Since we only need one target, at this point let's delete the auto-named one. Highlight the target name and copy it, and then type in delete, space, and then paste in the name, and hit enter. We can verify this with ls. We now have one target that we defined with a name that is unique but easy to understand. Now we need to create a LUN for the file IO backstore in our target. Be sure that you are logged into your RHOST1 VM and have a terminal open. Run target CLI by typing in sudo space target CLI. We need to go to the root, so type in cd space /. Verify that we have the backstore from a previous video in this chapter as well as the target by typing in ls. If you have both, you can continue on. Now we have to change into the target directory. You can use tab completion in target CLI, which can be very handy when dealing with long paths. Type in cd space /iSCSI /IQN and then hit your tab key. Now add in tpg and hit your tab key again. In my case, the entire line would read /iSCSI /IQN.2018-04.com.localnet : file disk 1 /tpg1 and hit enter. If your target name is different, be sure to enter the correct one here. Now that we're in our target portal group directory, we can create our LUN for our file IO backstore. Type in luns / create / backstores and then hit your tab key and it should fill out the rest of the line. And hit enter. Now let's verify with ls. Type in ls and hit enter. We can see that we now have a LUN for our target. The only thing we don't have at this point is an access control list, which we'll take care of in a later video. If you mess anything up, you can just use the delete subcommand followed by the name of the object, so don't worry. In previous videos of this chapter, we created a backstore, a target, and a LUN. Now let's create an access control list. Be sure you're logged into your RHOST1 VM and you have a terminal open with target CLI running as root. If you haven't done this, type in sudo space target CLI and hit enter. Let's also verify our progress. Go to your target CLI root by typing in cd space / and hit enter. And then type in ls. You should see our file IO backstore named file1. You should also see a target named IQN.2018-04.com.localnet : file disk 1, which has a LUN and a portal. The latter was auto-generated because we're using a version of Enterprise Linux newer than 7.1. Now let's cd into our target's target portal group. Use tab completion for this by typing in cd iSCSI /IQN, hit your tab key, and add tpg1 to the end and hit enter. Type in pwd to verify where you are. You should be in /iSCSI /IQN.2018-04.com.localnet : file disk 1 /tpg1. If so, we can continue. To create an ACL, we'll specify the ACL's /path, the name of the target, and identifier. Type in ACL's / create IQN.2018-04.com.localnet : client1, which is the identifier for our ACL, and hit enter. Type in ls to verify. We can now see that we have an ACL for our target. Remember this ACL path as we'll need it in the next video. We have not set access control yet. Now to set access control, we need to change into our new ACL's IQN directory. Once again, we'll use tab completion. Type in cd space ACL's / and hit your tab key, and then hit enter. Type in pwd to verify where you are. We're inside the ACL's IQN directory, which is inside the iSCSI target IQN directory. Now let's set some access control. We'll set a user ID and a password. First, let's set the user ID. Type in set space auth space user ID equals user1 and hit enter. Now let's set a password. I'm choosing a super simple and insecure password here for testing purposes. You will want to set a more secure password in production. Type in set space auth space password equals password and hit enter. Once again, use a stronger password for production. To verify what we did, let's cd up 2 levels. We can use a relative path just as we would on the Linux command line. Type in cd space // and hit enter. Let's verify our path by typing in pwd. This will take us up 2 levels to our target portal group directory. If your path doesn't match mine, then fix it now. Now let's get the hierarchy view by typing in ls. Here we see our target, its LUN, portal, and access control list. Now we can quit target CLI. It's important to exit properly as target CLI saves its configuration when the user leaves. If you do not properly exit target CLI, the configuration can be corrupted. To exit, type in exit and hit enter. Type into a terminal sudo space netstat space -at and hit enter. Type in your password if prompted. Here we can see that the iSCSI target is listening. If you want to see the port number it's listening on, add -n to netstat. So bring your line back and make the options -a and t and hit enter. We can see that it's port 3260. To allow traffic for port 3260, we will add the iSCSI target service to our firewall rules. Type in clear, type in sudo space firewall -cmd space -- space -- add -service space iSCSI -target and hit enter. If you're using Enterprise Linux 7.1 or older, this service doesn't exist and you'll need to specify the port directly. Now we need to reload the firewall rules for this to take effect. Type in sudo space firewall -cmd space -- reload and hit enter. Now we should be ready to connect our initiator to our target. For this video, you need to have both your RHOST1 and RHOST2 VMs booted up. You should be logged into your RHOST2 VM with a terminal open. To set up our initiator, we need to start by editing an iSCSI config file. Type into the terminal sudo space vi space /etc /iSCSI /initiator.iSCSI and hit enter. Type in your password if prompted. Now go into insert mode by pressing the I key and then change the initiator name to iqn.2018-04.com.localnet:/client1, which we set in a previous video when configuring our access control list. Now save and exit by pressing escape:*x! And hitting enter. Since we also added a username and password on the target, we'll need to edit a second file. Type in sudo space vi space /etc /iSCSI/iSCSID.conf and hit enter. In this file, we need to edit lines for authentication mode, username, and password. By default, the system runs in demo mode with authentication turned off. We want to switch it to challenge handshake authentication protocol mode so we can provide a username and password. Go into insert mode by pressing the I key and then find the auth method line and uncomment it. Also, make sure the value is chap. Now look below it and find the username line. Uncomment it and change the username to user1. Below that is the password line. Uncomment it and change the password to the one you chose. In my case, I chose password. Save and exit by pressing escape:*x! And hitting enter. Since we've changed our IQN settings in our initiator, we will want to make sure that the iSCSI and iSCSID services have been restarted so they use the current IQN information when logging in. Type in sudo space systemctl space restart space iSCSI and hit enter. And then bring your line back and change the service name to iSCSID and hit enter again. Now let's use discovery mode on the IP address of RHOST1. Type in clear, then type in sudo space iSCSI admin space -- mode space discovery space -- type space send targets space -- portal and the IP address of your RHOST1. For me, it's 192.168.3.115 and then hit enter. The output of this will show a few things including the portal address and the target IQN. Copy the IQN by right-clicking on it and selecting copy. Now let's use this information and try to log in. Type in clear again, Type in sudo again, then type in iSCSI admin, space -- mode, space node, space -- target name, and then paste in the IQN, space -- portal, space, and then the IP address of your RHOST1, -192.168.3.115, space -- login, and hit enter. If the previous steps were successful, you should have a new SCSI block device. To check the local SCSI block storage, we'll use lsblk. Type in clear and then type in sudo space lsblk space -- SCSI and hit enter. If all goes well, you should see an extra drive with the vendor being lio-org, which tells us that it's an LIO iSCSI device. Note the block device name. In my case, it's SDB. To verify that it's not in read-only mode, let's use lsblk again. Type in clear and then type in sudo space lsblk space pipe space egrep space double quote uppercase name pipe SDB double quote. If your block device name is different than mine, you'll want to insert that here instead of SDB. Now hit enter. Under the RO column, if the value is 1, then it's read only. If it's 0, then it's not. Mine is set to 0, so this device is read-write. Let's talk for a moment about troubleshooting. If you've done these steps out of order, you may not be able to log in. For instance, if you change the authentication at the target after you did the discovery, it won't work as the initiator caches the old credentials. To resolve this problem, you can delete the old credentials and then redo the discovery step above. This should solve that problem. Also, if you want to verify the username and password on the initiator, you can have the iSCSI admin command show that information. Type in sudo space iSCSI admin space -m space session space uppercase P space 2 space uppercase S. The -P2 is the print level and the -S is to show secrets. If you want to log out so you can change parameters and then log back in, bring back the login line and change the --login parameter to --logout. You can verify that you're logged out by bringing back your session line and running it again. We now have an iSCSI exported block device available on our initiator. Whenever we want to access it, we just need to log in using the iSCSI admin login command that we typed in earlier. Bring your --logout line back and change it to --login. And hit enter. This will set us up for mounting the drive later. Now that we have our drive exported from RHOST1 and accessible on RHOST2, we will put a partition on it, format it, and mount it by a UUID number. In order to do this, make sure your RHOST2 VM is booted and you're logged in. Also make sure your RHOST1 VM is running as well. Let's also verify that we still have access to the iSCSI drive. In a terminal, type sudo space lsblk space --SCSI and hit enter. If you see the iSCSI device, you can proceed. If you do not see it, you'll want to go back to the previous video and follow the steps in logging into the target. My device is /dev/SDB, but if yours is different, take note of that now. The device name is only important temporarily. It's not recommended that you use device major minor numbers or device names such as /dev/SDB when mounting iSCSI devices. These names can change depending on different factors. We will address our drives by UUID later. Let's begin by adding a partition to our drive and formatting it. Type in clear and then type in sudo space gdisk space /dev/SDB and hit enter. Press N for new partition, accept the default for partition number, first sector, last sector, partition type, and then press W to write. Press Y to proceed. Now type in clear and then verify this with lsblk. We can see that we now have a /dev/SDB1 drive. Now let's format it with the ext4 file system. Type in clear again, then type in sudo space mkfs.ext4 space /dev/SDB1 and hit enter. Once the formatting is done, let's get the UUID of the file system. Type in clear, then type in sudo space blkid space /dev/SDB1 and hit enter. Here we see our UUID name. Because it's long, we will want to copy and paste it. We can pass this argument to mount or even put it in the etcfs tab for automatic mounting if we wish. Let's create a mount point first. Type in clear and then type in sudo space mkdir space /mnt/filedisk1 and hit enter. I like to use the name with a target identifier so it's easier to associate them, but you can use anything you wish. Now let's mount it by UUID. Type in sudo space mount space and then paste in the UUID space and then type in the mount point, which in my case is /mnt/filedisk1 and hit enter. Be sure that this mounts properly before moving on. We can verify with lsblk. Now let's add an entry to the /fs tab. Type in sudo space vi space /etc/fs tab and hit enter. Go into insert mode by pressing I and then go to the very last line and add a new line. For the device, we'll want to paste in our UUID again, space, the mount point is /mnt/filedisk1, space, the file system is ext4, space, the file system option is _netdev. The reason for this is that it tells Linux to wait for the network to come up before trying to mount it. If this option doesn't exist, then the boot process may halt if the network isn't available, which includes maintenance mode. For backup and restore and file system check columns, we can add 0 space 0. Save and exit this by pressing escape, :x, ! and hitting enter. Now let's test it. Let's umount /mnt/filedisk1 and then mount it back up with mount-a. Type in clear, type in sudo space umount space /mnt/filedisk1 and hit enter. This will unmount the device, and then type in sudo space mount-a, which will mount it back up based on information in the /etc/fs tab. To verify that it is working, type in lsblk and hit enter. If it mounts back up, we're in good shape. Keep in mind that if you're going to reboot either of these machines, you need to shut down the initiator first, or the initiator needs to log out of the target. If you shut down the target first, then its drive will be pulled out from under the mount point on the initiator and can halt the initiator from being able to reboot. This challenge concerns iSCSI targets and initiators. For this challenge, you will need to create a 500 megabyte file I/O backstore called challenge1. Be sure write back for the backstore is turned off. Create a target named iqn.2019-06.com.localnet:challenge1. Create an ACL named iqn.2019-06.com.localnet:rhost2. Set up a user and password for the ACL. Configure the initiator on rhost2. Be sure the initiator authenticates with a challenge response mechanism. And lastly, configure rhost2 to mount the iSCSI target automatically by UUID. To satisfy the challenge objectives, we first have to install software on rhost1. We'll install the target CLI package by typing in sudo space yum space install space -y space target CLI and hit enter. Now let's start the service. Type in sudo space systemctl space start space target and hit enter. And bring your line back and change start to enable to make it persistent. Now let's create a directory for our file I/O backstores. Type in clear and then type in sudo space mkdir space /usr/backstores and hit enter. Now let's run target CLI. Type in sudo space target CLI and hit enter. Create the target by typing in /backstores /file IO space create space challenge1 space /usr/backstores /challenge1.img space 500 capital M space right _back equals false. Now let's create the target. Type in cd space /iSCSI and hit enter. Now type in create space iqn.2019-06.com.localnet:challenge1 and hit enter. Now let's create the LUN for our target. First, let's go into the iqn directory. Type in cd space iqn.2019 and tab, then type in tpg and hit tab again. Now let's create the LUN. Type in luns /space create space /backstores and then hit your tab key and hit enter. Now let's create the ACL. Type in ACLs /space create space iqn.2019-06.com.localnet:/. rhost2 and hit enter. Now we'll create the user and password. Type in cd space acls/iqn and hit your tab key and hit enter. Now let's create the user. Type in set space auth space user ID equals user1 and hit enter. And we'll give it a password. Type in set space auth space password equals and then enter a password. I'm just going to go with password for this example. Type in enter. Now type in exit to quit. Now let's create a firewall rule to let the initiator traffic in. Type in clear and then type in sudo space firewall-cmd space -- permanent space -- add - service equals iSCSI - target and hit enter. Then reload the firewall rules by typing in sudo space firewall-cmd space -- reload. Now our target is set up. Now switch over to your rhost2 VM and install the initiator packages. Type in sudo space yum space install space -y space iSCSI - initiator - utils and hit enter. As soon as that's installed, start the services. Type in sudo space systemctl space start space iSCSI and hit enter. Then bring your line back, add a D to the end so it says iSCSI D and hit enter again. Now let's make them persistent by bringing your line back and changing start to enable. And once again, bring the line back and change iSCSI to iSCSI D again. Now we need to edit the initiator name. Type in clear and then type in sudo space vi space /etc/ iSCSI / initiator name.iSCSI and hit enter. Change the initiator name to iqn.2019-06.com.localnet:/rhost2 and then save and exit by pressing escape :x and hitting enter. Now let's edit the iSCSID.conf file. Type in sudo space vi space /etc/ iSCSI / iSCSID.conf and hit enter. We need to turn on CHAP authentication. Search for CHAP by typing in / CHAP and hitting enter. What we're looking for is the node.session.auth.auth method equals CHAP. Uncomment that. Down below that is node.session.auth.username equals username. We're going to uncomment that. We're going to go into insert mode by pressing I, and we're going to change the username to user1. The next line down is the node.session.auth.password line. We're going to uncomment that and change the password to the password that you set. In my case, it's PASSWORD, so I'll leave it alone. Now save and exit by pressing escape :x and hitting enter. Now let's restart the services. Type in sudo space systemctl space restart space iSCSI. Bring the line back, add a D to it so it says iSCSI D and hit enter again. Now let's discover using the IP address of rhost1. In my case, this is 192.168.1.08. You will want to use your rhost1 IP address here. Type in clear and then type in sudo space iSCSI ADM space -- mode space discovery space -- type space send targets space -- portal space your rhost1 IP address. In my case, it's 192.168.1.108 and hit enter. The output of this will show a few things, including the portal address and the target IQN. Now let's try to log into the target. Type in sudo space iSCSI ADM space -- mode space node space -- target name space iqn.2019-06.com.localnet:/challenge1 space -- portal space the rhost1 IP address, which in my case is 192.168.1.108 space -- login and hit enter. To verify, type in sudo space lsblk space -- SCSI and hit enter. Here we should see our local iSCSI block device now. In my case, it's SDA. Now we need to create a partition, format, and mount it. Type in clear, and type in sudo space gdisk space /dev /SDA in my case, and hit enter. To make a new partition, press N and hit enter. And then take the default by hitting enter, take the default, take the default, take the default. Now press W and Y. This created a new partition that takes up the whole drive. Now let's format the partition. Type in clear, and then type in sudo space mkfs space -t space ext4 space /dev/sda1 and hit enter. Now we need to get the UUID of the file system. Type in clear and then type in sudo space blk id space /dev/sda1 and hit enter. We want to copy the UUID equals section of this line into the clipboard. Now let's create the mount point. Type in sudo space mkdir space /media /challenge1 and hit enter. And the last thing that we'll do is edit the FS tab so it mounts at boot. Type in sudo space vi space /et/fs tab and hit enter. Press capital G to go to the last line and capital A to go to the end. Hit enter. And then we're going to paste in the UUID line. Space, the mount point, which is /media /challenge1. Space, the file system, which is ext4. Space, the file system options, which are going to be _netdev. Space 0 space 0. Save and exit by pressing escape:*x and hitting enter. Now let's mount it from the /etc/fs tab. Type in sudo space mount space -a and hit enter. And we can verify with lsblk. And there we have it. If it mounts up automatically, then you've succeeded. The last step is to reboot to be sure. This chapter covers creating an NTP server and configuring the NTP client. As such, in this chapter, we perform the following steps. We install and configure NTP services. We configure the cronny server. We configure the cronny client. We configure the time and date. And then, we use the cronny client. It would be unfortunate to brush off this chapter as a fairly minor topic, as it may not seem that important to have perfect time on a server. But there are several reasons why you might want to work through this chapter. NTP is often an objective on certification exams. Also, in order to have reliable centralized authentication with LDAP and Kerberos, which we'll cover in the next chapter, the time has to be identical on all hosts in the network using these services. If it is not, employees and possibly your boss will not be able to log in. For this exercise, be sure you're logged into RHOST1 as user 1 and have a terminal open. The cronny server and client should already be installed by default, but to be sure, type into a terminal sudo space yum space install space -y space cronny and hit enter. This will not hurt anything if it's already installed. After making sure cronny is installed, we need to make sure the service is running. To do this, we'll use systemctl. Type in clear and then type in sudo space systemctl space status space cronny d and hit enter. This shows our cronny d service status. Mine is running, but if it was not, I would want to start it by typing clear and then typing sudo space systemctl space start space cronny d. And to make it start automatically at boot, I'd bring my line back and change start to enable. Again, this will not hurt anything if it's already running and persistent. Now cronny d will start when the system boots up. The cronny package includes the cronny d NTP time server. Cronny d by default only accepts time queries from the local client. The cronny d server can serve up time information to clients as well as allow a client to connect to it to control it. Both are configurable independently. The cronny d server by default allows connections using local Unix domain sockets. It can optionally be configured to allow connections using IP version 4 or IP version 6. The cronny package includes two pieces of software: the cronny d server, which we've already discussed, and a command line client called cronny c. Cronny c can be used to query the local time server and also can be configured to query other remote time servers if needed. If our cronny d server is configured properly, we can also use cronny c to control our time server remotely. To configure your cronny server to accept local requests, you'll need to know your IP address. Make sure you're logged into your RHOST1 VM with a terminal open. In the terminal, type in ifconfig and hit enter. You can also use IP space ADDR as well, but I find the output of the legacy ifconfig command easier to read. I can see that my IP address is 192.168.3.115 and my network mask is 255.255.255.0. That makes my network address 192.168.3.0. We need to remember this for later. For this exercise, we'll configure cronny d to accept network time requests from clients on the local network. For this, we'll configure cronny d and open a port in the firewall. To configure cronny as an NTP time server, we'll want to edit the cronny.conf file. Let's do this with vi. Type in clear and then type in sudo space vi space /etc /cronny.conf and hit enter. Type in your password if prompted. Comments start with a hash, %, or exclamation mark. The first non-commented line may be the server line or pool lines. If the keyword is pool, then the line specifies a pool of NTP servers as a time source. This pool name will resolve to multiple servers, which may change over time. At startup, cronny will get a list of sources from the pool. If a source is unavailable, it will attempt to replace it with another. In your case, you may not have a pool line, but may have multiple server lines. The server keyword specifies a specific server instead of a pool. Using the server keyword, we could direct all NTP client requests on the local host to a specific time server. The next line is the location of the drift file. This file stores the rate in which the system clock gains or loses in relation to real time. This is stored to allow cronny to adjust a clock before a reliable source is established. You should not have to do anything with this file or configuration line. The next line starts with make step. This determines if cronny can step the time if the time is too far off to adjust via speeding up or slowing down the clock frequency. My line says make step space 1.0 space 3, which would allow stepping the clock if the adjustment is more than 1 second off, but only in the first 3 clock adjustments. Now let's jump down to the min sources line. This is the number of NTP sources needed before adjusting their local clock. The default is 1, but if we want to make our local time more reliable, we may require more than 1 source. These sources would have to agree before our local clock is adjusted. The allow line is what turns our cronny installation into a time server for other hosts on our network. It's commented out by default. Let's uncomment this line and change it to our local network address. Go into insert mode by pressing the I key, and then uncomment the line. Now change the network address to yours. In my case, it should say 192.168.3.0/24. This is because my local network address is 192.168.3.0 and my subnet mask is 255.255.255.0 or 24 bits. The allow keyword allows NTP access. We can also allow cronny C to control cronny D by using the cmd allow keyword in the same manner, which we will not cover in this course. The local line below allows us to use cronny to serve up time to our local network without being connected to a time server. This is useful if our network is isolated. If we wanted to specify a peer host to synchronize time to, we'd use the peer keyword followed by the IP address of the peer. We'd also add peer to the other host configuration file pointing back to this host, so both hosts would synchronize with each other. Note that we can specify a server, a pool, a peer, and even local in one file. Cronny will fall back to peer and local if remote time sources aren't available. Now that we've modified this file, let's save it by pressing escape:*X, ! And hitting enter. Now we need to allow external NTP requests to our service by opening a port in the firewall. Type in sudo space firewall-cmd space --permanent space --zone equals public space --add-service equals NTP and hit enter. Type in your password if prompted. In most installations, the public zone is default, so you wouldn't have to add it here. However, if we had a firewall D zone for the internal network and a firewall D zone for the public network, and we only wanted to allow queries on the internal network, we'd add the service to that zone only. To verify that our service has been added to the zone, let's reload the firewall configuration. Type in sudo space firewall-cmd space --reload and hit enter. And then to list, bring your line back and change reload to list-all and hit enter again. Here we see that the NTP service is allowed in our public zone. Now restart the cronny service. Type in sudo space systemctl space restart space cronny D and hit enter. Your time server should be ready to serve up time information to clients now. Now that we have our RHOST1 VM configured to be an NTP time server, let's go to our second VM and configure it to use our time server. Log into RHOST2 and open a terminal. Now let's edit the cronny.conf file using vi. Type in sudo space vi space /etc /cronny.conf and hit enter. Type in your password if prompted. Going to Insert Mode by pressing the I key. And comment out any pool or server lines. Now we'll add one server line to point to our time server on RHOST 1. In my case, it would say server space 192.168.3.115 space iBurst. Use the IP address of your RHOST 1 VM in your file. Now save this by typing escape:x and hitting enter. Now restart the cronid service. Type in sudo space systemctl space restart space cronid and hit enter. Let's ensure our RHOST 2 VM is configured to use NTP by using the timedatectl command. Type in sudo space timedatectl space set-ntp space true and hit enter. To test that our system is synchronizing with our time server, type in sudo space cronc space sources space -v. The -v option tells us what each column is for. The first character says this host is a server, and the second character is an asterisk, showing it's synchronized. We'll be configuring the NTP client on RHOST 1 for this exercise. The steps will be exactly the same for any other hosts. We already have the cron package installed, but if you're doing this exercise on a new host, be sure to install cron first. It's desirable to have all server times synchronized on our network. To set this up, we'll use timedatectl with a set-ntp boolean. In a terminal, type in timedatectl space set-ntp space true and hit enter. Verify by running timedatectl again. Notice that NTP enabled is yes. If NTP synchronized is no, we have to restart the NTP client to synchronize. Type in clear, and then type in sudo space cronec space tracking, and hit enter. The reference ID is the computer at which cron is currently synchronized to. The reference time is when the time was last processed from the source. The system time may be different from the actual time. Cron doesn't change the time, but rather speeds up and slows down the system clock until the two are synchronized, so there's no jump in time. The frequency is the amount the system clock would be wrong if cron wasn't correcting it. You can check the cron sources by typing in clear and then typing sudo space cronec space sources space -v. The -v provides more caption information. The sources subcommand shows information about current time sources. The leftmost character under the capital M is the source mode. It will be a caret if the source is a server, an equal sign if it's a peer, and a hash if it's the local clock. The second character shows the state of the source. It will be an asterisk if it's synchronized. The rest of the columns provide valuable source information. Refer to the verbose output on the screen for more information. If you want drift and offset information for sources, use the source stats command. Type in clear and then type in sudo space cronec space source stats and hit enter. If the cmd allow option is provided in the time service cron.conf file, we can allow cronec to control our time server. Note that any configuration change through cronec is not persistent. We will not be covering the cmd allow option in this course. This chapter covers secure directory services using lightweight directory access protocol and Kerberos. As such, we'll be creating an LDAP server and using Kerberos to authenticate. In this chapter, we perform the following steps. Install and prepare the LDAP server. Configure the LDAP server. Set up the LDAP database. Create an LDAP user. And install and configure the LDAP client. OpenLDAP was the included LDAP server in both Enterprise Linux 6 and 7. However, Red Hat has removed the OpenLDAP server in Enterprise Linux 8.1 and newer. Red Hat now encourages people to use their Red Hat directory server, which is a commercial version of the 389 directory server, and can only be purchased through a subscription. OpenLDAP, however, continues to be a great option, so for this course, we'll configure third-party repositories for OpenLDAP packages. You have two choices of Yum repositories that contain OpenLDAP. The first is SciMass, which is a third-party company that delivers open-source identity and access governance and storage solutions along with support. And the second is the LDAP Toolbox project. For this course, we'll be using the SciMass repository because the package names closely mirror the Enterprise Linux 6 and 7 package names, making it easier to follow along for users of those operating systems. By the way, we're going to be using our fully qualified domain names in this chapter. Be sure to add lines to your Etsy host file in both RHOST1 and RHOST2. Also make sure that you insert the IP addresses of your RHOST1 and RHOST2 VMs, and don't use mine. By doing this, we can use the fully qualified domain names instead of IP addresses. Now, let's install the packages. First, we need to download the yum repo file. To do so, open a terminal on RHOST1 and type in sudo space wget space -q space https://configs/uppercase SOFL/RHEL8/SOFL.repo. That's the file we'll download. Space -uppercase O space, and we're going to save it in /etc/yum.repos.d/SOFL.repo and hit enter. Once we have our repository set up, we can move on to installing the packages. There are multiple packages necessary for a basic OpenLDAP server. OpenLDAP, which is the base package, OpenLDAP-clients, which provides client commands, and OpenLDAP-servers, which provides server commands. Optional packages are NSS-PAM-LDAPD, which provides an LDAP name service that allows users to do local queries, and mod_LDAP, which provides LDAP authentication abilities to the Apache web server. Our package names will differ slightly because we're using a third-party repository, and the names are changed to avoid conflict. As for the command naming schemes, server commands start with SLAP, and client commands start with LDAP. So keep this in mind as we use the commands later. Now, let's update the package cache. Type in sudo space dnf space check -update and hit enter. And then install the packages. Type in clear and then type in sudo space dnf space install space -y space SciMass -openldap -clients space SciMass -openldap -servers space oddjob -mk homedir and hit enter. The last package is needed to create home directories on the fly. If you happen to be using the older Enterprise Linux 7 for these exercises, you would install OpenLDAP-clients and OpenLDAP-servers without the SciMass prefix. Now that we have the OpenLDAP packages installed, we need to set up the services. First, let's set a couple of SE Linux booleans to allow our system to use LDAP. Type in clear, then type in sudo space set SEBool space -P space allow _ypbind equals 1 and hit enter. For the second boolean, type sudo space set SEBool space -P space auth login _NSSwitch use LDAP equals 1 and hit enter. Now let's start the LDAP service. Type in sudo space systemctl space start space slapd and hit enter. Remember that server commands start with slap. To make the slapd service persistent, bring your line back and change start to enable and hit enter again. You may see an SE Linux alert pop up. This won't affect the service running, but if you want to resolve it, click on the pop-up and follow the instructions. To verify that the service is running and listening on port 389, use the ss command. Type in clear, then type in ss space -lntu space pipe space grep space 389, which is the port number, and hit enter. You can also use the legacy netstat command, but you will have to install it. We also want to start the oddjob service for automatic home directory creation when users log in. Type in clear, then type in sudo space systemctl space start space oddjob d and hit enter. And then to make it persistent, bring your line back and change start to enable and hit enter again. Although we can provide all configuration data to these commands on the command line, it's usually easier to create an LDIF file and load it. This LDIF file specifies the database and the operations. When we load it, the operations are carried out. In this course, I provide LDIF files and load them for as many tasks as possible. On occasion, we'll provide arguments on the command line when appropriate. There are many tutorials on the internet instructing users to edit the LDAP configuration files directly. This is not recommended, and in fact, most files warn against it. In the beginning of this course, you should have downloaded the exercise files zip archive onto your RTrust1 VM and extracted it to your home directory. The directory for this chapter will contain various LDIF files. In a terminal, change into the Chapter 5 directory and then list it by typing in ls. Type in clear, then type in cat db.ldif and hit enter. This file changes the administrator's distinguished name and sets a password. The password in this file is the word password. In a production environment, you'd want a stronger password, so let's change the password now using the slap password command. Type in clear, then type in slap, PASSWD, and hit enter. Now enter your new password twice. Now highlight the output, and then right-click and select copy. Now let's edit the db.ldif file using vi. Type in vi space db.ldif and hit enter. Go into insert mode by pressing your I key, and go down to the bottom line and replace the existing hash with the one you just copied. And then save the file by pressing escape:x, exclamation mark, and hitting enter. Please remember this password, as you'll need it again later. Now we need to load this file using LDAP modify. Type in clear and then type in sudo space LDAP modify space dash capital Y space uppercase external space dash capital H space LDAP I :// space dash F for file space db.ldif and hit enter. Type in user one's password and hit enter again. To restrict access to the LDAP admin user, we'll load the monitor.ldif file. First, let's look at it. Type in clear, then type in cat space monitor.ldif and hit enter. Now bring your LDAP modify line back and change db.ldif to monitor.ldif and hit enter. Now let's test our configuration. Type in clear and then type in sudo space slap test space -u and hit enter. If everything is fine, you'll see it in the output. Type in sudo space cp space /usr/share/ open ldap-servers /uppercase db_config.example space /var/lib/ldap /uppercase db_config and hit enter. Now change the ownership to the LDAP user and group. Type in sudo space chown space -R space LDAP :LDAP space /var/lib/ldap and hit enter. Let's clear the screen again. These files get us 3 schema files that we'll load. I will clear the screen each time to make it easier to read and troubleshoot. Type in sudo space LDAP add space -Y space uppercase external space -H space LDAP I :// space -F space /etc /open LDAP /schema /cosine.ldif and hit enter. Now type in clear, bring your line back and change cosine.ldif to nis.ldif and hit enter again. And lastly, we'll clear the screen again, bring your line back, change nis.ldif to inetorgperson.ldif and hit enter again. Now that we have a generic configuration, let's add our own directory structure. Type in clear again, then type in cat space base.ldif and hit enter. This is our base directory structure, and we're going to load it using LDAP add. Type in sudo space LDAP add space -x space -W space -D space double quote cn equals LDAP ADM, DC equals localnet, DC equals com, double quote, space -F space base.ldif and hit enter. And enter your LDAP password again. That would be the password that we set with the slap password command earlier in this chapter. Our LDAP directory is now set up. We need to create a new user now. The user we create here is the person who will authenticate from RHOST2. Before we load it, let's look at the contents. Type in cat space rhuser.ldif and hit enter. Here we can see the user specifics such as user ID, username, home directory, etc. Now let's load this file. Type in clear, and then type in sudo space LDAP add space -x space -W space -D space double quote cn equals LDAP ADM, DC equals localnet, comma, DC equals com, double quote, space dash F, space rhuser.ldif, and hit enter. Enter your password. Now enter your LDAP admin password. Our user named rhuser has been added to the directory. Now let's give it a password. For this exercise, we're going to give rhuser a password of password123. You can change this to a stronger password if you wish. Type in clear, and then type in sudo space LDAP password. Space dash S, space password123. That's the password. Space dash capital W, space dash capital D, space double quote, CN equals LDAP ADM, comma, DC equals localnet, comma, DC equals com, double quote, space dash X, space double quote, UID equals rhuser, comma, OU equals people, comma, DC equals localnet, comma, DC equals com, double quote, and hit enter. Enter your LDAP password. To verify that the user exists in the directory, use LDAP search. Type in sudo space LDAP search, space dash X, space CN equals rhuser, space dash B, space DC equals localnet, comma, DC equals com, and hit enter. If you find it necessary to delete a user, then use the LDAP delete command as shown on the screen. To ensure that our LDAP server is accessible from the network, we'll want to edit the firewall rules on our RHhost1 VM. In a terminal, type in sudo space firewall-cmd space dash dash permanent space dash dash add dash service equals LDAP and hit enter. Now reload the firewall config by typing in sudo space firewall-cmd space dash dash reload and hit enter again. We also want to set up logging for the LDAP service by editing the rsyslog configuration. Let's load the rsyslog.conf file into VI. Type in clear, then type in sudo space vi space /etc /rsyslog.conf and hit enter. Go into the insert mode by pressing the I key and go to the end of the file. Now add a line and add local4.* space /var/log/ldap.log. This will log to the /var/log/ldap.log file. Now save and exit by pressing escape, X, ! And hitting enter. Now restart the rsyslog service by typing in sudo space systemctl space restart space rsyslog and hit enter. Before we go on, we might want to ensure that our services are persistent. Bring your line back again and change restart to enable and hit enter. Now bring your line back again and change rsyslog to slapd and hit enter again. And lastly, bring your line back again and change slapd to oddjobd and hit enter one more time. Now our LDAP server is installed and configured and we're ready to connect with the client. For this video, you'll need both your RHhost1 and RHhost2 VMs running. We're going to set up the client configuration on RHhost2. Log into RHhost2 as user 1 and open a terminal. To install the LDAP client packages, type in sudo space dnf space install space -y space open LDAP dash clients space nss-pam -ldapd space oddjob -mkhomdir and hit enter. This installs the client package as well as the nss-pam -ldapd package, which is an NS switch module used to switch the system authentication to directory services, in our case, LDAP. These may already be installed, but we want to make sure. For a production LDAP system, I recommend using TLS encrypted connections to your directory servers. I will, however, leave this as an exercise for you, and for this video, concentrate on getting LDAP functional between the directory server and the client without TLS. In Enterprise Linux 7, we would have used a one-line authconfig command to configure our entire client setup. However, RedHat has removed the authconfig command and replaced it with authselect, which doesn't have the same functionality. As such, we'll configure the client manually. nss-pam-ldapd uses the /etc/nslcd.conf file for both the NSS and PAM modules. Let's edit this file by typing into a terminal, clear, and type in sudo space vi space /etc/nslcd.conf and hit enter. I'm going to turn line numbers on to make it easier for you to see where I am in the file. type in escape, and then type in set space number and hit enter. Now go down to line 18 and change the IP address to rhost1.localnet.com. Go into insert mode by pressing the I key and then type in rhost1.localnet.com. Note that your name resolution needs to be working in order for you to use the DNS name. You might want to double check by pinging rhost1.localnet.com first. Now go down to line 25. Change example to localnet. And save and exit by pressing escape X, exclamation mark, and hitting enter. There are other things we could change, including your TLS certificates and keys, but this is fine for now. Now, let's restart the LDAP client service. Type in sudo space systemctl space restart space nsl cd and hit enter. Bring your line back and change restart to enable to make it persistent. And hit enter again. We will also want to start oddjob-d. Bring your restart line back and replace NSLCD with oddjob-d. Once again, let's make it persistent by changing restart to enable and hitting enter. Now we'll create the auth select profile. Auth select will automatically update the appropriate configuration files for you, just like auth config did in Enterprise Linux 7. However, auth select does not have a profile for nss-pam-ldapd, so we need to create one. We'll do so by copying a different profile and editing it. Let's copy the SSSD profile. Type in clear, and then type in sudo space cp space -R p space /usr /share /auth select /default /sssd space /etc /auth select /custom /nsl cd and hit enter. Now let's change into it. Type in cd space /etc /auth select /custom /nsl cd and hit enter. Once we're in this directory, we need to edit 6 files for LDAP. We're going to use sed to speed this process up. Type in sudo space sed space -i for in place space single quote s for substitute /sss /ldap /g single quote space fingerprint -auth. This will change any instance of SSS to LDAP. Now hit enter and bring your line back and change the file name to password-auth and hit enter again. Bring it back again, change the file name to smartcard-auth and hit enter again. Bring your line back again and change smartcard-auth to system-auth and hit it again. One more time, bring the line back and change the file name to nsswitch.conf and hit enter. The last file is a bit different. Type in sudo space sed space -i space single quote s for substitute uppercase SSSD uppercase NSLCD G single quote space, and then type in an uppercase REQ and hit your tab key and hit enter. Now all files have been changed to use LDAP. The next thing we'll do is use auth select to choose the profile. Type in clear and then type in sudo space auth select space select space custom /NSLCD space with -mk homedir space --force and hit enter. This selects our NSLCD profile and enables making home directories automatically using oddjob-d. Now to verify that our client is contacting the LDAP server, let's request LDAP entries from it. Type in clear again and then type in sudo space get ent space passwd space rhuser and hit enter. If it's successful, you should see user information from the LDAP server. If this doesn't show the user information for rhuser, make sure you can ping rhost1.localnet.com first, and then double check the files that we've modified next. The ultimate test, however, is to ensure logins work by logging in as the LDAP user named rhuser. Instead of logging all the way out, we'll just use the su command to switch to the rhuser account. Type in su space hyphen space rhuser. Make sure you include the hyphen and hit enter. It will prompt you for the rhuser password, which we set on the LDAP server on our rhost1 VM to password 123. Type in password 123 and hit enter. If all goes well, you should be logged in as rhuser. We may see an SE Linux security message. You can access these anytime by going into Overview mode by placing your pointer in the top left-hand corner and then searching for SE Linux and hitting Enter. This will bring up the SE Linux Troubleshooter GUI. You can resolve any errors you have by following the instructions provided in the solution box. You can address these warnings anytime. For now, close this window. To configure your Kerberos authentication server, you'll need to install some packages. In your RHOST1 VM, open a terminal and type sudo space yum space install space -y space krb5-server and hit enter. Type in your password if prompted. This should install the Kerberos server and a library. To configure our Kerberos server, we need to edit the main configuration file. Type in clear, and then type in sudo space vi space /etc/krb5.conf and hit enter. Let's start by uncommenting all lines below the top line by removing the leading hash symbols. Just put your cursor over the hash symbol and press the delete key. Next, we'll change all instances of example.com to localnet.com. You can do this quickly by pressing escape %s/example.com/localnet.com and hit enter. This will search for all instances of example.com and replace them with localnet.com. Also replace uppercase example.com with uppercase localnet.com using the same method. Type escape %s/uppercase example.com /uppercase localnet.com / and hit enter. The last thing we'll do is go to the KDC line and change the value to rhost1.localnet.com. We'll also want to change admin_server to rhost1.localnet.com. Save and exit by pressing escape :x and hitting enter. The second file we'll edit is kdc.conf. Let's load this into VI. Type in sudo space vi space /var /kerberos /krb5 kdc /kdc.conf and hit enter. In this file, we want to change the realm to localnet.com, all uppercase. And then save and exit by pressing escape :x and hitting enter. The next file we'll edit is kadm5.acl. We'll load this into VI. This is in the same directory, so you can bring a line back and change the file name from kdc.conf to kadm5.acl. Once again, change example.com to localnet.com, all in uppercase. And save and exit by pressing escape :x and hitting enter. Now your Kerberos server is configured. Now let's create a Kerberos database. To do so, we'll run the kdb5_util command. In a terminal, type in sudo space kdb5_util space create space -s space -r space uppercase localnet.com. Enter your password if prompted. It will also prompt you to choose a master password. Enter it twice and do not forget it. Now let's enable and start the services. Type in clear and then hit enter. Type in sudo space systemctl space enable space kadmin and hit enter. Bring your line back and change kadmin to krb5 kdc and hit enter. This enables both the kadmin and krb5 kdc services. Type in clear, then type in sudo space systemctl space start space kadmin and hit enter. Bring back your line again and change kadmin to krb5 kdc and hit enter again. Let's now create a firewall rule to allow incoming Kerberos connections. Type in clear, and then we'll type in sudo space firewall-cmd space --zone equals public space --permanent space --add -service equals Kerberos, and hit enter. Now we need to reload the firewall config. Type in sudo space firewall -cmd -reload and hit enter. We're now going to create some new principals. To do so, we'll run the kadmin.local command. Type in clear and then type in sudo space kadmin.local and hit enter. kadmin.local is an interactive tool. Let's create an administrator user principal. Type in add prince, spelled ADDPRINC, space root/admin and hit enter. Now enter the new admin user's desired password twice. Now let's add a host principal. Type in add prince space -rand key space host/rhost2.localnet.com and hit enter. This will add a host principal for our rhost2 client VM. Now let's add a principal for our user named rhuser. Type in add prince space rhuser and hit enter. It will prompt you to set rhuser's password. Enter it twice. This is the password we'll use later to authenticate as rhuser. Now let's create a key tab file for our rhost2 VM. We'll save it in /tmp/rhost2.keytab. Type in kt-add space -k space /tmp/rhost2.keytab space host/rhost2.localnet.com and hit enter. Now let's list our principals. Type in list prince and hit enter. This shows our host principal we created for our rhost2 VM and our rhuser principal for our user, as well as the admin principal. Now type in quit to exit. Now let's copy our Kerberos configuration file and the key tab file to the rhost2 VM. Each host we want to use Kerberos to authenticate will have a copy of the Kerberos configuration file as well as a host-specific key tab file. We're going to use SCP to secure copy these two files to the /tmp directory on rhost2. Type in clear and then type in sudo space scp space /etc/krb5.conf space /tmp /rhost2.keytab space user1 at rhost2:/tmp. We have to use sudo to access the local /etc/krb5.conf file, and we want to copy the files to rhost2 as the user1 user. Hit enter. Type in yes, and then type in user1's password. That's it for the Kerberos database configuration. In the next video, we'll configure the client side. Log into your rhost2 VM and open a terminal. To configure the Kerberos client, we need to install software. In a terminal, type in sudo space yum space install space -y space pam_krb5 space krb5-workstation. Hit enter. Type in your password if prompted. Let's now retrieve the Kerberos configuration file and the host-specific key tab file that we copied to /tmp from rhost1. Type in clear and then type in cd space tmp and type in ls. Here we see the krb5.conf file as well as the rhost2.keytab file. Let's copy the krb5.conf file to /etc. Type in sudo space cp space -f space krb5.conf space /etc and hit enter. This will overwrite the base configuration file that came with the krb5-workstation package. Now we need to use the kt-util command to load the keytab file and write it out. Type in clear, and then type in sudo space kt-util and hit enter. To read the keytab file, type rkt for read keytab, followed by the path to the keytab file. In our case, type in rkt space /tmp /rhost2.keytab and hit enter. Now we're going to use wkt to write the keytab. Type wkt/etc/krb5.keytab and hit enter. While we're here, to get a list of principals, type in list and hit enter. Now let's exit by typing in quit. To configure authentication on the client, let's run the text user interface of authconfig. Type in clear, and then type in authconfig-TUI and hit enter. Type in your user password if it prompts you. You can use the arrow keys to move around and your spacebar to select and deselect items. Make sure Use LDAP under the User Information section is selected. Even though we've set up Kerberos for authentication, we'll still use LDAP for identity management. In the second pane under Authentication, select Use Kerberos and deselect Use LDAP. I'm also going to deselect Use Fingerprint Reader since I don't have one. Select Next. The next pane is where we configure LDAP. For the server, it should be ldap://rhost1.localnet.com. The base distinguished name should be DC equals localnet, DC equals com. Select Next. The next pane is the Kerberos settings. For realm, insert localnet.com in uppercase letters if it's not already there. These items may already be populated from the krb5.conf file. For KDC, make sure it says rhost1.localnet.com. For admin server, make sure it says rhost1.localnet.com. Also select Use DNS to resolve host to realms, and then select OK. To test and make sure that LDAP still works, type in sudo space get ent space passwd space rhuser and hit enter. To test authentication, we'll want to attempt to log in as the rhuser. Type in su space hyphen space rhuser and hit enter. It will prompt us for the Kerberos password we created for rhuser. If you used a different password than in the previous chapter when we authenticated with LDAP, make sure you enter the correct one now. If it's successful, it will let you log in as rhuser. This chapter covers network services. In this chapter, we perform the following steps. We learned about consistent network device naming with systemd. We then gathered network information. We configure IP version 4 addresses. We then configure IP version 6 addresses and perform basic IP version 6 troubleshooting. And lastly, we configure subnet masks. We then move on to more advanced topics. We configure interface bonding using NMCLI. We configure interface teaming using NMCLI. We then use Firewall D for packet filtering and network address translation. And lastly, we route IP traffic and create static routes. Traditionally, Linux device names started with ET80 for Ethernet devices and WLAN 0 for wireless devices. The device number was incremented for each additional device. The problem with this method is that the device numbers don't correspond to the actual locations in the computer. In the case of a server, there may be many physical network devices, and the order in which they get assigned their network device numbers may not be consistent, resulting in counterintuitive names. In Enterprise Linux 7, network device naming is handled by udev, which by default assigns names based on firmware, topology, and location information. The advantage is that names are fully automatic, predictable, and they stay fixed even if the hardware is removed or added. This allows hardware to be replaced without network cards being renamed. However, these names are not as user-friendly as the old ET80 or WLAN 0 names. For instance, the network device name on my VirtualBox VM is ENP0S3, and my wireless card name is WLP3S0. To decipher the naming conventions, we need to look at the schemes that systemd uses to name devices. Scheme 1 names devices using firmware or BIOS-provided index numbers for onboard devices. It then goes to Scheme 2, which names PCI Express hot plug devices using firmware or BIOS information. Then it goes to Scheme 3, which names devices based on physical location of the connector of the hardware. Scheme 4 uses the MAC addresses of the network card to name the interface. This is not used by default, but can be utilized by the user. Scheme 5 uses a traditional, unpredictable kernel naming scheme if all other methods fail. If a user wants static control over device naming, they can write udev rules which will override the schemes previously mentioned. It is not recommended to disable consistent device naming, as consistent naming allows traditional names such as ET80 to be used. For manual overrides of device names, the udev script @/user/lib/udev rules.d/60-net.rules looks at all interface scripts in /etc/sysconfig/network scripts for configuration files matching the network interface MAC address. If it finds a match, it names the device according to the configuration file. In this manner, we can assign static names if we want. If an interface is renamed this way, systemd won't go through the other steps according to the schemes we discussed earlier. To understand the somewhat cryptic names, use the following rules. If the interface name starts with an EN, it's an Ethernet device. If it's WL, it's a wireless device, and WW, it's a wireless wide area network device. Following the EN, WL, or WW will be characters denoting its location in the system. O if it's an onboard device, followed by the device number, such as ENO1. S if it's a hot plug device, followed by the slot number. If the PCI device has multiple functions, the slot number will then be followed by the letter F and the function. For instance, if you have a PCI Express card with multiple Ethernet devices on it, it may be ENS1F4. The EN will be followed by an X, followed by the MAC address if it's using Scheme 4. The device name could be prefixed by an uppercase P, followed by the PCI domain. This only shows if the domain is not 0. For instance, if it were an Ethernet device in PCI domain 1, it could be capital P1 ENP5S0. Usually the uppercase P isn't necessary and the interface would be ENP5S0. The lowercase p is the PCI bus number and the S is the slot number. My VirtualBox network interface device name is ENP0S3, so this would be an Ethernet device in PCI bus 0, slot 3. An Ethernet device named by MAC address would start with EN followed by an X in the MAC address. A PCI hot plug Ethernet device would start with EN followed by S in the slot number, followed by F in the function number for cards that have more than one function. Be aware that many scripts call network interfaces by names such as IP tables, firewalls, or kickstart files. If you change the name of your network interface card, you'll want to change the names in the relevant scripts. A recursive grep through all configuration files in /etc may be a good idea to find all instances of the old name, which would then need to be changed to the new name. Traditionally, Linux used the nettools commands, including ifconfig, netstat, route, arp, and iptunnel. These commands have mostly been superseded by the iproute2 suite of tools, including the IP and SS commands, as well as others. I find the syntax of the legacy tools easier to remember, but in time they may no longer be available, so it's important to migrate to iproute2. We will install the nettools package in this course, so we'll have access to the legacy commands as well as their replacements, which are installed by default. We can do this exercise on any of our virtual machines. I'm going to use RHOST1. To do so, I've logged into RHOST1 and I have a terminal open. Now type sudo space dnf space install space -y space net -tools and hit enter. When it's done installing, make sure iproute2 is installed as well. In Enterprise Linux 7 and newer, iproute2 is called iproute. Bring your line back and change nettools to iproute. And hit enter. This package should already be installed. To get IP address and network mask information using the legacy tools, we'll type in clear, and then we'll type in ifconfig, and hit enter. From this output, we can see the IP version 4 and IP version 6 addresses for all network devices. These lines are prefixed with the words inet and inet6. To show information for a specific network interface, we can provide it as an argument. Type in ifconfig space enp0s8, with enp0s8 being the name of the network card. If your network card is named something different, enter that. We can also see the network mask prefixed by the word netmask. It's interesting to note that you can give ifconfig the network mask in CIDR form, but it prints it back in dotted notation. To get IP and network mask information using the newer IP tool, type it in clear, then type in IP space ADDR and hit enter. This shows a lot of useful information in a rather cryptic form. IP shows the IP address for each network interface, as well as the netmask in CIDR form. If you want to show network information for only one device, the syntax is slightly more complex than ifconfig. Type in clear and then type in IP space ADDR space show space ENP0S8 and hit enter. This will filter the output to only the ENP0S8 interface. Perhaps the output of ifconfig is more readable than that of IP, but that same output is harder to parse in shell scripts. Using the newer IP command, we can use the route subcommand and get the default gateway. Contrary to what I said earlier about the IP command being harder to read, I think the output of IP route is more readable than the legacy route command. Let's try it. Type in clear, then type in IP space route and hit enter. The top line shows our default gateway by numeric address and which network interface it uses. Now let's look at host names. The host name is the name of the computer. Do not get this confused with a DNS fully qualified domain name, although there is a lot of overlap. There are 3 types of host names in CentOS 8, static, transient, and pretty. The static host name is the one stored in /etc/hostname and can be read with any text viewer. The transient host name is a dynamic host name used by the kernel. By default, when the system starts, it's set to the static host name, but it can be changed anytime by a user or a service such as DHCP or MDNS. The pretty host name is a free-form UTF-8 string of text that is presented to the user. The Linux hostname can be up to 64 characters in length, has to be composed of 7-bit ASCII characters, and cannot have spaces or dots. RedHat recommends both the static and transient names match the fully qualified domain name, or FQDN, used by DNS. The requirements of DNS are, however, different from those of a Linux hostname. For instance, a DNS fully qualified domain name can have multiple labels or sections delimited by dots that add up to 253 characters. It is possible to have a Linux hostname that works until we try to use it on a network by way of DNS. If in doubt, use the hostnamectl command. Hostnamectl ensures that hostnames only consist of lowercase a to z, uppercase a to z, the numbers 0 through 9, hyphens, underscores, and dots, which are used to delimit sections. Hostnames cannot, however, begin or end in a dot and cannot have 2 dots immediately next to each other. Here are some examples of valid Linux hostnames: my.server.domain.com with a capital M, my.server.domain.com with a capital MY, my-server.domain.com, and my_server.domain.com. Note that hostnamectl will allow an underscore in the hostname, but DNS will not, so be careful. To show just a hostname, we can use a legacy tool named hostname. In a terminal, type in hostname and hit enter. To get more information, we would want to use the hostnamectl command that comes with systemd. Type in hostnamectl and hit enter. Early in this course, we used the hostnamectl command to set each VM's hostname by utilizing the set-hostname subcommand. Traditionally, individual network interface configuration files control the interfaces for network devices. These files can still be used to override Network Manager. As the system boots and Network Manager configures the network, these files are read and the network interfaces are configured or possibly ignored depending on the configuration. These files are stored in /etc/sysconfig/network-scripts and named ifcfg-name, where name is the name of the network interface. For instance, the configuration file for the ENP0S3 network interface would be /etc/sysconfig/network-scripts/ifcfg-enp0s3. The network interface is also named inside of the file as well. Generally, it's a good idea to have them match. These scripts are for all network interface configuration, including dynamic and manual configs. A dynamic config may only have a few lines in it, specifying the name of the device and the boot protocol of DHCP. This example specifies that it should be enabled at boot and uses DHCP for configuration. To create a static interface configuration, we'll change the boot proto to none. In this case, we're using a 24-bit subnet mask in the prefix line. If we wanted to insert the net mask as dotted notation, we could write it as netmask equals. The last line is the statically assigned IP version 4 address. There are a lot of different options you can add to this file. Let's go over some of the common ones. Device specifies the network device to configure. IP-ADDR is for the IP version 4 address. The HWADDR option specifies which network interface to configure if you have more than one. This is used to identify the network interface. Boot proto assigns the boot protocol and can be none for static assignments, boot P for older networks, and DHCP for newer dynamic networks. OnBoot specifies whether the network interface should be enabled at boot. IPv6 ADDR is for the IP version 6 address. IPv6 init specifies whether IP version 6 support should be enabled or not. The next couple of options need some explanation. The global DNS name server file is /etc/resolve.conf. However, Enterprise Linux allows interface-specific DNS servers using the DNS1 equals or DNS2 equals options. We would specify the DNS server addresses here. To keep these options interface-specific, we need to set peer DNS to yes. If we change it to no, these DNS servers are then copied to the global /etc/resolve.conf file. Prefix and net mask are both used to set the network mask. Only one is required. If you want to enter the net mask in dotted notation, use netmask equals. If you want to use CIDR, then use prefix equals. The next two options are for whether you want Network Manager controlling the interface or whether you want non-root users to be able to control it. There are many more options used to tune network interfaces and provide more control. As this is the legacy method of manually configuring network interfaces, the RedHat Enterprise Linux 6 deployment guide actually has more information on these files than the RedHat Enterprise Linux 7 or 8 networking guides, so reference that. If you change or edit these files, you need to notify Network Manager. One way of doing this is to use nmcli to reload the configuration. Type nmcli space connection space reload or nmcli space c space reload for short. Traditionally, individual network interface configuration files control the interfaces for network devices. These files can still be used to override Network Manager. As the system boots and Network Manager configures the network, these files are read and the network interfaces are configured or possibly ignored depending on the configuration. These files are stored in /etc/sysconfig/network-scripts and named ifcfg-name, where name is the name of the network interface. For instance, the configuration file for the ENP0S3 network interface would be /etc/sysconfig/network-scripts/ifcfg-enp0s3. The network interface is also named inside of the file as well. Generally, it's a good idea to have them match. These scripts are for all network interface configuration, including dynamic and manual configs. A dynamic config may only have a few lines in it, specifying the name of the device and the boot protocol of DHCP. This example specifies that it should be enabled at boot and uses DHCP for configuration. To create a static interface configuration, we'll change the boot proto to none. In this case, we're using a 24-bit subnet mask in the prefix line. If we wanted to insert the net mask as dotted notation, we could write it as netmask equals. The last line is the statically assigned IP version 4 address. There are a lot of different options you can add to this file. Let's go over some of the common ones. Device specifies the network device to configure. IPADDR is for the IP version 4 address. The HWADDR option specifies which network interface to configure if you have more than one. This is used to identify the network interface. Boot proto assigns the boot protocol and can be none for static assignments, boot P for older networks, and DHCP for newer dynamic networks. OnBoot specifies whether the network interface should be enabled at boot. IPv6 ADDR is for the IP version 6 address. IPv6 init specifies whether IP version 6 support should be enabled or not. The next couple of options need some explanation. The global DNS name server file is /etc/resolve.conf. However, Enterprise Linux allows interface-specific DNS servers using the DNS1 equals or DNS2 equals options. We would specify the DNS server addresses here. To keep these options interface-specific, we need to set peer DNS to yes. If we change it to no, these DNS servers are then copied to the global /etc/resolve.conf file. Prefix and net mask are both used to set the network mask. Only one is required. If you want to enter the net mask in dotted notation, use netmask equals. If you want to use CIDR, then use prefix equals. The next two options are for whether you want Network Manager controlling the interface or whether you want non-root users to be able to control it. There are many more options used to tune network interfaces and provide more control. As this is the legacy method of manually configuring network interfaces, the Red Hat Enterprise Linux 6 deployment guide actually has more information on these files than the Red Hat Enterprise Linux 7 or 8 networking guides, so reference that. If you change or edit these files, you need to notify Network Manager. One way of doing this is to use nmcli to reload the configuration. Type nmcli space connection space reload or nmcli space c space reload for short. For this exercise, you'll need to have your RHOST1 VM booted up and be logged in with a terminal open. In this video, we'll bond two network interfaces using the Network Manager command line interface. Just so we don't assume anything, let's check the status of Network Manager. Type in sudo space systemctl space status space Network Manager with a capital N and capital M. And hit enter. Type in your password if prompted. From this, we can see that it's running, and we can also see information about DHCP activity as well. Now let's list our network interfaces. Type in Q, and then type in clear, and type in nmcli space dev space status, and hit enter. We can see our main network interfaces, as well as the two that are not configured, ENP0S9 and ENP0S10. Now let's load the bonding driver. Type in clear, then type in sudo space mod probe space bonding and hit enter. And verify with lsmod. Type in lsmod space pipe space grep space bonding and hit enter. Now we'll create the bond0 logical interface with Network Manager. Type in nmcli space con for connection space add space type space bond for the type space con dash name space bond0, that'll be the name of it, space if name space bond0 again, space mode space balance dash RR for round robin, space IP4 followed by the IP version 4 address. Let's give it 192.168.100.101/24 space GW4 space, and the gateway will be 192.168.100.1 and hit enter. I've chosen 192.168.100.101 for the IP version 4 address. Now let's take a look at what it created. Type in clear, type in cat space /etc /sysconfig /network scripts /ifcfg -bond0 and hit enter. This is the exact same thing that we would have created by hand. The nmcli command we just typed in created this file for us and saved time. Now let's add the ENP0S9 and ENP0S10 interfaces to bond0. Type in clear, then type in nmcli space con space add space type space bond dash slave space if name space ENP0S9 space master space bond0 and hit enter. Now bring your line back and change ENP0S9 to ENP0S10 and hit enter again. These steps also create two new IFCFG files. Let's take a look at one of them. Type in clear, bring back your cat line and change the file name to be ifcfg-bond-slave-enp0s9 and hit enter. Once again, this is very similar to what we would have created by hand if we were doing it that way. Now let's activate the connection. Type in nmcli space con space up space bond0 and hit enter. We should see a message telling us it's active. Let's verify the network information of bond0. Type in IP space addr space show space bond0 and hit enter. We can see that it has the IP and net mask that we configured. Now let's get a connection listing with nmcli. Type in nmcli space con space show space pipe space grep space bond and hit enter. This should show all three connections that we just created as they have the word bond in their names. Naturally, we have to create a bond on RHOST2 as well in order to get any benefit. I will leave that as an exercise for you. After you have created your bond on both hosts and tested it, you can move on to creating a team. But before you move on to creating a team with your two network interfaces, you want to delete bond0 and the connections. To do so, you'd use the delete subcommand followed by the interface name. For this exercise, you'll want to have both RHOST1 and RHOST2 VMs booted up and be logged into RHOST1 with the terminal open. For this exercise, we'll team two network interfaces using the Network Manager command line interface. The difference between this exercise and the bonding one is that we'll be using the team driver instead of the bonding driver. Let's start by checking the status of Network Manager. Type into a terminal systemctl space status space Network Manager with a capital N and a capital M, and hit enter. From this, we can see that it's running. Press Q to quit, and then type in clear. Now let's look at our network interfaces. Type in nmcli space con space show and hit enter. We see our main network interfaces of ENP0S3 and ENP0S8. You may see some other interfaces called wired connection. These are either leftover configurations or configurations that Network Manager has automatically configured. These will probably cause us problems later, but we'll deal with them in a moment. Now let's load the team kernel module. Type in clear and then type in sudo space modprobe space team and hit enter, and enter your password if prompted. And we can double check with lsmod. Type in lsmod space pipe space grep space team and hit enter. Now we'll create the team0 logical interface with Network Manager. Type in clear and then type in nmcli space con space add space type space team space con dash name space team 0, which is the name, space if name, space team 0, space IP4, and for the IP version 4 address, let's give it 192.168.101.100/24, space GW4. For the IP version 4 gateway, let's enter 192.168.101.1 and hit enter. This is the Network Manager equivalent to creating the ifcfg-team0 file by hand. Now let's add the ENP0S9 and ENP0S10 interfaces to team0. Type in clear and then type in nmcli space con space add space type space team dash slave space if name space ENP0S9 space master space team0 and hit enter. Now bring your line back and change ENP0S9 to ENP0S10 and hit enter again. Teams are a bit different than bonds in that you don't determine which teaming mode, called the runner, that you want when you create the team. This is equivalent to the balance mode in the bonding exercise. To set the team runner, use nmcli again. Type in clear and then type in nmcli space con space modify space team0 space team.runner space active backup and hit enter. You can also set other attributes, such as the link watchers this way. These steps create 3 new ifcfg files. Let's list the network scripts directory. Type in ls space /etc /sysconfig /network -scripts and hit enter. These files are very similar to what we would have created by hand if we were doing it that way. Notice the wired connection files as well. We'll get back to those. Now let's activate the connection. Type in clear and then type in nmcli space con space up space team0 and hit enter. We should see a message telling us it's active. Let's verify the network information of team0. Type in IP space ADDR space pipe space grep space team0 and hit enter. We can see that it has the IP and net mask information that we configured. Now let's show connection information for teams and slaves. Type in clear, then type in sudo space team_nl space team0 space ports. If you don't see any output from this command, it means you probably have more than one configuration for the network interfaces. Go to your top right-hand menu and go down to ENP0S10 and connect. Then go back to your top right-hand menu and go down to ENP0S9 and connect. Now go back to the terminal and show connections again. Type in nmcli space con space show and hit enter. We see our wired connection 1 and wired connection 3 connected, but the team slave connections are not. Go back to your top right hand menu again, go down to any Ethernet device and select wired settings. Wait for the connections to fail, and then click on ENP0S10 on the gear icon next to wired connection, and then click on Remove Connection Profile. And do the same thing for ENP0S9. Now close the window. Bring your line back to show connections and hit enter. And that looks much better. Type in clear, then bring your team NL line back and hit enter. And there's your ports. To check the state, use team DCTL. Type in sudo space team DCTL space team 0 space state and hit enter. Now let's get a connection listing with NMCLI. Type in clear, then type in NMCLI space con space show space pipe space grep space team and hit enter. This should show all three connections that we just created as they have the word team in their names. Naturally, we have to create a team on RHOst 2 as well in order to get any benefit. I will leave that as an exercise for you. After you have created your team on both hosts, you'll want to test it by pinging the IP address of the remote end. If you want to delete this network team, you'll use the delete subcommand followed by the interface name. We won't spend a lot of time covering IP version 6 in this course, as this course is designed to prepare you for an exam and not teach you technologies. We won't go into the advantages of IP version 6. Instead, we'll focus on how to configure it and what tools to use. There are some default settings that are already set, but we need to be aware of them just in case. The sysctl.conf file holds a lot of settings for the kernel. We can also get them by using the sysctl command. In a terminal, type in sysctl space -a space pipe space grep space IPv6 and hit enter. What we're most interested in is that IP version 6 is not disabled. We can manually configure IP version 6 in the IFCFG configuration files. To do so, we need to add IPv6 init equals yes to turn it on, IPv6 ADDR equals followed by the address, and IPv6 underscore default GW equals followed by the gateway address. Changing our interface to use manually configured IP version 6 addresses using NMCLI looks like this. The tools to troubleshoot IP version 6 are not that different either. With IP version 4, we use the ping command to ensure connectivity. For IP version 6, we use ping 6. To show IP version 6 routing information, type IP space -6 space route space show. To trace route using IP version 6, use the traceroute 6 command. And lastly, the netstat command by default shows both IP version 4 and IP version 6 addresses. However, if you want to restrict it to IP version 6, pass the -6 option. With Enterprise Linux 7 and newer, the firewall administration tool is firewall-d. The legacy IP table service cannot be running at the same time as they are not compatible. To make sure the firewall-d is running, in a terminal type in sudo space systemctl space start space firewall-d and hit enter. Now let's make it persistent. Bring your line back and change start to enable and hit enter again. The command we use to interact with firewall-d is firewall-cmd. To verify the status, let's use the --state option. Type in sudo space firewall-cmd space --state and hit enter. And this shows it's running. Note that if you're editing the firewall rules remotely, you can use the --timeout equals option, which will revert the rules back after the specified timeout. Anyone who has written shell scripts in the past to do the same thing with IP tables will appreciate this feature. This is useful if your rules lock you out so you can't fix them. When the timeout expires, the rules will be reverted, allowing you back in. Also note the difference between the running config and the saved config. To make changes to the firewall survive a reboot, which is important, use the --permanent option. Let's add a permanent rule for the web service. Type in sudo space firewall-cmd space --permanent space --add -service equals HTTP and hit enter. This will allow HTTP traffic in from the outside to the default zone. Removing a service is just as easy. Bring your line back and change add to remove and hit enter. To open a port and protocol, just specify them. Type in clear, then type in sudo space firewall-cmd space --permanent space --add -port equals 443/TCP and hit enter. Change add port to remove port to reverse it. We can also add ranges of ports. For instance, to let VNC connections in, we can bring our line back and change 443 to 5901 through 5910 and hit enter. After modifying your firewall, you'll need to reload the rules or none of it will be active. To do so, type in sudo space firewall-cmd space -- reload and hit enter. Earlier, we added the HTTP service by name. To list the services that we can use by name, type in clear and then type in sudo space firewall-cmd space -- get-services and hit enter. To list the services enabled in the current zone, change get services to list services. Bring your line back and change get to list and hit enter. To list the ports enabled in the current zone, change list services to list ports. Bring your line back and change services to ports and hit enter. I've mentioned zones a few times. If you want to learn more about them, check out the man page named firewalld.zones. A zone defines the level of trust for network connections. A connection can only be part of one zone. A zone, however, can be used for many different network connections. For example, you could have a zone for your internal network, which allows DHCP connections, and another for your external network that does not allow any new incoming traffic. If an incoming packet matches the source address for the zone, then the zone's rules are applied. Included zones are drop, where incoming packets are dropped with no response; block, where incoming packets are blocked with an ICMP host prohibited response; external, for use on external network connections with masquerading enabled. You do not trust the other computers on the network. DMZ, for computers in the DMZ that are publicly accessible with limited access to internal computers. Public, work, home, and internal for the areas specified. You mostly trust the other computers on the network. And lastly, trusted. All network connections are accepted. Zones make it really easy for adding rules, as you don't have to think about the specifics. Just add the rule to the zone in question. We didn't specify zones in the previous video, so the rules were added to the default zone. Once again, I'm logged into RHOST1 as user 1 with the terminal open. To get your default zone, type in sudo space firewall-cmd space -- get-default-zone and hit enter. To get all zones, bring your line back and change the option to -- list -all -zones and hit enter. We can create a new zone easily. Type in clear and then type in sudo space firewall-cmd space -- permanent space -- new -zone equals coffee shop and hit enter. This creates a permanent new zone called coffee shop, perhaps for when we're in a coffee shop. Let's add a source address to it. Type in sudo space firewall-cmd space -- permanent space -- add -source equals 10.10.10.0/24 and hit enter. If incoming traffic matches this source address, then the rules in the zone will be applied. Now let's add a rule to this zone by specifying the name. Type in sudo space firewall-cmd space -- permanent space -- add -service equals HTTP. This will allow incoming HTTP traffic in the coffee shop zone, which would be all traffic coming from the 10.10.10.0 network. Now let's reload our firewall rules. Type in sudo space firewall-cmd space -- reload and hit enter. If you don't want to specify the zone each time, you can just make it default. Type in clear and then type in sudo space firewall-cmd space -- set -default -zone equals coffee shop and hit enter. Note that you have to reload your firewall rules before doing this. Now verify by typing in sudo space firewall-cmd space -- get -default -zone and hit enter. And we can see that the coffee shop zone is our default zone. Once again, remember to reload your firewall rules or they will not be active. Bring your reload line back and then hit enter. To see information on our new zone, using firewall-cmd, type in sudo space firewall-cmd space -- list -all space -- zone equals coffee shop and hit enter. You can use these same options to get information on any zone. Network address translation, or NAT, can be accomplished using either masquerade or forwarding in Firewall D. Masquerading can only be used on IP version 4 and not IP version 6. Masquerade will forward packets that are not directed to our system onto their destination. The source address will be changed to our system from the original source. Responses will then go back through our system. Masquerade can be enabled on a zone easily. Let's use our coffee shop zone that we created in the previous video. Type in sudo space firewall -cmd space -- permanent space -- zone equals coffee shop space -- add - masquerade and hit enter. Type in your password if prompted. It's really as simple as that. Now all packets coming into the coffee shop zone will be masqueraded. To verify that it's been added to the permanent firewall config, bring your line back and change everything after -- permanent to -- query - masquerade and hit enter. Although we'll talk more about rich rules later, we can use them now to add more granularity. Type in clear and then type in sudo space firewall -cmd space -- permanent space -- zone equals coffee shop space -- add - rich - rule equals. And then inside single quotes, we're going to type in rule space family equals IP version 4 space source space address equals 192.168.100.0/24 space masquerade single quote. This means that all the traffic coming from 192.168.100.0 will be masqueraded. And hit enter. Now that we're masquerading, let's forward a port to an inside host. Type in sudo space firewall -cmd space -- permanent space -- zone equals coffee shop space -- add - forward - port equals 22 : proto equals TCP : 2 port equals 2222 : 2ADDR equals 192.168.100.101. This is an odd syntax. What it does is it forwards port 22 to an inside host of 192.168.100.101 on port 2222. And verify by typing in sudo space firewall -cmd space -- permanent space -- list - all space -- zone equals coffee shop and hit enter. We can also be more granular about which traffic we're forwarding by specifying a source address within the coffee shop zone. We're combining the two previous methods that we've used. We'll do this with a rich rule, which we'll talk about more in the next video. Type in clear, then type in sudo space firewall -cmd space -- permanent space -- zone equals coffee shop space -- add - rich - rule equals single quote rule space family equals IP version 4 space source space address equals 192.168.1.0/24 space forward - port space port equals 22 space protocol equals TCP space 2 - port equals 2222 space 2 - ADDR equals 192.168.100.101 single quote and hit enter. Rich rules give us a lot of granularity, and we'll talk about them in the next video. Let's talk for a moment about rich rules. Before we start, you might want to check out the man page for rich rules by typing in man space 5 space firewall d.rich language. Adding services and ports to zones is the easiest way of configuring your firewall and satisfies most firewall needs. However, if you're used to using IP tables and having complete control over which packet goes where, you might want the granularity of firewall d rich rules. For example, if you wanted to accept all traffic from all but one host in a zone, you could do so with a rich rule. You can also have granular filters for ports as well. You can rate limit connections and log. These were normal IP tables functions that didn't fit within the standard add service and add port functions in firewall D. A rich rule specifies a condition the packet must match, as well as an action on the packet if it does. The format of a rich rule looks like this. First, we have the name rule, then we have the family of rules. This would be either family equals IPv4 or family equals IPv6. If you leave out the family keyword, it applies to all packets. The next two lines, source address and destination address, use the same format and relate to where the packets are coming from and going to. You can specify the address with a CIDR mask. You can also invert the address to include all but the specified address or addresses. The next block is the service name such as SMB or NFS, the port number, protocol such as UDP or TCP, or even the ICMP block type such as echo reply. You can get service names using sudo space firewall -cmd space -- get - services. You can get ICMP block types by using sudo space firewall -cmd space -- get - ICMP types. The resulting action can be one of log, audit, accept, reject, or drop. We'll start with drop. Drop where the packet is dropped without a response. Reject where the packet is dropped and an ICMP message is sent, or accept where the packet is allowed. We can also use log, which allows us to log to syslog, or audit, which allows us to log to audit D. These will be very familiar to administrators of IP tables. We can also rate limit using limit space value equals rate/duration. For instance, limit space value equals 5/m will allow 5 log messages per minute. Here's an example of a rich rule. This creates a permanent rule in the coffee shop zone concerning IP version 4 traffic from the 10.10.10.0/24 network, destined for the 192.168.0.10/24 network. Traffic matching this destined for TCP ports 8080 to 8090 will be accepted. To list the rich rules, type in sudo space firewall-cmd space -- permanent space -- zone equals, and then whatever zone you're interested in, space -- list - rich - rules, and hit enter. To add rich rules, use the -- add - rich rule option. To remove a rich rule, you change it to -- remove - rich - rule. Rich rules provide us the power of IP tables using Firewall D. We can add static routes using the IP route command. We can also add static routes using the legacy route command, although it needs to be installed first. However, if you want your static routes to survive a reboot, you will need to add them to configuration files in /etc/sysconfig/network-scripts. When we create a network interface configuration file, we name it ifcfg-interface name, such as ifcfg-eth0. For static routes, we name the configuration file route-interface name. For instance, if we wanted to add a static route for the eth0 interface, we'd create a file called route-eth0. To add a route manually using the IP command, we'd type IP space route space add space 192.168.100.0, which is the network address, /24, which is the subnet mask, space 192.168.100.1, which is the gateway, space dev space team0, which is the interface. If you typed in IP space route, you would see the results of this line. The legacy route version of this command line is a bit longer. We type in route space add space -net space 192.168.100.0 space netmask space 255.255.255.0 space GW for gateway space 192.168.100.1 space dev space team0. However, if you reboot after setting the static route with either of these commands, it will be gone. To make it persistent, we'll want to add it to a configuration file. As such, we'd create a route-team0 file in /etc/sysconfig/network-scripts. Inside this file, we'd add address 0 equals 192.168.100.0. Netmask equals 255.255.255.0. Gateway equals 192.168.100.1. The device name is derived from the file name itself. This would be equivalent to our manual IP route example earlier, but it would survive a reboot. For this challenge, you will need to run a web server on RHOST 1. We will be covering web servers in this course, but just for this challenge, installing Apache and starting the service will suffice. You will create a firewall on RHOST 1. The default zone should be set to public. You will create an environment where you will accept web traffic from all hosts in the network, except for rhost3.localnet.com. For this particular host, you will deny packets with an ICMP message. Also, you will allow rhost2.localnet.com to connect to the web server with connections logged to rsyslog at a rate limit of 2 per minute and logged as rhost1 space http space access. Lastly, all traffic from 192.168.3.0/24 will be assigned to the demilitarized zone. The result should be that rhost2 can access the website and its access requests will be logged at a rate of 2 per minute. rhost3 cannot access the website at all. Other hosts on the 192.168.3.0 network will be able to access the website without logging. To solve the network service challenge, we'll start by reviewing our lab layout. Your IP addresses may be different, but for clarity, here are mine. My rhost1 is at 192.168.3.115. My rhost2 is 192.168.3.116, and my rhost3 is at 192.168.3.120. On your rhost1 VM, make sure that Apache is installed, running, and that you can access the Apache homepage. To do so, type in sudo space dnf space install space -y space httpd and hit enter. Type in sudo space systemctl space start space httpd and hit enter. Then bring your line back and change start to enable and hit enter again. Lastly, type in Firefox space 127.0.0.1 and hit enter to test the web server. You can close Firefox now. Now check that the default zone is set to public. Type in clear and then type in sudo space firewall -cmd space --get -default -zone and hit enter. If not, set it with --set -default -zone. Now list the settings associated with the default zone. Type in sudo space firewall -cmd space --list -all and hit enter. You should see the main network interface, mine is ENP0S3, as well as our host-only adapter of ENP0S8 in the list of interfaces. Now I will confirm that my ENP0S8 interface is associated with the 192.168.3.0/24 network and move its interface to the demilitarized zone. Type in clear and then type in IP space ADDR space show space ENP0S8 and hit enter. Here I can see that it is associated with 192.168.3.0. If your main network interface is different, then enter that here. Now let's move ENP0S8 to the DMZ. Type in clear, and then type in sudo space firewall -cmd space --permanent space --change -interface equals ENP0S8 space --zone equals DMZ and hit enter. Type in clear, and then list it by typing in sudo space firewall -cmd space --list -all space --zone equals DMZ and hit enter. We can see that my ENP-S8 interface is now associated with the DMZ. Now let's create a general rule in our DMZ to allow web traffic. Type in clear, then type in sudo space firewall -cmd space --permanent space --zone equals DMZ space --add -service equals HTTP and hit enter. At this point, both of our hosts should be able to access the website. Now we'll create our first rich rule to allow web requests from RHOS2, which in my case is 192.168.3.116, and log all attempts. Type in clear. Then type in sudo space firewall -cmd space --permanent space --zone equals DMZ space --add -rich -rule equals single quote. Between single quotes will be our rich rule. Type in rule space family equals IPv4 space source space address equals my RHOS2 address, which is 192.168.3.116/32 space service space name equals HTTP space log space prefix equals double quote RHOS2 space HTTP space access space double quote space limit space value equals double quote 2/m double quote space level equals double quote notice double quote space accept single quote. That's our entire rich rule. Now hit enter. Note that our subnet mask for one host is /32. This creates a rich rule that logs all connections from 192.168.3.116, which is my RHOS2 VM. Now create a new rich rule to reject web connections from rhos3.localnet.com, which in my case is 192.168.3.120. Use your RHOS3 IP address in your command line. Let's shortcut this by bringing our line back and deleting all the way back to the IP address. And I'll change this from 116 to 120/32, which is my RHOS3 VM. Space service space name equals HTTP space reject single quote and hit enter. Now let's reload our firewall rules. Type in clear, then type in sudo space firewall -cmd space --reload and hit enter. And we'll look at the DMZ rules. Type in sudo space firewall -cmd space dash dash zone equals DMZ space dash dash list dash all and hit enter. We can see our allowed services above and our two rich rules below. Now go to your RHOST2 VM and point your web browser to rhost1.localnet.com. RHOST3 should be denied access. Now go to your RHOST2 VM and point your browser to rhost1.localnet.com and hit enter. RHOST2 should be able to access the web server fine. In the challenge objectives, I also mentioned that the connections from RHOST2 should be logged to our syslog. Go back to your RHOST1 VM and type in clear, then type in sudo space tail space dash f space slash var slash log slash messages and hit enter. If RHOST2 is allowed to connect and we have messages and var log messages, then we're done. If not, go back and double check your solution. Installing MariaDB is simple, and it may even be installed already depending on your base package set. We'll install 3 different packages: MariaDB, MariaDB-server, and MariaDB-libs. The MariaDB package installs the client tools, MariaDB-server installs the servers, and MariaDB-libs contains the supporting libraries. The latter package will be pulled in as a dependency, so we don't have to specify it. You will want to be logged into your RHOST1 virtual machine as user 1 and have a terminal open. In the terminal, type sudo space yum space install space dash y space MariaDB space MariaDB-server and hit enter. Type in your password if prompted. Now type in clear to clear the screen, and let's verify that it's installed. Type in yum space list space installed space pipe space grep space caret MariaDB and hit enter. Ensure all 3 packages are installed before moving on. Now let's start MariaDB and make it persistent so it starts at boot. Type in sudo space systemctl space start space MariaDB and hit enter. Now bring your line back and change start to enable to make it persistent and hit enter. Lastly, we'll ensure it's running. Bring your line back one more time and change enable to status. This should show that it's running and where it's logging to. If not, you'll want to troubleshoot it before proceeding with this course. Now that we have it running, let's open a port in the firewall for database connections. Type in clear, and then type in sudo space firewall-cmd space dash dash permanent space dash dash add dash service space MySQL. And then let's reload the firewall rules. Type in sudo space firewall-cmd space dash dash reload and hit enter. At this point, we should be ready to use MariaDB. Due to the nature of databases used for websites, the security has to be tight to keep the data they contain from being exploited. On Enterprise Linux 7, SE Linux is used for this purpose. The MariaDB server runs in a security context, and there are rules and booleans to control what the service can do and to what. Let's take a look at the security context that the MariaDB service runs as. Type in ps space dash capital A capital Z space pipe space grep space MariaDB and hit enter. We can see that there isn't a MariaDB service listed. Let's run it again and check for MySQL. Bring your line back and change MariaDB to MySQL and hit enter. We can see that there is a MySQLD service as well as a MySQLD_safe service. Looking at the third section of the leftmost column, we can see that the MySQLD service is running as the MySQLD_T type, and the MySQLD_safe service is running as the MySQLD_safe_T type. Now let's take a look at the MySQLD binary. Type in clear to clear your screen, and then type in ls space dash capital Z space slash usr slash libexec slash MySQLD and hit enter. We can see that its type is MySQLD_exec_T. Lastly, let's take a look at the database files and their SE Linux types. Type in clear and then type in ls space dash capital Z space slash var slash lib slash MySQL and hit enter. We can see that the type of the database files is MySQLD_DB_T. This is very important if you ever want to move the database files to a non-standard location. If the security context is not correct on the database files, the server will not be able to run. If you wanted to move the database files, you'd change the expected type of the files with path in the SE Linux database, and then run a restore command on the directory. See the overlay for an example using a directory @/database. Now let's check to see what SE Linux booleans exist that may impact our MariaDB server. Type in clear and then type in get se bool space -a space pipe space grep space MySQL. And hit enter. There are only two, MySQL _ connect _ any and SE Linux user _ MySQL _ connect _ enabled. If you want MariaDB to connect to any port, you'll want to turn on the MySQL _ connect _ any boolean. This is the sledgehammer solution to using MariaDB on a different port. Perhaps a better method would be to set the type of the new port number to MySQL _ port _ t using SE manage. If you want to connect to MySQL, you need to set the SE Linux user _ MySQL _ connect _ enabled boolean to on. There are two types of backups for database servers, physical and logical. Backing up database servers can be complex because traditional backup tools focus on physical files on the server. However, backing up files on a working database server can result in corrupted database files if file system snapshots are not employed as the database is changing while it's being backed up. A physical database backup stores the physical files on the server, and as such, it includes the server configuration and the database files themselves. This type of a backup would be good for recreating an entire database server from scratch. In contrast, a logical database backup is carried out by having the database service export its data, resulting in SQL files that can later be imported. This type of backup does not include the server configuration files and is good for moving data in a database from one database server to another or for replicating the database. Let's see how this works. In a terminal, we'll use the MySQL dump command to create logical database backups. Let's start by backing up all databases in one SQL file in our home directory. Type in MySQL dump space -u space root space -p space -- all -databases space > space tilde / dbbackup -all.sql and hit enter. Type in your database password. We can view this file using any text viewer, as it's a text file full of SQL statements. Note that even though we specified all databases, MySQL dump doesn't back up the information schema or performance schema databases. Options can be specified to back up information schema, but performance schema is never backed up. Now let's back up a specific database. To get a list of databases, we would log in with the MySQL tool and run show databases. To back up our Linux devs database, type in MySQL dump space -u space root space -p space -- space Linux devs, the name of our database, space > space tilde / dbbackup -linuxdevs.sql and hit enter. Type in your database password again and hit enter. I've specified the --databases option with the name of our database after it. Because we only have one database, this option isn't actually necessary. However, if you want to specify multiple databases to back up, you'd want to use the --databases option. I've named these backup files in such a way that they'll sort alphabetically. Also, in a production environment, I would add a backup date to the name, such as dbbackup -linuxdevs -08 -03 -18.sql. This way it would be easy to locate a specific logical backup. We can also be more granular in what we back up. If we wanted to only back up one table in a specific database, we could. Let's only back up the Linux devs table in the Linux devs database. Type in MySQL dump space -u space root space -p space Linux devs, that's the database, space Linux devs, which is the table, space > space tilde / dbbackup -linuxdevs -linuxdevs.sql and hit enter. Enter your database password and hit enter again. This backs up the Linux devs table in a database called Linux devs into the dbbackup -linuxdevs -linuxdevs.sql file. In our case, we only have one table, so the resulting file isn't different than just backing up the entire database. MySQL dump is an easy command to use and does a good job of backing up databases. Because it's saving SQL files, they need to be run in order to recreate the database. If you have a large database, it may take some time to execute the SQL files to rebuild the database. There are other enterprise-level tools that may do a better job, but are beyond the scope of this course. Such a tool is MySQL Backup of the MySQL Enterprise Backup product. Now that we've gone over the commands needed to change databases, create databases, and insert or update records, let's walk through this process. Let's start by showing the databases that currently exist. Be sure you're logged into MariaDB as the root database user using the MySQL command. Type in MySQL --u --root --p and hit enter, and then hit enter again for your password. Type in show --databases and hit enter. We see that we have 4 databases: Information Schema, MySQL, Performance Schema, and Test. We can also see from our prompt that we have not selected a database using the use command. Now let's create a database called Linux Devs. Type in create --database Linux Devs and hit enter. Now type in show --databases to verify. If it's not there, look for an error message saying it wasn't created and troubleshoot it before moving on. Now let's choose the Linux Devs database. Type in use Linux Devs and hit enter. You should see the prompt change to reflect our choice. Let's create a table called developers and we'll add some structure to it. I'm going to read out every character as it's important to get it right. Type in create table developers left parentheses devnum int comma name varchar left parentheses 20 right parentheses comma last name varchar left parentheses 20 right parentheses comma city varchar left parentheses 20 right parentheses comma country varchar left parentheses 20 right parentheses comma age int right parentheses semicolon and hit enter. I'll talk about what this does in a moment. Let's verify by describing the table. Type in DESC developers and hit enter. We should see a table with 6 columns and 6 rows. The rows are devnum, name, last name, city, country, and age. Devnum and age are integers. The others are text columns with a limit of 20 characters. We can see that the first column is the field name. The second column is the field type, with any restrictions in parentheses, such as the length of the field. The third column shows if it is null. The fourth column shows if it is a table key. The fifth column denotes the default value for the field. And the last column shows any special attributes for the field. Now let's insert some data into our table using the insert command. Again, I'll read out every character as it has to be exact. Type in insert into developers values left parentheses single quote 1 single quote comma single quote Linus single quote comma single quote Torvalds single quote comma single quote Helsinki single quote comma single quote Finland single quote comma single quote 48 single quote right parentheses semicolon and hit enter. This will insert the information for Linus Torvalds into the table. We specify a developer number of 1, Linus Torvalds for their first and last names, Helsinki for city, and Finland for country. Finally, we specify 48 for age. Now bring your line back and change the developer number to 2, the first and last names to Alan Cox, the city to Solihull, and the country to United Kingdom. Lastly, change the age to 50. So it should look like this. Now hit enter. Make sure all of the quotes are preserved. We'll add one more developer. Bring your line back again and change the dev num to 3. The name to Theodore Cho, the city to Palo Alto, and the country to United States. The age will remain at 50. Once you've made these changes, hit enter. If you have a problem, it most likely deals with quotes. Double check them. Select asterisk from developers semicolon and hit enter. You should see all 3 records in the developers table of the Linux Devs database with the relevant data in the respective columns. In the last video, we created a couple of logical database backup files in our home directory. We can verify their existence by typing in ls -1 tilde /**.sql. Hit enter. Now let's use these files to restore our database. First, let's log into MariaDB using the MySQL interactive tool. Type in MySQL -u root -p and hit enter, and enter your database password. Let's get a list of databases by typing in show databases /. We can see our Linux devs database, which we backed up in a previous video. Let's drop this database using the drop command. Type in drop database Linux devs / and hit enter. And we'll verify with show databases /. Now that we see it's gone, let's exit and restore the Linux devs database from our backup. Type in exit. Now type in clear to clear your screen. Now we use the MySQL command in a non-interactive way to restore the database. Type in MySQL -u root -p tilde /dvbackup -linuxdevs.sql and hit enter. And enter your database password. Now let's log back in with MySQL and verify it. Type in MySQL -u root -p and hit enter. And then enter your database password. Let's list our databases. Type in show databases / and hit enter. It shows the Linux devs database exists again. Now let's switch to it and list the tables. Type in use Linux devs. Hit enter. Now type in show tables / and hit enter. We can see that the Linux devs table is there, so let's query it. Type in select from Linux devs / and hit enter. It appears to be complete. Using this method, we can back up databases and tables and then restore them later. Now that we have a working database with data in it, let's try some queries. But before we move on, let's verify our database is ready. Make sure you are logged into MariaDB as root and that you are using the Linux devs database. Your prompt should reflect this. Now let's query all records in our database. Type in select from developers /. This will verify that everything is ready. Now let's do some more specific queries. Let's only show developers that are 50 years old. Bring your line back and add to the end where age with a capital E equals 50 / and hit enter. This should show Alan Cox and Ted Show. Now let's query for developers under 50. Bring your line back, change age equals 50 to age less than 50 and hit enter. This should only show Linus Torvalds. We can show specific records as well by being more precise. Bring your line back again and change age less than 50 to last name equals TSO / and hit enter. This should only show Ted Show. We can specify more than one piece of data to match as well. Bring your line back again and replace last name equals with city equals Helsinki or city equals Solihull semicolon and hit enter. This should show Linus Torvalds and Alan Cox. We can change the sorting order as well by specifying order. Type in select from developers order by last name. Hit enter. Here we're sorting on the last name. If you want to sort in descending order, just bring your line back and add DESC to the end and hit enter. We can do less concise queries as well. Let's return all developers from countries that start with United. Bring your line back again and change order by last name to where country single quote United with a capital U %, single quote, semicolon, and hit enter. This should return both Ted Cho and Alan Cox as both were born in countries starting with the word United. The % is a wildcard for 0, 1, or multiple characters. This would be equivalent to an asterisk on the Linux command line or a dot asterisk in a regular expression. To match one character, you can use an underscore. We can combine multiple criteria as well. Let's query developers from countries that start with United and order by last name descending. Bring your line back again and add to the end order space by space last name space DESC semicolon and hit enter. It's as simple as that. There are two types of backups for database servers, physical and logical. Backing up database servers can be complex because traditional backup tools focus on physical files on the server. However, backing up files on a working database server can result in corrupted database files if file system snapshots are not employed as the database is changing while it's being backed up. A physical database backup stores the physical files on the server, and as such, it includes the server configuration and the database files themselves. This type of a backup would be good for recreating an entire database server from scratch. In contrast, a logical database backup is carried out by having the database service export its data, resulting in SQL files that can later be imported. This type of backup does not include the server configuration files and is good for moving data in a database from one database server to another or for replicating the database. Let's see how this works. In a terminal, we'll use the mysql dump command to create logical database backups. Let's start by backing up all databases in one SQL file in our home directory. Type in mysql dump space -u space root space -p space -- all databases space > space tilde / dbbackup all.sql and hit enter. Type in your database password. We can view this file using any text viewer, as it's a text file full of SQL statements. Note that even though we specified all databases, mysql dump doesn't back up the information schema or performance schema databases. Options can be specified to back up information schema, but performance schema is never backed up. Now let's back up a specific database. To get a list of databases, we would log in with the MySQL tool and run show databases. To back up our Linux devs database, type in mysql dump space -u space root space -p space -- databases space Linux devs, the name of our database, space > space tilde / dbbackup -Linux devs.sql and hit enter. Type in your database password again and hit enter. I've specified the -- databases option with the name of our database after it. Because we only have one database, this option isn't actually necessary. However, if you want to specify multiple databases to back up, you'd want to use the -- databases option. I've named these backup files in such a way that they'll sort alphabetically. Also, in a production environment, I would add a backup date to the name, such as dbbackup -Linux devs -08 -03 -18.sql. This way it would be easy to locate a specific logical backup. We can also be more granular in what we back up. If we wanted to only back up one table in a specific database, we could. Let's only back up the Linux devs table in the Linux devs database. Type in mysql dump space -u space root space -p space Linux devs, that's the database, space Linux devs, which is the table, space > space tilde / dbbackup -Linux devs -Linux devs.sql and hit enter. Enter your database password and hit enter again. This backs up the Linux devs table in a database called Linux devs into the dbbackup -Linux devs -Linux devs.sql file. In our case, we only have one table, so the resulting file isn't different than just backing up the entire database. mysql dump is an easy command to use and does a good job of backing up databases. Because it's saving SQL files, they need to be run in order to recreate the database. If you have a large database, it may take some time to execute the SQL files to rebuild the database. There are other enterprise-level tools that may do a better job, but are beyond the scope of this course. Such a tool is MySQL Backup of the MySQL Enterprise Backup product. In the last video, we created a couple of logical database backup files in our home directory. We can verify their existence by typing in ls space -1 space tilde ***.sql. Hit enter. Now let's use these files to restore our database. First, let's log into MariaDB using the MySQL interactive tool. Type in mysql space -u space root space -p and hit enter, and enter your database password. Let's get a list of databases by typing in show space databases semicolon. We can see our Linux devs database, which we backed up in a previous video. Let's drop this database using the drop command. Type in drop space database space Linux devs semicolon and hit enter. And we'll verify with show space databases semicolon. Now that we see it's gone, let's exit and restore the Linux devs database from our backup. Type in exit. Now type in clear to clear your screen. Now we'll use the MySQL command in a non-interactive way to restore the database. Type in MySQL space -u space root space -p space less than space tilde slash dvbackup dash linuxdevs.sql and hit enter. And enter your database password. Now let's log back in with MySQL and verify it. Type in MySQL space -u space root space -p and hit enter. And then enter your database password. Let's list our databases. Type in show space databases semicolon. And hit enter. It shows the Linux devs database exists again. Now let's switch to it and list the tables. Type in use space Linux devs. Hit enter. Now type in show space tables semicolon and hit enter. We can see that the Linux devs table is there, so let's query it. Type in select space asterisk space from space Linux devs semicolon and hit enter. It appears to be complete. Using this method, we can back up databases and tables and then restore them later. On occasion, you may not remember your database root user password and need to reset it without having access to the old one. You need super user privileges to do this, so not just anyone can reset the database root user password. First, we need to stop the MariaDB server. In a terminal, type in sudo space systemctl space stop space MariaDB and hit enter. Type in your password if prompted. Then we need to run the mysqld_safe server with a skip grant tables option. Type in sudo space mysqld_safe space --skip--grant-tables space ampersand and hit enter. Then hit enter again. Be sure to add the ampersand at the end or it will tie up your terminal. The --skip--grant-tables option starts mysqld without authentication. Now log into MySQL as the database root user without a password by typing in mysql space -u space root space -p and hit enter. And hit enter again when prompted for a password. Now we'll reset the password the way we did in our previous video. We want to start by switching to the MySQL database. Type in use space MySQL semicolon and hit enter. You'll notice your prompt will change. Now let's update the password record for the root user. Type in update space user space set space password equals uppercase PASSWORD left parentheses double quote and then your desired password. I'm putting in my new password double quote right parentheses space where space user with a capital U equals single quote root single quote semicolon and hit enter. Now we're going to flush privileges by typing in flush space privileges semicolon and hitting enter. If this succeeds without error, we're ready to log out of the MySQL interactive tool. Type in exit and hit enter. Now let's clear our screen by typing in clear. And now we'll stop the mysqld_safe server using the MySQL admin command. Type in mysql admin space -u space root space -p space shutdown and hit enter. Type in your new database password and hit enter. This should stop the mysqld_safe process. Now let's restart the MariaDB service. Type in sudo space systemctl space start space MariaDB and hit enter. If it started, we can try to log in again with the MySQL command. Type in mysql space -u space root space -p and hit enter. And enter your new database password. If you can log in, the process has been successful. There are multiple ways of setting the initial root database user's password. The easiest might be to use the MySQL admin command. Be sure that you are not logged into MariaDB with MySQL. You need to be on the Linux command line for this exercise. To set the initial root database user's password, we'll use the MySQL admin command. Type in mysql admin space -u space root space password space, and then enter your desired password. I'm going to set mine to my secure password. And hit enter. Now let's verify by trying to log in with the old blank password. Type in mysql space -u space root space -p and hit enter. And then hit enter again for the blank password. You should be denied. Now let's try our new password. Bring your line back again and hit enter. Now enter your new password. If it worked, you should be able to log in fine. Another way to set the password, if you are able to log in currently, is to use SQL and update the MySQL table. You would log in as you normally would and then show databases. Type in show space databases, semicolon, and hit enter. We want to switch to the MySQL database. Type in use space MySQL, semicolon, and hit enter. Now let's update the password record for the root user. Type in update space user space set space password equals uppercase PASSWORD, left parentheses, double quote, your new desired password. I'm setting mine to my new password, double quote, right parentheses, space where, space user with a capital U equals, single quote, root, single quote, semicolon, and hit enter. Now flush privileges by typing in flush space privileges, semicolon, and hit enter. If this succeeds without error, you can log out and back in to check it. Type in exit, semicolon, and hit enter. Now type in mysql space -u space root space -p and hit enter, and enter your new password. If it was successful, you should be able to log in with your new password. For this exercise, we'll need to be logged into our RHOST1 VM and have a terminal open. We'll install both a bind server package and the bind utilities package if we don't have them already. Type in sudo space yum space install space -y space bind space bind-utils and hit enter. Type in your password if prompted. Once those are installed, let's take a look. Type in clear and then type in yum space list space installed space pipe space grep space caret bind and hit enter. And this shows the bind package and some of its dependencies. Now let's enable and start the service. Type in clear again and type in sudo space systemctl space enable space named and hit enter. And then start the service by bringing your line back and changing enable to start. And hit enter again. The main bind configuration file is at /etc/named.conf. Let's open this file and less. Type in sudo space less space /etc/named.conf and hit enter. This file includes global options plus zone and include statements. The zone statements declare a zone, and the include statements include external files. All statements start with a left curly bracket and end with a right curly bracket and a semicolon. Statements can be nested this way, but always follow the same pattern. Single-line comments start with double slashes. If you want a multi-line comment, you can include it between a /* and an */. We can see an example of this by scrolling down a bit. Now let's scroll to the end of the file. The zone statements declare a zone and then point to the zone file that resides in the /var/named directory. There's nothing in the zone statement that tells you this, you just need to know it. Take a note of the name of the file in the zone statement. After the file keyword, it says named.ca. We'll look at this file later in the course. Press Q to quit. Now that we've looked at the bind configuration, let's take a look at a zone file and analyze it. Type in sudo space less space /var/named/named.localhost into a terminal. A zone file contains directives and resource records. The directives control how the DNS server operates and how to apply settings to the zone. The resource records apply an identity to the domain. To differentiate between directives and resource records, you should know that directives start with a $. We can see in this file that we have $TTL as an example directive followed by its option. For resource records, we have an NS or name server record, an A record for an IP version 4 address, and a quadruple A record for an IP version 6 address. The name of this file is named.localhost, so that name is resolved to 127.0.0.1 if we're using IP version 4. We could also have a CNAME record or alias, an MX record for mail exchange, or a PTR record, which is a pointer to a different location in the namespace. PTR records are used for reverse lookups. Lastly, we have an SOA record, which is a start of authority. This defines authoritative data for the domain. The SOA record can include the following data: serial, which is the number of times the zone has been updated. Refresh is the amount of time a secondary server will wait before sending a request to update the zone. Retry is the amount of time the secondary server will wait before sending an additional request to update the zone. And lastly, minimum is the amount of time a name server will cache zone data. For this exercise, you'll want to be logged into your RHOST1 VM and have a terminal open. Since we already installed the bind and bind utils packages, we won't need to do that now. They do need to be installed in order to proceed though. To configure a caching-only DNS server, you'll need to edit the named.conf file. Let's load it into VI by typing in sudo space vi space /etc/named.conf and hit enter. Enter your password if prompted. Now go into insert mode by pressing I. We want to change the listen on port from localhost to any. If you want to also answer IP version 6 requests, change the following line from localhost to any as well. In addition, change the allow query line to any. Now scroll down past the comment and change both DNSSEC lines to no. And save and exit by pressing escape:*x and hitting enter. Let's check the DNS configuration file using named-checkconf. Type in sudo space named-checkconf and hit enter. If you don't get any errors, then start the named service. Type in sudo space systemctl restart space named and hit enter. Let's also check the status of named. Bring your line back and change restart to status. If you get error messages, then double check the previous steps and try restarting the named service again. If all is well, then enable the named service to start on boot. Bring your line back and change status to enable and hit enter. Now let's add the DNS service to the firewall. Type in clear and then type in sudo space firewall cmd space -- permanent space -- service space DNS and hit enter. And then reload the firewall rules by typing in sudo space firewall -cmd space -- reload. Next, switch over to your RHOST2 VM and open a terminal. To finish our configuration, we'll change the resolve.conf file to include our new name server. Type in sudo space vi space /etc/ resolve.conf and hit enter. Type in your password if prompted. Go into insert mode by pressing the I key and then delete the two name server lines. Once that's done, we'll add our own. Type in name server space and enter the IP address of your RHOST1 VM. In my case, it's 192.168.1.88. Make sure you enter your RHOST1 IP address here. Now save and exit by pressing escape:*x and hitting enter. Let's test our DNS configuration using dig. We'll force dig to use our caching-only DNS server to resolve the request. Type in dig space @ followed by the IP address of RHOST1 space google.com. This will force dig to use the DNS server of RHOST1. If this works, then our DNS server is resolving. You can also try to resolve without the DNS server IP address to ensure that the etc resolve.conf file is correct. To do this, bring your line back and remove the @ and RHOST1's IP address. Type in clear, and then bring your line back and remove the @ and RHOST1's IP address, and now hit enter. If this works, then our caching-only DNS server is functional and our DNS client is configured. It's important to have a working DNS setup. The exam only specifies setting up a caching-only name server which passes queries onto a master server and caches the results. However, there are many things that can happen that keep the client from functioning. First, let's double-check the etc nsswitch file. Type in less /etc/ nsswitch.conf and hit enter. You'll want to go down to the host line. These entries are used in order of left to right. The first attempt at name resolution will go to local files. This means the etc host file, which we modified at the beginning of this course. After that, it will attempt to resolve via DNS. Press Q. Now let's take a look at the etc host file. Any attempt to reach rhost1.localnet.com or rhost1 will go to the IP address in the first column. If this IP address isn't correct, then name resolution will fail. Most of the troubleshooting I've had to do to make the chapters in this course work together has concerned making sure the etc host file was correct. Keep an eye on it, specifically if you're using dynamic IP addresses. After the etc host file is consulted and a match is not made, the system will attempt to query the DNS server. Press Q. We keep our global DNS servers in the etc resolve.conf file. Let's take a look. We probably want to verify that the name servers listed in this file are reachable and actually name servers. We'll do this with a dig command in a moment. Press Q. Another place where DNS servers are configured is in the network interface specific config files. We'll look at the ifcfg-eth0 file. If your network interface is named something different, then specify that instead. Type in sudo space vi space /etc/sysconfig /network-scripts /ifcfg-eth0 in my case. Enter your password if prompted. This file does not have any specific DNS entries in it. However, if it did, they would look like this. If the peer DNS entry is set to yes, then the entry will get copied to the etc resolve.conf file. Keep in mind that if you modify resolve.conf, this may overwrite it. If peer DNS is set to no, then this entry will never end up in resolve.conf, hiding out here, so be sure to check. Again, you want to make sure that the IP addresses specified are really DNS servers and accessible. To do so, let's use the dig command. Now let's test the DNS server that is in the etc resolve.conf file. The DNS server in my file is 192.168.1.254, and I'll attempt to resolve forward.com, which is not a website I go to normally, so it should not be in a cache anywhere. Type in clear and then type in dig space @ and then the DNS server you want to use, space and then the name you want to resolve, and hit enter. If the DNS server is accessible, we should get a successful resolution back. If this is not successful, then maybe the host is not available or that it is not a DNS server. We have more than one command to query DNS servers, including the legacy nslookup. However, dig does such a good job, I'm going to focus on it. Let's type in dig space redhat.com and look at the results. In a terminal, type dig space redhat.com and hit enter. This shows information on redhat.com. The dig command shows the header, which includes the dig command version number and the global options used by dig. It also shows the question section, which is the question it sent to the DNS server. Since the default question is an address query, it shows that we made an address query. Then comes the answer section, which is the response from the DNS query. In our case, it shows the address record. Next is the authority section, which displays the DNS name server that has the authority to respond to this query. Lastly is the additional section, which displays the IP address of the name server listed in the authority section, followed by stats about the query, including the amount of time it took. If we want to pare this down and only show the answer section, we have to add some options. Type in clear and then type in dig space redhat.com space plus no comments space plus no question space plus no authority space plus no additional space plus no stats and hit enter. You can, of course, choose to hide any of these individually if you wish. An interesting shortcut is to turn off all sections and then turn the answer section back on. Type in dig space redhat.com space plus no all space plus answer. This is a shorter line to type, but provides the same output as the long line we typed in previously. By default, dig queries the address record, but we can select a different record if we wish. To do this, filter by the record type. For instance, to ask for the mail exchange record, let's type in clear and then type in dig space redhat.com space capital MX space plus no all space plus answer and hit enter. If you want the name server address, just replace the MX with NS for name server. To view all records, replace MX with ANY. We'll bring our line back by pressing the up arrow key and then replace MX with the word ANY and hit enter. If you just want the IP addresses, which might be useful in the case of shell scripts, you can use the plus short option. Type in clear and then type in dig space redhat.com space plus short and hit enter. This can be combined with any of the record filters we just discussed. A reverse DNS lookup takes the IP address and finds the DNS name associated with it. We will need to use the -x option to do a reverse lookup. We'll use the IP address that we got from the previous query. When I did it, I got 209.132.183.105. So to do a reverse query, we'll do dig space -x space 209.132.183.105 space plus short and hit enter. This shows us the DNS name associated with this IP address using the short form. Another common task is to query a specific DNS server. In the default output, it shows us the DNS server that responded, which may not be the one we want to query. To specify a DNS server, precede its IP or name with an @ symbol. Type in dig space at ns1.redhat.com space redhat.com. This will query the ns1.redhat.com DNS server for the address record for redhat.com. Hit enter. This is most useful when querying our own DNS servers to verify that they're giving the answers that we want. You can also do bulk DNS name queries by making a text file with each DNS name in it on a separate line. For instance, let's make a file called dnsnames.txt in our home directory using vi. Type in clear, and then type in vi space dnsnames.txt and hit enter. In this file, we're going to add 3 lines by pressing the I key to go into insert mode, and then we're going to type in redhat.com, enter, forward.com, enter, and centos.com, and we'll hit enter again. Save and exit by pressing escape, X, enter. To use this file, we'll pass the -f option to dig and specify the file name. Because we're getting back answers from multiple sites, we'll probably want to add the +knowall and +answer options as well. So type in dig space -f space dnsnames.txt space +knowall space +answer and hit enter. We can specify the type of record as well, like we did earlier. If you find yourself typing in the same options to dig every single time, you can store them in a file called .digrc in your home directory. In this file, just add the options such as +knowall space +answer on one line, and they will be automatically appended when using dig unless you override them. This chapter covers web services using Apache. In this chapter, we cover the following topics. First, we install and configure Apache. Then we manage SE Linux for web services. Next, we configure access control on directories using Apache's access control. We then configure group managed content. This is useful if you have a group of people sharing the responsibility of managing a website's content. Next, we configure a virtual host. Then we configure a virtual host on a non-standard port. Our next exercise configures a secure virtual host. Lastly, we deploy a basic CGI application. Before you start, you might want to download and print the web cheat sheet included with this chapter. We need to install the Apache web server now. You will want to be logged into your ArchHost 1 VM with the terminal open. To install the server package, support for encrypted websites, and the tools, type in sudo space dnf space install space -y space httpd space mod_ssl space openssl and hit enter. Type in your password if prompted. This will also install the httpd-tools package, which we want. These packages may already be installed. Now let's start the service and enable it so it starts at boot. Type in sudo space systemctl space start space httpd and hit enter. Then bring your line back and change start to enable. And hit enter again. Now we need to open a port in the firewall. First, let's double check the default zone. Type in clear, then type in sudo space firewall-cmd space --get-default-zone and hit enter. If it's public, then let's continue. If it's not public, then revisit the firewall zones video in the network services chapter and make it public. Let's also ensure that our ENP0S8 interface is associated with the default zone. Type in sudo space firewall-cmd space --permanent space --change -interface equals ENP0S8 space --zone equals public and hit enter. Now let's open the port for HTTP. Type in clear, then type in sudo space firewall-cmd space --permanent space --add -service equals HTTP and hit enter. and then reload the firewall rules. Type in sudo space firewall -cmd space -- reload and hit enter again. Now we should be able to view the default web page. Open Firefox and browse to localhost. What we see here is the welcome message. To make this go away, we'll need to edit the welcome.conf file. Go back to your terminal and then type in clear and then type in sudo space vi space /etc /httpd /conf.d /welcome.conf and hit enter. Now comment out all lines by prepending them with a hash. Go into insert mode and then add a hash. And then save and exit by pressing escape:*x and hitting enter. Now we need to reload the config or restart the service. We can do this with a systemctl command like we would with any other service, but we can also use the Apache CTL command. Type in sudo space Apache CTL space graceful and hit enter. This reloads the config without a full restart of the service. Now go back to your Firefox web browser and reload the page. You should now see an index of files, which should be empty since we don't have any yet. You will also want to install the documentation. To do so, go back to your terminal and then type in sudo space dnf space install space -y space httpd -manual and hit enter. This documentation is more useful than man pages for this particular service. The HTML documentation in this package is basically the Apache website documentation. To view the local copy from this package, use Firefox. In the URL bar, type in /usr/share/httpd/manual/index.html and hit enter. Another tool that may be useful for browsing our own websites for troubleshooting purposes is elinks. Install it by enabling the PowerTools repository. Go back to your terminal, type in clear, and then type in sudo space dnf space -- enable repo equals PowerTools with a capital P and a capital T space install space -y space elinks and hit enter. Elinks is a command line web browser, so we can use it from the terminal. For example, type in elinks space google.com and hit enter. It may have problems viewing more complex websites, but can be useful for troubleshooting simple stuff. Now let's take a look at the configuration file added when we installed mod_ssl. Hit enter, press your Q key, and hit enter again. Then type in less space /etc /httpd /conf.d /ssl.conf and hit enter. This sets up some Apache configuration directives, including an encrypted virtual host. If we scroll down, we can see that near the middle. We can use this as an example to create our own secure virtual host. Like any service that's outward-facing, Apache has a large attack surface. It's a very well-written piece of software and is secure, but also benefits by being protected by SE Linux. A lot of functionality is denied in the base configuration. If you want Apache to do anything outside the norm, you will need to change an SE Linux boolean or two. On RHOST1 in a terminal, let's get a list of SE Linux booleans for Apache by using get SEBool. Type in get SEBool space -a space pipe space grep space httpd and hit enter. And go ahead and scroll up to the top of the list. A few booleans that are important are httpd_anon_write, which allows Apache to write to any directory with the type of public_content_rw_t. This could be an existing directory, or you can change the security context of a directory manually, and with this boolean set, access it with Apache. By setting httpd_can_check_spam, you can have Apache check for spam. To get Apache to act as a network relay, set httpd_can_network_relay. If you want Apache to send mail, set httpd_can_sendmail. To use CGI scripts, set httpd_enable_CGI. This should be the default. You can get Apache to act as an FTP server by setting httpd_enable_ftp_server. By default, Apache can't read files in a user's home directory. If you want this functionality, set httpd_enable_homedirs. If you want Apache to use a Windows share, NFS share, or a fused file system, You may need to set httpd_use_cifs, httpd_use_nfs, or httpd_use_fusefs booleans. Lastly, if you want Apache to query NS records, set httpd_verify_DNS. This is not all booleans associated with Apache. There is a man page for the httpd SELinux booleans named httpd_SELinux. However, it is not installable as a package. We have to create it. First, let's install the SELinux policy devel package by typing in clear and then typing in sudo space yum space install space -y space SELinux policy devel and hit enter. Type in your password if prompted. Once that's installed, we can create the man page using the se policy command. Type in clear and then type in sudo space se policy space man page space -a space -p space /usr/local /man/man8.mandb and hit enter. If this completed successfully, type in clear and then read the man page by typing in man space httpd_SELinux and hit enter. This will not only tell you about the SELinux booleans for Apache, but also the different file contexts. In order to configure a basic web server, you need to already have done the following. Apache needs to be installed. You need to comment out all lines in the welcome.conf file and restart the Apache service so the new configuration is loaded. And lastly, the DNS name rhost1.localnet.com needs to resolve to your rhost1 VM's IP address. These things were covered in the installation video in the previous chapter. Once you've done these things, log into your rhost1 VM and open a terminal. We'll start by checking the Apache configuration file for the web document root. Type in grep space caret document root with a capital D and a capital R space /etc/httpd/conf/httpd.conf and hit enter. This shows that the web document root is /var/www/html. Also, let's check the allowed directory index files. Bring your line back and change the search criteria to directory index with a capital D and a capital I, and then hit enter. This shows that our directory index file is index.html. Now let's go to the document root and create that file by name. Type in clear and then type in cd space /var/www/html and hit enter. Now type in sudo space vi space index.html and hit enter. Go into insert mode by pressing the I key and then type in basic space web space server space test space page. Save and exit by pressing escape :x exclamation mark and hitting enter. Now let's view our website with Firefox. Type in Firefox space rhost1.localnet.com and hit enter. If you see the page we just created, then it works fine. If it doesn't work, then troubleshoot the items in the slides at the beginning of the video. This is a very basic web server configuration, but you need to make sure it works before moving on. I mentioned in a previous video that Apache has some directives for restricting access based on user, group, network, or host. Let's take a closer look. With require user, access is granted to a specific user based on their username or user ID. We can deny the same way with not require user. Let's see what this looks like. To allow user access by user, we just specify their name. To deny by user, we change it to not require user and again specify their name. We can allow or deny by group as well by using require group and not require group. For both, we can just specify the group name. With require valid users, access is granted only to valid users. For more broad control, we can allow or deny based on network addresses by using require IP and not require IP directives. To use this, we specify the network address without the host portion. If you want to allow or deny based on host name, use the require host or not require host directives. We can specify a host or even a portion of a domain name to allow or deny. Apache will do a reverse DNS lookup on the IP address attempting to access the resource, and then a forward lookup to make sure the records match. Only if both are consistent will the host be allowed. To grant all access, use require all granted. To deny all access, use require all denied. To allow access to hosts on the local network, use require local. When multiple required directives are used, only one has to be evaluated as true to allow access. For instance, if we had a require user user1 and require group admin, then user1 would be allowed even if they were not in the admin group. If we wanted to require all conditions to be true, we can group our access control into a require all container. The default acts like a require any container. There is also a require none container. Lastly, we can specify conditions and check environmental variables as well. We can do this with an if container or the require env directive. In this exercise, we will create a private site that requires logging in and entering a password. For more details on Apache access control, please refer to the previous chapter of this course. For this exercise, you should be logged into RHOST1 and have a terminal open. Also make sure that you've completed the previous videos that installed Apache, configured the firewall, started the relevant services, and modified the welcome.conf file. Before continuing with this exercise, you should be able to type into a terminal Firefox space rhost1.localnet.com and hit enter, and it should view the index.html file we created in the last video. If not, then troubleshoot that problem first. Now close Firefox. Viewing the error log will cut your troubleshooting time to a minimum. To view the log, open another terminal tab and enter sudo space tail space -f space /var/log/httpd/error_log and hit enter. Type in your password if prompted. This will follow the error log file while you work and is a good practice. To start this exercise, let's create a new directory for our private website. Go back to your first terminal tab and type in cd space /var/www/html and hit enter. Now type in sudo space mkdir space private and hit enter again. Since we're adding multiple files to this directory, we'll wait until the end to set ownership and permissions. For now, leave them as they are. Now we need to edit the Apache configuration file. Type in sudo space vi space /etc/etc/conf/httpd.conf and hit enter. Go clear to the bottom and go into insert mode by pressing I. We're going to add a directory director for access control to this file. For this exercise, we'll allow .htaccess overrides for auth config. Enter left angle bracket directory space double quote /var/www/html/private double quote right angle bracket. New line tab. Allow override space auth config. New line left angle bracket /directory right angle bracket. This will allow us to override the main configuration settings with a .htaccess file. We could put the access control in this directory directive instead of the .htaccess file. The advantage to this would be that it only gets processed once when the service starts. With a .htaccess file, it gets processed every time the directory is accessed. The downfall is that only administrators can edit this Apache config file, whereas the webmaster has access to the .htaccess file in the web document root. Now save and exit by pressing escape :x and hitting enter. Now let's test the configuration. Type in clear, and then type in sudo space apachectl space config test and hit enter. If your configuration is okay, then continue. Next, we'll create our .htaccess file. Type in sudo space vi space private /.htaccess and hit enter. Go into insert mode by pressing I and then add auth type space basic new line auth name space double quote enter your credentials double quote new line auth user file space double quote /etc/httpd/conf/.userdb double quote new line require space user space user1. This sets the auth type to basic auth. It prompts us with a nice message and specifies the auth user file of .userdb. It also requires the user named user1. Save and exit by pressing escape :x and hitting enter. Because we haven't allowed auto generation of indexes in the directory directive, we'll need to add an index.html file. Type in sudo space vi space private /index.html and hit enter. and go into insert mode by pressing I. Type in private space index space file or any text that you would like. Now save this by pressing escape :X exclamation mark and hitting enter. Now that we're done adding files to the private directory, let's change the ownership and permissions of it and its contents. Type in clear, then type in sudo space chown space -R space Apache :Apache space private and hit enter. And let's change the permissions as well. Type in sudo space chmod space -R space 770 space private and hit enter. In order for a webmaster to add files to the directory, they need to be part of the Apache group. No other user is allowed to read or write files here. Since the Apache server runs as the Apache user, it has access. Since we're adding files within /var/www/html, our SE Linux security context has been inherited, so we haven't had to set it. However, if this directory were anywhere else, we'd have to create a new rule for the policy database and then restore the file system. Not doing this could restrict Apache from accessing the files. Now let's create the auth user file that we specified in our .htaccess file using the htpassword command. Now that we're done in the web document root, let's change directories first. Type in cd space /etc/httpd/conf and hit enter. Now type in sudo space htpasswd space -c for create space .userdb space user1 and hit enter. Now enter a password for user1. This does not have to be the same password as user1's login password because they're not logging into the OS, only accessing web content. Now let's change ownership and permissions so nobody but the Apache user and members of the Apache group can access it. Type in clear, then type in sudo space chown space Apache :Apache space .userdb and hit enter. Now let's set more restrictive permissions. Type in sudo space chmod space 660 space .userdb and hit enter. Lastly, let's restart Apache and check the access control of Firefox. Type in sudo space systemctl space reload space httpd and hit enter. This will reload the configuration files and do a graceful restart. Now let's see if it works using Firefox. Type in Firefox space --private-window space rhost1.localnet.com/private and hit enter. By specifying the --private-window option, it won't remember basic auth information, making it easier to troubleshoot. If you're prompted for a password and allowed to view the web page, you have a functioning basic auth website. If it doesn't work, then start troubleshooting by viewing your error log on the other terminal tab. For this exercise, we'll create a directory for group modified content. You will want to be logged into rhost1 with the terminal open. Pause this video as necessary. Viewing the error log will cut your troubleshooting time to a minimum. To view the log, open another terminal tab and type in sudo space tail space -f space /var/log/httpd/error_log and hit enter. Type in your password if prompted. This will follow the error log while you work through this exercise. To start the exercise, let's create a new directory for our private website. Go back to your first terminal tab. Let's change into the HTML directory so we have less to type. Type in cd space /var/www/html and hit enter. Now create the directory. Type in sudo space mkdir space private group and hit enter. Type in your password if prompted. Since we're adding multiple files to this directory, we'll wait until the end to set the ownership and permissions. For now, leave them as they are. Now we need to edit the Apache configuration file. Type in sudo space vi space /etc/httpd/conf/httpd.conf and hit enter. Go clear to the bottom of the file. We're going to add a directory director for access control to this file. For this exercise, we'll allow .htaccess overrides for authconfig. Go to your directory director for the private directory. Place your cursor on the first line and press Y2 and then move your cursor down below it. Now press P. Lastly, change private to private group. Go into insert mode by pressing the I key and add group. Now save by pressing escape :X exclamation mark and hitting enter. Now let's test the configuration. Type in sudo space apachectl space config test. If your configuration is okay, then continue. We'll now create our .htaccess file. Type in clear and then type in sudo space vi space private group /.htaccess and hit enter. Now go into insert mode by pressing I, and then add on the first line auth type space basic. Hit enter. On the second line type in auth name space double quote, enter your credentials. Double quote, and hit enter. On the third line, type in auth group file space double quote /etc/httpd/conf/.groupdb double quote. On the fourth line, add auth user file space double quote /etc/httpd/conf/.grouppassdb double quote and hit enter. On the fourth line, type in require space group space web group. This sets the auth type to basic auth. It prompts us with a nice message and specifies the auth user file of .grouppassdb. It specifies the auth group file as .groupdb, which includes a list of users in the group. Lastly, it specifies which group the users are required to be in to access the content. Save by pressing escape:*x and hitting enter. Because we haven't allowed auto-generation of indexes in the directory directive, we'll need to add an index.html file. Type in sudo space vi space private group /index.html and hit enter. Go into insert mode by pressing the I key and then type in private group index file and save and exit by pressing escape:*x and hitting enter. Now that we're done adding files to the private group directory, let's change the ownership and permissions of all files. Type in clear and then type in sudo space chown space -R space apache :apache space private group and hit enter. And we'll change the permissions too. Type in sudo space chmod space -R space 770 space private group. In order for a webmaster to add files to this directory, they'll need to be part of the Apache group. No other user is allowed to read or write files here. Since the Apache server runs as the Apache user, it has access. Since we are adding files within the /var/www/html directory, our SE Linux security context has been inherited, so we haven't had to set it. However, if this directory was anywhere else, we'd have to create a new rule for the policy database and then restore the file system. Not doing this could restrict Apache from accessing the files. Now let's create the auth group file that we specified in the Apache config. Let's cd2/etc/httpd/conf. And now create the .groupdb file. Type in sudo space vi space .groupdb and hit enter. Go into insert mode by pressing the I key. In this file, add our two users. Note that these don't have to be Linux login users. This is just for Apache's authentication. Type in webgroup space user1 space user2. Now save and exit by pressing escape:*x and hit enter. Now let's create passwords for our users. This will create the auth user file that we specified in the Apache config. You only need to specify the -c option once as it creates the file. Type in clear and then type in sudo space httpasswd space -c to create space .grouppassdb space user1 and hit enter. Give user1 a password. And then bring your line back, change user1 to user2, and get rid of the -c, and hit enter. Now give user2 a password. Now change the ownership and permissions so only the Apache user can read and write these files. First, we'll change the ownership to Apache. Type in clear, and type in sudo space chown space apache :apache space .group * and hit enter. Now let's set more restrictive permissions. Type in sudo space chmod space 660 space .group * and hit enter. Now that our permissions are set, let's restart the Apache service and check the access control with Firefox. Type in sudo space systemctl space reload space httpd. This will reload the configuration files and do a graceful restart. Now let's see if it works using Firefox. Type in clear and then type in Firefox space -- private window space rhost1 vhost1.localnet.com/private group and hit enter. By specifying the -- private window option, it won't remember basic auth information, making it easier to troubleshoot. Log in as user 1 and enter user 1's password. If that works, you're partway there. Now close Firefox, bring your line back, and hit enter again. This time log in as user 2. If that works, then you have a working basic auth site that allows groups. For this exercise, you will want to be logged into RHOST1 and have a terminal open. Virtual hosts let us have more than one website per server. We can have different logs, site name, and access control per virtual host as well. Let's create a basic virtual host now. Once you've done that, let's take a look. Type in less /etc/http/conf.d/vhost1.conf and hit enter. We start our virtual host container with the name virtual host, followed by the IP address and port to answer on. We've used a wildcard for the IP, so it will answer on all IPs. We've also specified port 80, but we could have chosen something else if we wanted to. We also set the server admin email to webmaster@vhost1.localnet.com. We set the document root to /var/www/html/vhost1.com. With virtual hosts, you can specify a different document root per site. The naming convention is up to you, but I like naming my directories after the website domain name. We also changed our server name for the site to vhost1.localnet.com and added an alias of www.vhost1.localnet.com. This doesn't take care of the name resolution, which we'll fix in a moment. It just means that if someone requests vhost1.localnet.com, that request will be forwarded to this virtual host instead of being handled by the default server. We can also have per site log files, so we've specified an error log and a custom log. When troubleshooting, be sure to follow these logs, not the general ones we've used up until now. Now we need to create our new virtual host document root directory. Press Q to quit, and then type in sudo mkdir /var/www/html/vhost1.com and hit enter. Let's also make an index file. Type in sudo vi/var/www/html/vhost1.com/index.html and hit enter. Go into insert mode by pressing I, and then type in vhost1.com virtual host index file, and save and exit by pressing escape:*x! And hitting enter. Let's test our configuration now. Type in sudo apache-ctl config test and hit enter. Also, we can dump our virtual hosts. Type in sudo httpd --dump_V hosts and hit enter. Here we see our virtual host. Since we're adding files within the var www.html directory, our SE Linux security context has been inherited, so we haven't had to set it yet. However, if this directory was anywhere else, we'd have to create a new rule for the policy database and then restore the file system. To manage name resolution, you could add a zone file to your DNS server. However, to keep this exercise simple, we'll edit our etc host file. Type in clear and then type in sudo vi/etc/hosts and hit enter. Copy the RHOST1 line by moving your cursor to it and pressing YY. Now press P twice. You should have 3 identical lines. Now edit the second identical line and change the domain name to vhost1.localnet.com and the alias to vhost1. Edit the last duplicate line and change the domain name to www.vhost1.localnet.com and delete the alias. Then save and exit by pressing escape:*x! And hitting enter. Before we go further, test the name resolution by pinging vhost1, which works, then press Ctrl+C. Before going further, test the name resolution by pinging vhost1, vhost1.localnet.com, and www.vhost1.localnet.com. Now we need to reload the Apache config file. Type in sudo systemctl reload httpd and hit enter. And then type in clear. To troubleshoot our virtual host, we can follow the log file specific to this host. Open a new terminal tab and type in sudo space tail space -f space /var /log /httpd vhost1.com-error_log and hit enter. Type in your password if prompted. Now go back to your first terminal tab and use Firefox to test the virtual host. Type in Firefox space vhost1.localnet.com. You should see your virtual host index file. If it doesn't work, then double check your name resolution, and then redo the previous step where we used httpd to show the value of dump vhosts. Also make sure your firewall is allowing web traffic. Lastly, make sure permissions and SE Linux security labels are correct for the document root. Also check the web server logs. Sometimes the answer is right in front of us. Before you do this exercise, make sure you have completed the previous exercise which configured a basic virtual host. In this exercise, we'll create a virtual host that answers on a non-standard port. I've chosen the port 8085 as it isn't being used for anything. Also for this exercise, you will want to be logged into RHOST1 with a terminal open. Notice that we're specifying *:8085 on the virtual host directive. The rest is almost identical to the previous virtual host outside of the domain name change. Press Q to quit. Before we get too far, we'll want to tell Apache to listen on port 8085. Type in sudo space vi space /etc /httpd /conf /httpd.conf and hit enter. Search for listen by pressing your / and type in listen. We're going to add a new line here. Type in listen space 8085 and then save and exit by pressing escape :x and hitting enter. Let's create our document root now. Type in clear and then type in sudo space mkdir space /var /www /html vhost2.com and hit enter. Now let's make an index file. Type in sudo space vi space /var /www /html vhost2.com /index.html and hit enter. Go into insert mode by pressing I and type in vhost2.com virtual host index file and then save and exit by pressing escape :x and hitting enter. Since we're using a non-standard port, we need to notify SE Linux that it's okay. Type in sudo space semanage space port space -at space http _port _t space -p space tcp space 8085 and hit enter. This will change the type of TCP port 8085 to http _port _t. Now let's verify. Type in sudo space semanage space port space --list space pipe space grep space caret http _port _t and hit enter. If we see port 8085 in the list, then we're good. Now we need to allow traffic on our new port through the firewall. Type in clear and then type in sudo space firewall -cmd space --permanent space --add -port space 8085 /tcp and hit enter. And then reload the firewall rules. Type in sudo space firewall -cmd space --reload and hit enter. Now let's test our configuration. Type in sudo space apache-ctl space config test and hit enter. If all is well, then you can proceed. To manage name resolution for this exercise, we'll edit our etc host file. Type in clear and then type in sudo space vi space /etc /hosts and hit enter. Copy the vhost1 line by moving your cursor to it and pressing YY, and then press P twice to make 2 copies. You should now have 3 identical lines. Now edit the second copy and change the domain name to vhost2.localnet.com and the alias to vhost2. Go to insert mode by pressing your I key and just change the 1s to 2s. For the third copy, get rid of the alias and change the domain name to www.vhost2.localnet.com and save and exit by pressing escape, :X, ! And hitting enter. Before we go further, test the name resolution by pinging vhost2. Press Ctrl-C to cancel it, bring your line back, and change vhost2 to vhost2.localnet.com. And try it again. And then press Ctrl-C, bring your line back, and change it to www.vhost2.localnet.com. And lastly, press Ctrl-C again. If there are no error messages, we'll continue. Now we need to restart the Apache service. Type in clear and then type in sudo space systemctl space reload space httpd and hit enter. To troubleshoot our virtual host, we can follow the log file specific to this host. Open a new terminal tab, and then type in sudo space tail space -f space /var /log /httpd vhost2.com -error_log and hit enter. Type in your password if prompted. Now go back to your first terminal and use Firefox to test the virtual host. Type in Firefox space vhost2.localnet.com :8085 and hit enter. If you can see your index file, then you're good to go. In this exercise, we'll create a secure virtual host using the key and certificate that we created in the previous video. You will want to be logged into RHOST1 and have a terminal open. Let's start by creating the new document root. Type in sudo space mkdir space /var /www /html /secure and hit enter. Now we need to edit the ssl.conf file. This file contains a virtual host container that we will modify. Type in sudo space vi space /etc /httpd /conf.d /ssl.conf and hit enter. Search for virtual host by pressing / and then typing in virtual host. Go into insert mode by pressing I and then change the document root to /var /www /html /secure. And change the server name to secure.localnet.com :443. Now press escape and / and search for SSL certificate file. And change the file name from localhost.crt to secure.localnet.com.crt. Now scroll down a bit to the certificate key file line. Change the file name from localhost.key to secure.localnet.com.key. And now save and exit by pressing escape : X ! and hitting enter. Now let's dump our virtual hosts. Type in sudo space httpd space -D space $dump _ vhost and hit enter. We should see our previous virtual host as well as a new secure one. Now let's create the index.html file. Type in clear and then type in sudo space vi space /var /www /html /secure /index.html and hit enter. Go into insert mode by pressing the I key and then type in secure virtual host index file and save and exit by pressing escape : X ! and hit enter. Now we'll ensure that the correct SE Linux security context is applied. Type in sudo space restorecon space $RV space /var /www /html /secure and hit enter. More than likely this will not be necessary, but it doesn't hurt anything to run it. If you create directories outside of var www html, you'll have to create new rules for SE Linux and then use restorecon. We'll also need to ensure that port 443 is allowed through the firewall. Type in clear and then type in sudo space firewall-cmd space --permanent space --add -service space https and hit enter. And then we'll need to reload the firewall rules. Type in sudo space firewall-cmd space -- reload. Lastly, we'll restart the Apache server. We need to address hostname resolution as well. We'll add a line to the etc host file. Type in clear, and then type in sudo space vi space /etc /hosts, and hit enter. Go down to the line that has rhost1 in it, press YY, and then press P. This will give you 2 copies of it. Now edit the copy and change the domain name to secure.localnet.com. And save and exit by pressing escape:*X!, and hitting enter. Now we'll use Firefox to test our new secure virtual host. Type in Firefox space https://secure.localnet.com and hit enter. Because it's a self-signed certificate, we'll need to manually accept it. Once that's done, we should see our index page. For this exercise, you'll want to be logged into rhost1 with a terminal open. We will run a script under CGI that displays some information about the web server. You'll want to copy the loggedin.sh file to /var/www/cgi-bin. Once you've done that, let's take a look at it. Type in less space /var/www/cgi-bin /loggedin.sh. Rephrase, /loggedin.sh, and hit enter. It's a very simple script that presents some HTML on the screen and runs the date command. It also runs the who command. Now let's see it work. Press Q to quit. Let's make it executable by typing in sudo space chmod space +x space /var/www/cgi-bin /loggedin.sh and hit enter. We need to turn on an SE Linux boolean to allow CGI scripts. Type in clear and then type in sudo space set se bool space --P space httpd _ enable _ CGI space 1 and hit enter. Now let's restart Apache. Type in sudo space systemctl space restart space httpd. Now let's test it using Firefox. Type in Firefox space rhost1.localnet.com /cgi-bin /loggedin.sh. You will notice that it does not show which users are logged in. Also, an SE Linux alert has popped up. If we click on Show Alert, we can see why. Click on Details, and we can see that SE Linux has prevented the who command from reading the UTMP file. SE Linux keeps a close eye on which commands are accessing which resources. If we wanted to continue, we'd walk through the suggestions to get SE Linux to allow our script to execute. If we wanted to run our CGI script from a non-standard location, we'd want to change our SE Linux security context using semanage fcontext. The security context we want to change it to would be httpd://sys_script_exec_t. Before we can create a secure website, we need to create a self-signed certificate. In the RHCE exam, you will be given a key and certificate, but knowing the process of creating your own can help with understanding SSL and HTTPS. For this exercise, you need to be logged into rhost1 and have a terminal open. You also need to have installed mod_SSL and OpenSSL. Start by changing into the certificates directory by typing in cd space /etc/pki/tls/certs and hit enter. You should be able to do this as a normal user. Now let's generate the RSA private key. Type in sudo space openssl space gen pkey space -algorithm space RSA space -pkey opt space RSA _ keygen _ bits :2048 space -out space secure.localnet.com.key and hit enter. Type in your password if prompted. This should create a key called secure.localnet.com.key in the current directory. Type in ls to verify. Now that we have our private key, we need to create a certificate signing request or CSR. Type in clear and then type in sudo space openssl space req space dash new space dash key space secure.localnet.com.key space dash out space secure.localnet.com.csr and hit enter. This will ask you a few questions. For some options, hitting enter will accept the default option. For country, I'm going to put in US and hit enter. For state, I'll put in CA for California. For locality, I'll put in Los Angeles. For organization name, I'll put in LocalNet. For organizational unit, I'll put in LocalNet. For common name, I'll put in secure.localnet.com. For email address, I'll put in info@secure.localnet.com. And then I'll hit enter for other questions. This will create the CSR in the current directory. Type in ls to verify. We can see our key and our certificate signing request. Now we'll sign the certificate ourselves for testing purposes. Type in clear and then type in sudo space openssl space x509 space dash rec space dash days space 120 space dash sign key space secure.localnet.com.key space dash in space secure.localnet.com.csr space dash out space secure.localnet.com.crt and hit enter. This will create the signed certificate named secure.localnet.com.crt. Now list the results using ls. You should see the certificate signing request, and the private key. Now let's change the permissions on the key and move it to the private directory. Type in clear and then type in sudo space chmod space 600 space secure.localnet.com.key and hit enter. Now let's move it by typing in sudo space mv space secure.localnet.com.key space / private and hit enter. We can check the validity using OpenSSL. First, let's restart the Apache service. Type in sudo space systemctl space restart space httpd and hit enter. To check the validity using OpenSSL, type in sudo space OpenSSL space s_client space -connect space localhost :443 space -state and hit enter. If you get a lot of information on the screen, including details of your certificate, then you're done. Once again, you will most likely not have to do this in the exam, as they will provide you with a key and certificate. However, it's good to know how it all works, and it allows you to practice with secure Apache websites. For this challenge, we'll be focusing on a private web server in a non-standard location on RHOST1. You'll create a document root directory at /var/private site. You will manage all user and group permissions of this directory. The web server will need to continue to function after a restorecon or file system relabel. You will create an index.html file for this site. You will only allow authconfig overrides in this directory. You will create basic auth password protection of this site, which will only allow user 1 to access it. Set the password as you wish. Opening a web browser and entering rhost1.localnet.com/private site should prompt you for a username and password, which, if correct, will only allow user 1 to view the index.html file. To satisfy the web service private site challenge, we'll start by creating the document root directory and setting permissions. Type in sudo space mkdir space /var/private site. Now let's change ownership. Type in sudo space chown space user1 : user1 space /var/private site and hit enter. Now lastly, we'll change the permissions. Type in sudo space chmod space 0711 space /var/private site and hit enter again. Since we're using a non-standard directory, we need to let SE Linux know. To make the change to survive your file system relabel, we need to add a new rule to the SE Linux database and then restore the context to that. Type in clear, then type in sudo space se manage space fcontext space -at space httpd underscore sys underscore content underscore t, that's the type, space double quote /var /private site, left parentheses slash dot asterisk, right parentheses question mark double quote, and hit enter. This will change the context to the var private site directory and everything in it. Now restore the context using sudo space restorecon space /var /private site and hit enter. Now edit the Apache config by typing in sudo space vi space /etc /httpd /conf /httpd.conf and hit enter. The first thing we'll change is server admin. So type in / and type in server admin and hit enter. Change the server admin into root at rhost1.localnet.com. The next thing we'll change is the server name just down below. And uncomment it. The next line we'll change is document root. Change the document root to /var. The next thing we'll do is add a director for our /var /private site directory. Type in left angle bracket, directory with a capital D, space /var /private site, right angle bracket, new line, tab, allow override with a capital A and a capital O, space authconfig with a capital A and a capital C, new line, left angle bracket, / directory with a capital D, and right angle bracket. And then save and exit by pressing escape, :X, exclamation mark, and hitting enter. Now let's check the config by typing in sudo space httpd space -t and hit enter. If the syntax is okay, we can move on. Now go to the web document root directory and create the .htaccess file. Type in cd space /var /private site and hit enter. Type in clear, then type in vi space .htaccess and hit enter. In this file, we're going to add 4 lines. Type in auth type space basic and hit enter. Then type in auth name space, and you can enter anything you want in here, but I'm going to put in private site, space, enter your credentials. This is the prompt to the user. The third line is auth user file. This is very important. Space, double quote, /etc /httpd /conf .private site db, double quote. This line is very important, so we're going to copy it into a clipboard. The last line will be require user space user1. Make sure your capitalization is correct and then save and exit. Now we need to create the .private site db basic auth password file that we just specified. Type in cd space /etc /httpd /conf and hit enter. Now type in sudo space htpasswd space -c for create, then paste in the path you just copied, space user1 and hit enter. And then enter user1's password. This is the password they have to enter when they enter the site. We can verify this by typing in sudo space cat space and then paste in the path again and hit enter. Now let's change the ownership and permissions of this file. Type in clear and then type in sudo space change group space Apache and then paste in the path again and hit enter. And lastly, we'll change the permissions. Type in sudo space chmod space 0640 space and then paste in the path one more time and hit enter. We pasted the path each time to ensure that the path is correct. If it is not, this won't work. Now let's create an index.html file. Type in sudo space vi space /var /private site /index.html and hit enter. Just enter some text here. And save and exit. Now let's restart Apache by typing in sudo space systemctl space restart space httpd and hit enter. And lastly, we're going to verify with Firefox. Type in Firefox space rhost1.localnet.com /private site and hit enter. Enter user1 for the password. rephrase, enter user 1 for the username, rephrase, enter user 1 for the username, and enter user 1's password that you just set. And there you have it. If this does not work, then follow the Apache error log file by typing in sudo space tail space -f space /var /log /httpd /error_log and hit enter. For this exercise, you'll want to be logged into RHOST 1 with a terminal open. We will run a script under CGI that displays some information about the web server. Once you've done that, let's take a look at it. Type in less space /var /www /cgi-bin /loggedin.sh and hit enter. This script presents some HTML on the screen and then runs the date command. It also runs the who command. Let's see it work. Press Q to quit. First, let's make it executable. Type in sudo space chmod space +x space /var /www /cgi-bin /loggedin.sh and hit enter. Now we need to turn on an SE Linux boolean to allow CGI scripts. Type in clear, then type in sudo space set se bool space -P space httpd _ enable _ CGI space 1 and hit enter. Now let's restart Apache. Type in sudo space systemctl space restart space httpd and hit enter. Now let's test it using Firefox. Type in Firefox space rhost1.localnet.com /cgi-bin /loggedin.sh and hit enter. We see the output of the date command on the screen, but we also see an SE Linux alert which has popped up. If we click on show, we can see why. Now click on details. SE Linux has prevented the who command from reading the UTMP file. SE Linux keeps a close eye on which commands can access which resources. If we wanted to continue, we'd walk through the suggestions to get SE Linux to allow our script to execute, and then we'd run it again to see if there were more errors. This chapter covers network file services using NFS. In this chapter, we perform the following steps. First, we install NFS tools and configure NFS services. We manage SE Linux booleans for NFS services. We provide a network share to specific clients, and then we provide a network share for group collaboration. Lastly, we mount our simple NFS share, as well as mount our NFS share for group collaboration. Chances are that the NFS package is already installed on both of your virtual machines, but let's make sure. Start both VMs now and open terminals on them. To begin, make sure you're logged into your RHOST 1 VM and in a terminal, type in sudo space yum space install space -y space nfs-utils and hit enter. Type in your password if prompted. If it's already installed, it won't hurt anything. Now let's look at what's in the package. Type in clear and then type in rpm space -ql for query list space nfs-utils and hit enter. If you scroll up, you will see a mount.nfs command as well as a mount.nfs4 command. These are the mount commands for NFS exports. If you scroll down a bit, you'll see export fs, mount stats, and NFS stats, which are useful for getting information about our NFS exports and mounts. Another package that is not necessary to install but can be useful when dealing with NFS4 access control lists is nfs4-acl-tools. Let's install it by typing in clear. Type in sudo space yum space install space -y space nfs4-acl-tools and hit enter. Now let's look what's in this package. Type in clear and then type in rpm space -ql space nfs4-acl-tools and hit enter. We can see that we have tools for getting, setting, and editing NFS4 ACLs. Now let's switch over to our RHOST 2 VM and install both packages there as well. In a terminal, type in sudo space yum space install space -y space nfs-utils space nfs4-acl-tools and hit enter. Type in your password if prompted. Once that is done, we're ready to move on with the course. SE Linux, the mandatory access control system in Enterprise Linux 7, has controls that limit or grant access to all services, including NFS. Let's take a look at some of the booleans and security contexts that relate to NFS. You will want to be logged into RHOST1 with a terminal open. Before we begin, we need to start the NFS service if it is not running. In a terminal, type in sudo space systemctl space start space nfs-server and hit enter. Type in your password if prompted. Make it persistent by bringing your line back and change start to enable and hit enter again. Now, let's take a look at the security context of the running processes. Type in clear and then type in ps space -e capital Z space pipe space egrep space single quote NFS pipe RPC single quote. This will look for lines that include either NFS or RPC and the output of PS. We can see that the security context of RPC bind is RPC bind _T and the context of NFSD is kernel_T. Now let's take a look at the NFS configuration files. Type in clear and then type in ls space -l capital Z space /etc/exports and hit enter. This security context is exports_T. We can see from these examples that SE Linux is already NFS aware. However, if you want to do something special like using an NFS share as the base for a web or FTP server, you may have to change security context or a boolean in the SE Linux policy database. Let's take a look at the NFS-specific SE Linux booleans. Type in clear and then type in get SE bool space -a space pipe space grep space NFS and hit enter. As an example, the first line reads cobbler_use_NFS. In order for cobbler to use NFS, we need to switch this boolean to on. Currently, it's been restricted. Some of these booleans are self-explanatory, like httpd_use_NFS and logrotate_use_NFS. In both cases, if you want those services to use an NFS share as their file system, you need to turn these booleans on. An interesting one that has relevance to this course is samba_share_NFS. This is used if you are sharing the same directory via NFS and Samba. A couple more that we should be interested in are NFS_export_all_RO and NFS_export_all_RW. The former is useful if you want to export a share as read-only. The latter is useful if you want to export a share as read-write. Note that these two booleans are not required when files to be shared are labeled with a public_content_T type or public_content_RW_T type. If the files are not labeled accordingly, then we need to flip one or more of these booleans. We won't modify any of these booleans right now, but rather wait until we need to change them later. This way we can be sure that we are not opening security policy unknowingly. Before starting the following exercises, make sure you've watched the previous videos which installed and started the relevant services. Also make sure your name resolution for both hosts is working. Double-check the etc host file on both VMs to make sure the names match the relevant IP addresses before proceeding. Lastly, make sure you're logged into your RHOST1 VM and have a terminal open. Let's start this exercise by creating a new directory to export. In a terminal, type in sudo space mkdir space /home/user share. Type in your password if prompted. Let's verify this using ls. Type in ls space -l capital Z space /home and hit enter. We can see that our directory exists, and the SE Linux security context is home_root_t. This is because the root user created it in the /home directory. We will need to set a couple of SE Linux booleans for the shares we want to create. Type in clear, and then type in sudo space set se bool space -P space NFS_export_all_RO space on and hit enter. Now bring your line back and change RO to RW and hit enter again. Now verify by typing in get se bool space -a space pipe space grep space NFS_export and hit enter. We can see that both booleans are on now. Now let's add the NFS service to the firewall. Type in clear and then type in sudo space firewall-cmd space --permanent space --add-service space NFS and hit enter. And now reload the firewall rules. by typing in sudo space firewall-cmd space -- reload and hit enter. Now we need to run the NFS service and set it to start on boot. If you did this earlier in the chapter, it won't hurt to do it again now. Type in clear and then type in sudo space systemctl space start space nfs -server and hit enter. Now make it persistent by bringing your line back and changing start to enable. And hit enter again. If you're using NFS version 3, you will also want to start the RPC bind service. We will only be using NFS version 4 in this course, so we don't need to do this now. Now, let's create our export. Edit the etsy exports file using vi. Type in clear and then type in sudo space vi space /etc/ exports and hit enter. Go into insert mode by pressing I and then add /home/ user share space rhost2 left parentheses rw right parentheses. Save this and exit by pressing escape :x and hitting enter. Now export the entry by typing in sudo space exportfs space -avr and hit enter. If it worked, we should see the results in the output. Now let's verify by looking at the etab file. Type in cat space /var/lib/nfs/etab and hit enter. Here we can see the export with all options including the defaults. In the case of /home/usershare, we see that it's read-write and it is squashing root but not other users. We can see it squashing the root user to the user ID of 65,534. We can see which account this is by grepping the etsy password file. Type in grep space 65,534 space /etc/PASSWD and hit enter. We can see that it's the NFS nobody account. The last thing we need to be aware of is the ownership of the exported directory. NFS passes standard Unix permissions to the client. So if the user doesn't have write permissions on the NFS server, then they won't on the client either. Let's change the ownership of the /home/usershare directory to be owned by user1. Type in sudo space chown space user1 :user1 space /home/usershare and hit enter. And verify with ls. Type in ls space -ld /home/usershare and hit enter. Now we have an export ready for the client side. Let's log into our rhost2 VM and open a terminal. First, let's make a mount point. Type in sudo space mkdir space /home/user mount and hit enter. Type in your password if prompted. And now let's mount it. Type in sudo space mount space -t space nfs space rhost1 :home/usershare space /home/user mount and hit enter. Now type in mount again to verify that it's mounted. The very last line of this output shows the export is mounted. In later chapters, we'll spend more time looking into the client-side mount options. If your export doesn't mount, there are a couple things to troubleshoot. The main one is that your hostname resolution on both virtual machines is correct. Since we're using host names, they need to resolve to the correct IP addresses. Double check this in the etsy host files on both VMs. Also, verify that the nfs-server service is running. On rhost2, use showmount space -e space rhost1 to verify the export is visible. Next, verify that the firewall is configured correctly. Since our VMs are in a test environment, we can turn the firewall off temporarily to see if it helps. Turn the firewall off by typing in sudo space systemctl space stop space firewall d. Be sure to turn it back on as soon as you get the share working. If these steps don't solve the problem, consult the NFS troubleshooting video later in this course. For this exercise, we'll create an NFS share for group collaboration. Make sure you're logged into your rhost1 VM and have a terminal open. Due to the length of this exercise, I'll be rather brief in each step. For more detailed information, refer to the previous videos in this course. Let's start this exercise by creating a new directory to export. In a terminal, type in sudo space mkdir space /home/group share and hit enter. Type in your password if prompted. Let's also create a new user called user2. Type in sudo space useradd space user2 and hit enter. Let's take note of our user IDs by viewing the etsy password file. Type in cat space /etc/PASSWD and hit enter. We can see that the user ID for user 1 is 1000 and the user ID for user 2 is 1001. Remember this, it will be important later. Now let's create a group for collaboration and place both users in it. We're going to specify the group ID so that it doesn't mess up the order of new users added to the system later. Type in clear and then type in sudo space group add space -g space 6000, that's the group ID, space group collab. That's the name I've given it, and hit enter. Now let's add our users to the new group. We'll use usermod for this. Be sure to include the lowercase a option, otherwise the users will be removed from the current groups. In our case, this would take sudo privileges away from user 1. Type in sudo space usermod space -a space -G space group collab space user 1 and hit enter. And then bring your line back and change user 1 to user 2 and hit enter again. We can verify they're in our group by looking at etc group. Type in cat space /etc/group and hit enter. We can see the group at the bottom and both users are in it. Now that we have our users in group, let's change the ownership of our group shared directory. Type in clear and then type in sudo space chown space nfs nobody group collab space /home/group share and hit enter. In order to enable inheritance so all newly created files are accessible to all members, we need to set the sgid bit on the directory. Type in sudo space chmod space 2770 space /home/group share and hit enter. And then verify with ls. Type in ls space -ld space /home/group share and hit enter. Here we can see the S in the group section of the permissions, and the ownership is the NFS nobody user and group collab group. We need to set a couple of SE Linux booleans for the shares we want to create. Type in clear and then type in sudo space set se bool space -P space nfs underscore export underscore all underscore ro space on and hit enter. And then bring your line back and change RO to RW and hit enter again. Now let's also add the NFS service to the firewall. Type in clear and then type in sudo space firewall-cmd space --permanent space --add-service space NFS and hit enter. If it's already been added, that's fine. Now let's reload the firewall rules. Type in sudo space firewall-cmd space --reload and hit enter. Now run the NFS service and set it to start on boot. Type in clear and then type in sudo space systemctl space start space nfs-server and hit enter. And to make it persistent, bring your line back and change start to enable. Now let's create the export. Edit the /etc/exports file using vi. Type in sudo space vi space /etc/exports and hit enter. Go into insert mode by pressing your I key and then add a line to the end. In our new line, make sure you add /home/group share space rhost2 left parentheses rw comma no underscore root underscore squash right parentheses and save by pressing escape x exclamation point and hitting enter. Now export the entry by typing in sudo space exportfs space -avr and hit enter. If it worked, we should see the results in the output. Now we have an export shared and ready to be mounted on the client. Before you attempt this exercise, make sure you did the previous exercise, which had you create a share for group collaboration. Be sure your RHOST1 VM is still running. Be sure your RHOST2 VM is not running. If it is, shut it down first. Now discard the save state and boot it up. If you are restoring your virtual machines from the save state, as I do, then sometimes NFS gets locked up because a server comes up instantly running and the client comes up instantly mounted, but the communication between the two gets wonky. Once RHOST2 is booted up, log in as user 1 and open a terminal. First, we'll create a mount point. Type into the terminal sudo space mkdir space /home/group mount and hit enter. Type in your password if prompted. Let's also create user 2 now. Type in sudo space user-add space user2 and hit enter. Let's verify that our user IDs are the same as RHOST1. Type in cat space /etc/passwd and hit enter. I can see that the user ID of user 1 is 1000, and the user ID of user 2 is 1001, just like they are on RHOST 1. If the user IDs of your users don't match on both RHOST 1 and RHOST 2, you'll need to change them now. NFS passes user IDs between the client and host, so they need to be the same. Because we need to log in with a new user, we'll need to give it a password. Type in clear and then type in sudo space passwd space user2 and hit enter, and then give user2 a password. Now let's create the shared group. Type in clear and then type in sudo space group add space -g space 6000, which is the group ID we used on RHOST 1, space group collab, and hit enter. Now add the users to it. Type in sudo space usermod space -a space -G space group collab space user1 and hit enter. And bring your line back and change user1 to user2 and hit enter again. We can verify this by viewing etc group. Type in cat space /etc /group and hit enter. We can see that our users are in the new group, but if we look at our current session, we'll find that we are not. Run the groups command to see this. Type in clear and then type in groups and hit enter. To solve this, you can log out and log back in again. Once you log back in as user 1, open a terminal. Now let's mount the share. Type in sudo space mount space -t space nfs space rhost1 /home /group share space /home /group mount. Verify this using mount and look at the last line. Now we need to test this. Let's create a file as user1 and as user2. As user1, type in clear and then type in touch space /home /group mount /user1.txt and hit enter. Let's change to user2 using the su command. Type in su space hyphen space user2 and hit enter. And enter user2's password. Now let's create a file using user2. Type in touch space /home /group mount /user2.txt and hit enter. Now let's verify with ls. Type in ls space -l space /home /group mount and hit enter. We can see that both users can write to this directory and that the group ownership of both files is group collab. The last step would be to add this mount to the etcfs tab file or AutoFS configuration to get it to mount automatically. Refer to previous videos for instructions on how to do this. This challenge concerns creating an NFS share for group collaboration. Your RHOST 1 VM will have a directory at /var/NFS share shared via NFS. Your RHOST 2 VM will mount the share automatically at boot on /home /NFS collab. Other hosts on the network cannot mount this share at all. However, other hosts on the network can mount other shares from your RHOST 1 VM. 3 users will have read and write access to the share: Bob, Ted, and Sally. No other users will be able to access the share even if they exist on RHOST 2. Lastly, you will need to resolve any SE Linux access problems. I've tried to be brief in explaining this challenge without giving away too much. Read through it, think about it, and execute it. Double check your solution when you're done. This challenge concerns creating an NFS share for group collaboration. Because of the length of the solution, we won't be verifying anything until the end. You can take the time to verify each step if you wish. We'll start the solution to the NFS share for group collaboration challenge by creating the shared directory. On RHOST 1, type in sudo space mkdir space /var/NFS share and hit enter. Now we need to create the 3 users I've specified. Type in sudo space useradd space Bob and hit enter. Bring your line back and change Bob to Ted and hit enter again. Bring your line back one more time and change Ted to Sally and hit enter again. Now let's give them passwords. Type in sudo space passwd space Bob and hit enter. Give Bob a password and then bring your line back and change Bob to Ted and hit enter again. And lastly, bring your line back again, change Ted to Sally and hit enter. Once they have passwords, look at the etc password file to see what the user IDs are. Type in cat space /etc Rephrase, type in cat space /etc/PASSWD and hit enter. We can see their user IDs are from 1002 to 1004. We need to note these user IDs for later. Since we're using the etc password file for user management instead of LDAP, they have to match on both hosts. Now let's create the group our users will belong to. Type in clear and then type in sudo space group add space -g space 6000, that's their group ID number, space NFS group, and hit enter. Now let's add our users to it. Type in sudo space user mod space -a space -G space NFS group space Bob and hit enter. Bring your line back, change Bob to Ted, and bring your line back and change Ted to Sally. And hit enter again. Now let's change the ownership of the collaboration directory to our group. Type in sudo space chown space NFS nobody NFS group space /var/NFS share and hit enter. Now we'll turn on inheritance so all newly created files are accessible to all members. To do this, we need to set the SGID bit on the directory. Type in sudo space chmod space 2770 space /var/NFS share and hit enter. Now we need to set a couple of SE Linux booleans for the shares. Type in clear, and then type in sudo space set SE bool space -P space NFS underscore export underscore all underscore RO space on and hit enter. Then bring your line back and change RO to RW and hit enter again. Now let's add the NFS service to the firewall and reload the config. Type in clear, and then type in sudo space firewall-cmd space --permanent space --add -service space NFS and hit enter. And then reload the firewall config by typing in sudo space firewall-cmd space --reload and hit enter again. Now run the NFS service and set it to start at boot. Type in sudo space systemctl space start space NFS -server and hit enter. And bring your line back and change start to enable. And hit enter again. Now let's create an export. Edit the exports file using VI. Type in clear and then type in sudo space VI space /etc/exports and hit enter. In this file, add a line /var/NFS share space rhost2, the host that we're going to share it to, left parentheses RW, comma, no underscore root underscore squash, right parentheses. The no root squash option is not required, but is helpful for testing. Now save and exit by pressing escape :x exclamation mark and hitting enter. Now export the entry by typing in sudo space exportfs space -avr and hit enter. Now let's go to your rhost2 VM. You're going to log in and in a terminal make the mount point by typing in sudo space mkdir space /home/nfs collab and hit enter. Type in your password if prompted. Now let's create the 3 users I specified. The user IDs need to match the rhost1 user IDs. Type in sudo space user add space -u 1002 space Bob and hit enter. Bring your line back and change 1002 Bob to 1003 space Ted and hit enter again. Then bring your line back one more time and change 1003 Ted to 1004 Sally and hit enter again. Now we need to give them passwords. Type in sudo space PASSWD space Bob and hit enter. Bring your line back and change Bob to Ted and hit enter again. Bring your line back one more time, change Ted to Sally, and hit enter again. Once they all have passwords, we can move on. Now let's create the shared group. Type in clear and then type in sudo space group add space -g space 6000 space NFS group and hit enter. Now let's add the users to it. Type in sudo space user mod space -a space -G NFS group space Bob. Bring your line back, change Bob to Ted, hit enter again. Bring your line back, change Ted to Sally, and hit enter again. Now let's add the share to the etc FS tab. You can mount it first manually if you wish to verify it works. Type in clear and then type in sudo space vi space /etc/fs tab and hit enter. In this file, go to the end and add a line. In this line, type in rhost1 /var/NFS share tab /home/NFS collab tab NFS4 tab defaults tab 0 space 0. Note, there are many NFS mount options that can be useful here. Also, it's a much better idea to mount the NFS volume with AutoFS, but we won't go into that now. Double check the Linux System Engineer NFS and Samba course in the course library for more information. Save and exit by pressing Escape:*X, exclamation mark, and hitting Enter. Now let's mount the share from the FS tab file by typing in sudo space mount space -a and hit Enter, and verify by typing in df. The ultimate test would be to log into Bob, Ted, and Sally now, change into the group collaboration directory, and create some files. Let's test Bob. Type in su space hyphen space Bob and hit Enter. Enter Bob's password. And then cd into the directory. Type in cd space /home /nfs collab and hit Enter. Now let's create a file. Type in touch space Bob's file. Hit Enter. And then type in ll. We can see the file is owned by the NFS group and the permissions are read, write, read. So Ted and Sally can have access to it because they're part of the NFS group and other users cannot. This chapter covers network file services using Samba. In this chapter, we install SMB services using the Samba server. We manage SE Linux for SMB services. We learned about Samba global configuration options, and we learned about Samba share configuration definitions. We then provide network shares to specific clients. We also provide network shares suitable for group collaboration. We then automatically mount our shares securely using a credentials file. Lastly, we mount a share for group collaboration. Before you start, you might want to download and print the Samba cheat sheet included with this chapter. For this exercise, you'll need both your RHOST 1 and RHOST 2 VMs booted up. Start by being logged into RHOST 1 with a terminal open. Let's install the Samba server packages now. Type in sudo space dnf space install space -y space samba space samba -client and hit Enter. The Samba package is the server. Samba-client is a client-side tool that we can use to test our shares for troubleshooting purposes. This should have installed the Samba server and any dependencies. Let's see what it installed. Type in clear and then type in rpm space -qa space pipe space egrep space smb pipe samba pipe cifs and hit Enter. This shows the common Samba packages and some libraries in addition to the server we just installed. Now let's switch over to RHOST 2, log in as user 1, and open a terminal to install the Samba client packages. In a terminal, type in sudo space dnf space install space -y space cifs -utils space samba space samba-client and hit Enter. Just like before, we'll use the rpm command to see what's installed. Type in clear and then type in rpm space -qa for query all space pipe space egrep space smb pipe samba pipe cifs . This should look for smb, samba, or cifs. This shows the common Samba programs as well as libraries and the tools we just installed. In order to keep troubleshooting simple, you may want to disable the NFS shares in /etc/fs tab. Just edit that file and comment out the NFS shares from the previous chapter. Also, you'll want to unmount those shares if they're currently mounted. At the end of this course, and after your Samba shares are working perfectly, you can re-enable whichever portions you would like. Troubleshooting Samba and NFS is just easier this way. There are multiple SE Linux booleans and types that we may have to modify in order to have a working Samba server. We can take a look at these now. The best way to know what is necessary is to read the example configuration file installed with the Samba server. Be sure you're logged into RHOST 1 with the terminal open. Type into the terminal sudo space vi space /etc /samba /smb.conf.example and hit Enter. Near the top, it explains the various booleans. If you want to run your Samba server as a primary domain controller and use the user add and group add commands, then turn the Samba domain controller boolean on. If you want to share home directories, you need to turn on the Samba enable home-dirs boolean. Whenever you create a parent directory that will be shared via Samba, you need to change its security context to samba_share_t. You can either do this temporarily with changecon, or you can change the security policy itself with the semanage command. If you only change the context with changecon, then the next time you do a restore con or relabel the entire file system, its type will revert back to what the policy database specifies, so be aware. If you want to share system directories, you will need to turn on Samba export all RO or Samba export all RW booleans. If you want to run scripts on events in Samba, then you'll need to copy them to /var/lib/samba/scripts so Samba can run them. Make sure you don't move them or copy them while saving permissions, or the security context won't be right. If the context is incorrect, then restore the context by using the restorecon command. Exit VI by pressing escape:Q and hitting enter. There are a couple more booleans we need to be aware of. Let's take a look. Type in get SEBool space -a space pipe space egrep space single quote SMB pipe Samba pipe CIFS single quote and hit enter. We see the ones we've already talked about, but also Samba_share_NFS. If you want to share out the same directory as both NFS and Samba, you need to set this boolean to on. The global options in the Samba configuration file control how Samba works, including how it identifies itself and which mode it runs in. Network-related options including the workgroup name, server string, and NetBIOS name. We can also set the network interfaces to provide services on. This is useful when we have multiple network interfaces in our host and we only want to serve files on one of them. We can also decide which host to provide services to using the host allow and host deny option. Samba provides log options that allow us to define the log file and the maximum log size. We can use variables in many options to ease configuration. For instance, we can even have logs created dynamically for each client system by specifying log file equals %m.log, or one log per share by specifying log file equals %S.log. Samba provides different security modes to run in. Security equals ADS uses Kerberos to authenticate Active Directory users. Security equals domain authenticates users to an NT4 primary domain controller or backup domain controller. Security equals user authenticates users against a local database, which is the default mode. There are 3 different password database backends: SMB password, TDB SAM, and LDAP SAM. PassDB backend equals SMB password uses the /var/lib/samba/private/SMB password file to store passwords. PassDB backend equals TDB SAM sets up a trivial local account database in /var/lib/samba. This is the default PassDB backend. PassDB backend equals LDAP SAM uses a remote LDAP account database. Samba has many configuration options specific to shares. We'll go over some of the more common ones now. Comment is a string of text that is displayed when a client gets information about the share. Browsable controls whether a share is visible to clients browsing the network. Writable means just that. It determines if the share is writable. Valid users is a list of users or groups that are allowed to access the share. Write list is a list of users or groups that are allowed to write to the share. Path is used to define the absolute path to the file system location. Public allows users to access the share without entering a password. Guest only controls if only guests can access the share. Force group defines which group all newly created files are owned by. Create mask defines the default permissions of newly created files. To learn more about any of these directives, check the man page for smb.conf. For this exercise, we're going to create a simple public Samba share. Be sure you're logged into your RHOST1 VM and have a terminal open. We'll start by creating a directory. Type in sudo space mkdir space /home/samba public and hit enter. We also need to set a couple of SE Linux booleans before we move on. Type in sudo space set SEBool space -P space samba _ export _ all _ RO space on and hit enter. Then bring your line back and change RO to RW and hit enter again. Now let's change the ownership and permissions of the /home/samba public directory so the nobody user can write to it. Type in sudo space chown space nobody nobody space /home/samba public and hit enter. And let's set the permissions for the nobody user. Type in sudo space chmod space 775 space /home / Samba public and hit enter again. Now let's change the SE Linux policy database to expect our /home / Samba public directory to have the public _content_rw_t type. We'll do this with the se manage command. Type in clear, then type in sudo space se manage space f context space -at space public _content _rw_t. That's the type. Space double quote /home / Samba public left parentheses /dot asterisk right parentheses question mark double quote and hit enter. This will change the expected context in /home / Samba public and anything in it. Now let's use the restorecon command to have Linux apply the context. Type in sudo space restorecon space /home / Samba public and hit enter. And let's verify it. Type in ls space -d capital Z space /home / Samba public and hit enter. The permissions, ownership, and security context look fine, so let's move on. Now let's add the Samba service to the firewall rules. Type in clear and then type in sudo space firewall-cmd space --permanent space --add -service space Samba and hit enter. And now let's reload the firewall rules. Type in sudo space firewall-cmd space --reload. Next, let's edit the smb.conf file using vi. Type in clear and then type in sudo space vi space /etc /samba /smb.conf and hit enter. Go to the end of the file, go into insert mode by pressing the I key, and add a new line. In this line, type left square bracket, Samba public, right square bracket. Hit enter and hit tab. Comment equals public Samba share. Add a new line. Path equals /home / Samba public. Add a new line. Writable equals yes. Add a new line. Public equals yes. This gives us a share named Samba public and is backed by the /home / Samba public directory. It's writable and public. Save and exit by pressing escape :x exclamation mark and hit enter. Now test the configuration using test parm. Type in test parm with no arguments and hit enter. And then hit enter again. We can see that the configuration is valid. Now we'll need to start the Samba service and make it persistent. Type in clear and then type in sudo space systemctl space start space smb and hit enter. Then bring your line back and change start to enable and hit enter again. And bring your line back one more time and change enable to status and hit enter again. Everything looks good, so let's move on. Now we'll use the smb client command to list our local shares. This is a good troubleshooting step. Type in clear and then type in smb client space -L space / localhost and hit enter. Hit enter again to log in anonymously. This should show our Samba public share and some information about our Samba server. Now let's use smb client to log in. Type in clear. Type in smb client space / localhost / Samba public and hit enter. And hit enter again to log in anonymously. If it runs, you'll have an FTP-like interface. We'll take a closer look at its functionality in a later video. For now, let's just make sure we can write to the disk. Use the mkdir command to make a directory. Type in mkdir space testdir and hit enter. If it's successful, you're almost done. We'll mount it in a later video. I like to use the smb client command to test and access shares to troubleshoot Samba. It's a simple tool that provides decent output. Now let's exit smb client by typing in quit. For this exercise, we're going to create a private Samba share. To keep this exercise brief, we will not duplicate all of the steps that we did in earlier chapters. Make sure you completed the exercise in creating a public share before doing this one. Ensure the firewall is configured for Samba and make sure the Samba service is running. Make sure you're logged into your RHOST1 VM and have a terminal open. We'll start by creating a directory. Type in sudo space mkdir space /home / Samba private and hit enter. Type in your password if prompted. Now let's change the ownership and permissions of this directory so user 1 can write to it. Type in sudo space chown space user1 user1 space /home / Samba private and hit enter. So now let's set the permissions. Type in sudo space chmod space 775 space /home / samba private and hit enter. Now let's change the SE Linux policy database to expect our Samba private directory to have the public_content_rw_t type. We'll do this with the se manage command. Type in sudo space se manage space fcontext space -at space public_content_rw_t space double quote /home / samba private left parentheses slash dot asterisk right parentheses question mark double quote and hit enter. This will change the expected context in /home / samba private and anything in it. Now let's use the restorecon command to have Linux apply the context. Type in sudo space restorecon space /home / samba private and hit enter. Now that the context has been fixed, let's move on. Now let's edit the smb.conf file using vi. Type in clear and then type in sudo space vi space /etc /samba /smb.conf and hit enter. Go into insert mode by pressing the I key and then go to the bottom of the file. We're going to add a new entry called Samba Private. Type in left square bracket, Samba Private, right square bracket. Add a new line and then type in comment equals private Samba share available to user 1. Add a new line, path equals /home / samba private. Add a new line, writable equals yes. Add a new line, valid users equals user 1. Add a new line, write list equals user 1. Add a new line, public equals yes. This will give us a share named Samba Private and is backed by the /home / Samba Private directory. It's writable and public. Save this by pressing escape :x and hit enter. Now let's test the configuration using test parm and hit enter. And then hit enter again. We can see that the configuration is valid. Now let's create the Samba user named user1 and set its password. Type in clear and then type in sudo space smb_passwd space -a space user1 and hit enter. And then give user1 a password. Now let's view the output of the pdb_edit command to see our new user. Type in sudo space pdb_edit space -L lowercase v and hit enter. Now let's restart the Samba service. Type in clear and then type in sudo space systemctl space restart space smb and hit enter. Everything looks good, so let's move on. Now we'll use the smb client command to list our local shares. This is a good troubleshooting step. Type in smb client space -N L space / localhost and hit enter. This should show our Samba private share and some information about our Samba server and not prompt us for a password. Now let's switch over to RHOST2, open a terminal and try to log into our share using smb client. Type in smb client space / rhost1 / samba private space -U space user1 and hit enter, and then type in user1's password. If you're able to log in this way, then the share is ready to be mounted. Type in quit. To mount the share, we'll start by creating a mount point in /home. Type in sudo space mkdir space /home / samba private and hit enter. Type in your password if prompted. Now let's mount the share by typing in sudo space mount space -t space cifs space -o space username equals user1 space / rhost1 / samba private space /home / samba private and hit enter. And type in user1's password. Now verify by typing in df and hit enter. We can see that our private share is now mounted. Let's test our ability to write to it by touching a file. Type in clear and then type in touch space /home / samba private /file.txt. If that worked, we're in good shape. We might not want to manually mount our share each time we boot up, so we'd put an entry in /etc/fs tab. However, since our share has a password, we'd have to put that in plain text, which isn't good. The solution is to use a credentials file, which we'll cover separately. For this exercise, you want to be logged into your RHOST2 VM and have a terminal open. Auto-mounting a private share can be problematic because even though we can specify username equals and password equals in the /etc/fs tab file, everyone can see the contents as that file is world readable. The solution is to put the username and password information in a credentials file that only root can read, and then reference that file in the /etc/fs tab. Let's create our credentials file for our private share using vi. type in sudo space vi space /root /samba-private.cred and hit enter. Type in your password if prompted. The name is arbitrary. You can name yours whatever you want. If you save it somewhere else besides /root, you'll need to make sure nobody but root can read it by changing permissions. Now let's go into insert mode by pressing the I key, and then add our username and password key value pairs. In my case, it's username equals user1, and then password equals password. Enter your password here. Now save and exit by pressing escape :X and hitting enter. Now we'll reference the credentials file in the /etcfs tab. Let's edit that file with vi. Type in sudo space vi space /etc/fs tab and hit enter. Go into insert mode by pressing the I key and then add a line at the end. First, I'll enter all information including username and password so you know what it looks like. Although this would work, it's not very secure. Let's make it more secure and replace the username and password with the location to the credentials file. So I'm going to replace username equals and password equals with credentials equal. In my case, it'll read credentials equals /root /samba-private.cred. Save and exit by pressing escape :X and hitting enter. If your private share is mounted, then unmount it now. Type in sudo space umount space /home /samba-private and hit enter, and verify with df. Now let's mount up anything in the /etcfs tab that isn't mounted already. Type in sudo space mount space -a and hit enter, and then type in df to verify again. There we have it. We mounted a private share without entering a password or exposing it to prying eyes. In this exercise, we'll create a Samba share for group collaboration. You should have your RHOST1 VM booted up, and you should be logged in with the terminal open. We'll be using user 1 and user 2. Both were created in the first half of this course. Let's start by creating our mount point in /home. In a terminal, type in sudo space mkdir space /home /samba group and hit enter. Type in your password if prompted. Now let's create a new group called Samba Collab with a group ID of 6001 and add user 1 and user 2 to it. Type in sudo space group add space -g space 6001 space Samba Collab and hit enter. Now let's add our users. Type in sudo space usermod space -a space -G space Samba Collab space user 1 and hit enter. Bring your line back and change it to user 2 and hit enter again. Now let's change the ownership of our Samba group directory to our new Samba Collab group. Type in sudo space chown space Samba Collab space /home /Samba group and hit enter. Now let's set the permissions so only the user owner and group owners can access it. Type in sudo space chmod space 770 space /home /Samba group and hit enter. The SE Linux security context needs to be changed as well. Type in sudo space se manage space fcontext space -at space public _content _rw_t space double quote /home /Samba group left parentheses /.*, right parentheses double quote and hit enter. And then run restorecon to apply the new context. Type in sudo space restorecon space /home /Samba group and hit enter. Now let's verify with ls space -d capital Z space /home /Samba group and hit enter. We see the user owner is root and the group owner is Samba Collab. The user owner and group owners have RWX permissions and other has nothing. The directory has the public _content _rw_t security context. We also need SE Linux booleans turned on to allow exporting RW and RO shares. We also need to allow SMB traffic through the firewall and the Samba service needs to be running. We did all of these things in the first video creating the simple public share, so we won't do them again here. Just beware if you're starting at this exercise, you'll want to go back and do the Samba simple public share exercise first. You will also want to do the Samba private share exercise as well. Now let's edit our smb.conf file with vi. Type in clear and then type in sudo space vi space /etc/samba /smb.conf and hit enter. Go into insert mode by pressing your I key and then go to the bottom of the file and add a new line. Here we'll add a new share. and type in comment equals Samba share for group collaboration. New line, path equals /home/Samba group. New line, browsable equals no. New line, public equals no. New line, valid users equals @Samba collab. New line, write list equals @Samba collab. New line, writable equals yes. Force group equals Samba collab. Note that this does not have an @ sign at the beginning. New line, create mask equals 0770. This will create a writable but not browsable share that is only accessible by the Samba collab group. All files will be owned by the Samba collab group, which will have full RWA access to them by default. Save and exit by pressing escape:*X and hitting enter. Run the test prime command to test for syntax errors. If there are errors, fix them now, otherwise let's move on and hit enter again. When we created a private share, we gave user 1 an SMB password. We'll now do that for user 2 as well. If you did not do this for user 1 earlier, then do it now for both. Type in clear, then type in sudo space SMB_PASSWD space -A space user 2 and hit enter. Type in a password for user 2. To view the user information for both users, run sudo space pdb edit space -L_V and hit enter. We should see both user 1 and user 2 here. Now let's restart the Samba service and then get the status. Type in clear and then type in sudo space systemctl space restart space SMB and hit enter. Now bring a line back and change restart to status and hit enter again. If everything looks good, we can test it. Let's list the shares on RHOST 1 using SMB client. Type in clear, then type in SMB client space -L space / localhost space -U space user 1. Enter user 1's password and hit enter again. We should see all shares. We can also bring our line back, change user 1 to user 2, and try it again to be sure that both can see the Samba group share. Now we have a group collaboration share ready to be mounted on RHOST 2. For this exercise, we'll mount our Samba group collaboration share. Make sure you're logged into RHOST 2 with the terminal open. Let's create the Samba collab group with the same group ID that we used on RHOST 1. Type in sudo space group add space -G space 6001 space Samba collab and hit enter. Type in your password if prompted. Next, let's add both user 1 and user 2 to our Samba collab group. Type in sudo space usermod space -A space -G space Samba collab space user 1. Bring your line back and change user 1 to user 2 and hit enter again. Now let's try to list the Samba group share using SMB client as user 1 and user 2. Type in SMB client space -L space //RHOST1 /Samba group space -U space user 1 and hit enter. Enter user 1's password. Bring your line back and change user 1 to user 2 and hit enter. Now that that worked, let's go ahead and try to mount it. Type in clear and let's make our mount point. Type in sudo space mkdir space /home/Samba group. Type in sudo space mount space -T space CIFS space -O space username equals user 1 space //RHOST1 /Samba group space /home/Samba group and hit enter. And type in user 1's password. Let's verify this by typing in df. We can see that it mounted. We can get more information on the mount by looking at the output of mount. Type in clear and then type in mount space pipe grep space Samba group and hit enter. Auto-mounting this share is the same as any other that requires authentication. Follow the previous video on creating a credentials file and referencing it in the etcfs tab file. This challenge concerns creating a Samba share for group collaboration with hidden credentials. Your RHOST 1 VM will have a directory at /var/Samba share shared via CIFS as Samba collab. Your RHOST 2 VM will mount the share automatically at boot at /home/Samba collab using credentials hidden from prying eyes. This share is only accessible to RHOST 2, no other host can mount it. 3 users will have read and write access to the share: Bob, Ted, and Sally. No other users will be able to access the share, even if they exist on RHOS 2. You will need to resolve any SE Linux access problems. This is a common Samba share configuration and is similar to the NFS challenge. However, there are differences in the way Samba and NFS handle users and authentication, as well as SE Linux. This challenge concerns creating a Samba share for group collaboration. I will not be verifying anything until the end. You can take the time to verify each step if you wish. Be sure you're logged into your RHOS 1 VM with the terminal open. Let's make sure the packages are installed first. Type in sudo space yum space install space -y space samba space samba-client and hit enter. Once it's installed, type in clear. Now create the share directory. Type in sudo space mkdir space /var/samba share and hit enter. Now let's create the 3 users I've specified. If you still have them from the NFS challenge, you can skip this section. If not, type in sudo space user add space Bob and hit enter. Bring a line back, change Bob to Ted. Bring a line back, change Ted to Sally. And hit enter again. Now let's give them Linux passwords. Type in sudo space passwd space Bob and hit enter. And give Bob a password. Bring a line back, change Bob to Ted. And give Ted a password. Bring your line back one more time and change Ted to Sally. And give her a password. And type in clear. Now let's create the group that our users will belong to. Type in sudo space group add space -g space 6001 space samba group and hit enter. Now we'll add our users to it. Type in sudo space usermod space -a space -G samba group space Bob and hit enter. Bring your line back, change Bob to Ted, hit enter again. Bring your line back, change Ted to Sally, and hit enter again. Samba maintains its own database for users. Let's create the Samba users and set their passwords. Type in sudo space smb passwd space -a for add space Bob and hit enter. And give Bob a password. Bring your line back, change Bob to Ted, and give Ted a password. Bring your line back and change Ted to Sally, and give Sally a password. And type in clear. Now let's change the ownership of the collaboration directory to our group. Type in sudo space change group space samba group space /var/samba share and hit enter. Now let's set the permissions. Type in sudo space chmod space 0770 space /var/samba share and hit enter again. The SE Linux security context needs to be changed as well. Type in sudo space se manage space f context space -at space samba _share _t space double quote /var/samba share left parentheses /* right parentheses question mark double quote and hit enter. And then run restorecon to apply the new context. Type in sudo space restorecon space /var/samba share and hit enter again. We also need to set a couple of SE Linux booleans to ensure our share works. Type in sudo space set se bool space -P space samba _export _all _ro space on and hit enter. And then bring your line back and change ro to rw and hit enter again. Now let's add the Samba services to the firewall rules. Type in clear, and then type in sudo space firewall-cmd space --permanent space --add -service equals Samba and hit enter. Now let's reload the firewall rules by typing in sudo space firewall-cmd space --reload and hit enter again. Now let's edit our smb.conf file with vi. Type in sudo space vi space /etc/samba /smb.conf and hit enter. We're going to add one line into the global section, and that's going to be hosts space allow space equals space the IP address of your RHOS 2 VM. In my case, it's 192.168.1.109. Add your RHOS 2 VM IP address here. Now we're going to add a new share. So inside square brackets, type Samba collab, new line, comment space equals space Samba share for group collaboration, new line, browsable equals yes, new line, path equals /var/Samba share, new line, public equals no, new line, valid space users equals space at Samba group, and new line. Right space list space equals space at Samba group, new line. Writable equals yes. Force space group equals space Samba group without a tilde symbol. New line, create space mask space equals space 0770. This will create a writable share that is only accessible by the Samba group on RHOS2. All files will be owned by the Samba group, which will have full RW access to them by default. Save and exit by pressing escape:*X, exclamation mark, and hitting enter. Now let's restart the Samba service and make it persistent. Type in sudo space systemctl space restart space SMB and hit enter. And then bring your line back and change restart to enable and hit enter again. Now your server is configured. Now go to your RHOS2 VM and make sure the packages are installed. In a terminal, type in sudo space yum space install space -y space cifs-utils space samba space samba-client and hit enter. Once the packages are installed, type in clear. Now let's create the 3 users I've specified. If you still have them from the NFS challenge, you can skip this step. If not, type in sudo space user add space -u space 1002 space bob and hit enter. Bring your line back and change 1002 bob to 1003 space ted and hit enter again. Then bring your line back and change 1003 ted to 1004 space sally and hit enter again. Now let's give them Linux passwords. Type in sudo space passwd space bob and hit enter. Give Bob a password. Then bring your line back, change Bob to Ted, and give Ted a password. And lastly, bring your line back and change Ted to Sally and give her a password. And then type in clear. Let's create the Samba group with the same group ID that we used on RHOS1. Type in sudo space group add space -g space 6001 space Samba group and hit enter. Now let's add our users to it. Type in sudo space usermod space -a space -G space Samba group space Bob and hit enter. Then bring your line back and change Bob to Ted, and bring your line back and change Ted to Sally and hit enter again. Now let's create the mount point. Type in clear and then type in sudo space mkdir space /home /Samba collab and hit enter. Now let's create our credentials file for our private share using VI. Type in sudo space VI space /root /Samba private.cred and hit enter. In this file, we're going to add the username and password. Go into insert mode and then type in username equals Bob, for example. And then the next line, type in password equals, and then whatever you set Bob's password to. Then press escape:*X exclamation mark and hit enter. Now we'll reference the credentials file in the /fs tab. Let's edit that file using VI. Type in sudo space VI space /etc/fs tab and hit enter. We'll go to the bottom of the file and we'll add a line. For the device, type in //rhost1 /Samba collab. Tab. For the mount point, type in /home /Samba collab. For the file system, type in CIFS. Tab. For the file system options, type in credentials equals /root /Samba private.cred. And for the last 2 options, type in 0 space 0. Save and exit by pressing escape:*X exclamation mark and hitting enter. Now let's mount the share from the FS tab. Type in sudo space mount space -a and hit enter. And we can verify by typing in df. The ultimate test would be to log in as Bob, Ted, or Sally now, change into the Samba collab directory and create some files. Let's try that. Type in su space -space Bob and hit enter. type in Bob's password, and then hit enter again. Now type in cd space /home/Samba collab and hit enter. And we'll touch a file by typing in touch space file, and we'll look at the file permissions. We can see that the file is owned by the Samba group, and the permissions are RW for Bob and RW for the Samba group. So Ted and Sally can access it, but nobody else can. This chapter covers Simple Mail Transfer Protocol or SMTP services using Postfix. In this chapter, we install and configure SMTP mail services using the Postfix mail server. Then we manage SE Linux for SMTP services. We configure a local mail server. Then we create a null client mail relay. And lastly, we create a mail gateway. It's impossible to adequately cover something as complex as SMTP mail servers in one chapter. However, this chapter covers a lot of the foundational knowledge and gets you started. To get started with Postfix, we'll want to install it first. Just to make sure that SendMail is not installed, we'll also attempt to uninstall it. Be sure you're logged into your RHOST1 VM as user 1 and have a terminal open. In the terminal, type in sudo space yum space remove space sendmail and hit enter. Type in your password if prompted. If SendMail is installed, it will remove it now. Otherwise, it will provide a warning message and return you to your prompt. Now let's install Postfix. Type in sudo space yum space install space -y space postfix and hit enter. If it's already installed, we can proceed with the next command. Now let's make Postfix the default MTA. Type in clear, type in sudo space alternatives space --set space MTA space /usr/sbin/sendmail.postfix and hit enter. Now Postfix is installed and ready. Postfix by default works out of the gate with SE Linux. In this video, we'll look at the security context that Postfix runs under, as well as any SE Linux booleans that pertain to Postfix operations. Let's start by looking at the SE Linux security context for the running processes. In a terminal, type in ps space -A Z space pipe space grep space postfix and hit enter. We can see the master service is running under the postfix_master_t domain. The queue manager is running under the postfix_qmgr_t domain. And lastly, the pickup service is running under the postfix_pickup_t domain. Now let's check the security context on Postfix related files and directories. Type in clear and then type in ls space -d Z space /etc/postfix space /var/lib/postfix space /var/spool/postfix and hit enter. We can see that we have three file security contexts: postfix_etc_t for the configuration files, postfix_data_t for the var/lib postfix directory, and postfix_spool_t for the mail spool directory. In SE Linux, network ports also have types in order to allow certain domains to access certain ports. Let's look at the ports associated with the SMTP protocol. Type in clear, and then type in sudo space semanage space port space -l space pipe space grep space SMTP and hit enter. This shows the TCP ports of 25, 465, and 587 labeled with the SMTP_port_t type. If you choose to have your mail server answer on any other port, you will need to change the SE Linux security policy database by adding the SMTP_port_t type to the new port number. The last thing we'll look at is the SE Linux booleans associated with the Postfix service. To do so, type in clear, type in get sebool space -a space pipe space grep space postfix and hit enter. We see that we have one boolean that allows writing to a local mail spool. This is turned on by default and is necessary for most standard mail servers. It could be turned off if the mail spool was remote. To configure a local mail server, we'll want to start by editing the etc postfix main.cf file using vi. On your RHOST1 VM, open a terminal and type in sudo space vi space /etc/postfix/main.cf and hit enter. Enter your password if prompted. The first parameter we'll edit is my hostname. Press / and type in my hostname and hit enter. Go into insert mode and change the value to rhost1.localnet.com and make sure it's uncommented. and then go down to my domain and change that to localnet.com. And also make sure it's uncommented. Now scroll down again until you see my origin. We can change this to rhost1.localnet.com, or we can use $my_hostname, which contains the same value. As such, we just need to uncomment the line that includes my hostname. Next, let's double check which network interfaces postfix will answer on. Scroll down again until you see iNet interfaces. We need to make sure this says all. You may have to comment out the current line and uncomment the line that says all, or just edit any line directly. Now let's edit my destination. Press escape and then / and type in my destination. Press N to go to the next instance. Make sure this includes my host name, local.mydomain, localhost, and my domain. We will comment out the default line and uncomment the one that includes my domain. Now press escape and type / again. Type my networks and hit enter. You can press N multiple times to step through the instances of the word my networks, or just scroll down. We need to change the values to 192.168.1.0/24, space 127.0.0.0/8. If your local network is not 192.168.1, then insert the correct one here. The last thing we'll edit is the DNS lookups. This line is not currently in the file, so we'll need to go to the end and add it. Go to the end by pressing escape, capital G, capital A, and hit enter. This will take you to the end of the file and put you in insert mode. Now add disable _ DNS _ lookups, space equals space yes. This instructs postfix to use the get address info system library routine, which also looks in etc hosts. Now save and exit by pressing escape :X ! And hitting enter. Let's check the postfix configuration file now using postfix check. Type in sudo space postfix space check and hit enter. If there are syntax errors, you'll want to fix them now. Now let's allow SMTP traffic through the firewall. Type in clear and type in sudo space firewall-cmd space --permanent space --add -service space SMTP and hit enter. Now let's reload the firewall rules. Type in sudo space firewall-cmd space --reload and hit enter. Now let's verify that postfix is running and we'll start on reboot. Type in clear again, then type in sudo space systemctl space enable space postfix and hit enter. And we'll restart the service now that we've changed the configuration file. So bring your line back and change enable to restart. And lastly, let's check the status. Bring your line back again and change restart to status. If everything looks good, we can move on. So now we need to make postfix the default mail transport agent. Type in clear and then type in sudo space alternatives space --set space mta space /usr /sbin /sendmail .postfix and hit enter. Now let's create a second user to send email on. Type in sudo space user_add space user2 and hit enter. Now let's set a password for user2. Type in sudo space passwd space user2. Now set a password for user2. Now let's create an email for user2. Type in clear and then type in date space pipe space mail space -s space double quote. This is a local test, double quote, user2 and hit enter. Now we'll switch over to user2 and check that user's email. Type in su space hyphen space user2 and hit enter. Now enter user2's password. To check user2's email on the command line, type in mail and hit enter. We can see that we have an email. To read it, press the number of the email. In our case, it's the number 1, so press number 1 and hit enter. We can see the email came from rhost1.localnet.com. When done, press Q to quit. Keep in mind that to troubleshoot this process, you can also open a terminal and tail the var log mail log file for messages. Also, now that we have a working mail server, let's create a new snapshot. Press Ctrl T and let's call this Working Mail Server. And hit enter. For this exercise, we're going to send an email remotely to a user on the mail server and then log into the mail server and check it. You will need both RHOST1 and RHOST3 VMs running for this exercise. You will want to start this exercise logged into your RHOST3 VM. We're going to reserve our RHOST2 VM for our relay host exercise later in this chapter. We'll start by installing Postfix. To do so, make sure you logged in as user 1 and have a terminal open. To install Postfix, type in sudo space yum space install space -y space postfix and hit enter. Enter your password if prompted. Postfix may be installed, and if not, this should install it without issues. Now let's edit the main.cf file using vi. Type in clear, and then type in sudo space vi space /etc /postfix /main.cf and hit enter. We're going to disable DNS lookups. Since this line doesn't exist, we'll add it to the end. Go to the end of the file by pressing escape, capital G, capital A, and hit enter. This takes you to the end of the file and puts you in insert mode. Now add disable _DNS _lookups. Space equals space yes and hit enter. Save and exit by pressing escape, X, ! And hitting enter. Now let's restart the Postfix service and enable it so it starts at boot. Type in sudo space systemctl space restart space postfix and hit enter. Now to enable it, bring your line back and change restart to enable and hit enter again. Now we should be ready to send a test email. We'll send this test email to user 1 on RHOST1 by typing in clear and then type in date space pipe space mail space -s space double quote. This is a remote test double quote space user 1 at rhost1.localnet.com and hit enter. Be sure there are no error messages before going on. Now switch to your RHOST1 VM and log in as user 1. Open a terminal and check email by typing in mail and hit enter. We should see our new remote test email. To read the email, press the number that precedes it. If you only have one, then press 1 and hit enter. Here we can see some information about the email. We can see that it came from rhost3.localnet.com. Now press Q to quit. If you did not see an email, you'll want to double check a few things. First, make sure your name resolution is perfect. Ping rhost1.localnet.com from rhost3 to be sure. Also make sure the SMTP port on rhost1 is open by allowing traffic with the firewall. Before we move on to the next exercise, let's snapshot rhost3. To do so, switch back to rhost3 and press Ctrl-T. Name this Mail Client Working and hit enter. For this exercise, we'll need two virtual machines running. rhost1 will be our mail server just as it is now, and we will not change the configuration from past lessons. It's important to note that it needs to be in a working state from previous lessons in this chapter. rhost2 will be our null client mail relay. We will configure the Postfix service to relay all local mail in rhost2 to the mail server. Then we'll send an email in rhost2, which will get relayed to our central mail server on rhost1. Log into rhost2 and open a terminal. Now install Postfix using yum. Type in sudo space yum space install space -y space postfix and hit enter. Type in your password if prompted. This will install Postfix if it is not already installed. As soon as it's installed, edit the etc postfix main.cf file with vi. Type in clear and then type in sudo space vi space /etc /postfix /main.cf and hit enter. We're going to edit this file pretty quickly. Use forward slashes to find the parameters and then set them to the values that I specify. First, we'll start with my host name. Type in / my host name. We're going to uncomment the line and then change the value to rhost2.localnet.com. Now let's go down to my domain and let's change this to localnet.com. And of course, uncomment it. Now let's scroll down again to my origin. We want to uncomment my origin equals my domain. With this setting, all emails will look like they came from localnet.com and not from rhost2.localnet.com. Now search for inet_interfaces. Escape /inet_interfaces and hit enter. We want this set to localhost. This means we will not accept any incoming emails and only relay mail created on this host. Make sure there are no other options uncommented. Now search for my destination. Escape my destination and hit enter. And you might have to scroll down. Change this to null. It should read my destination space equals with nothing after it. This says that this postfix installation is not the destination for any email. All email is forwarded to the main mail server on RHOST 1. Now let's set relay host. Press escape / relay host and hit enter. We're going to set relay host to rhost1.localnet.com. We can use a host name here even without working DNS because we're going to disable DNS lookups in a moment. For this to work, we need to have reliable name resolution via the etc host files. Another option is to use the IP address or place the fully qualified domain name inside square brackets. Now go down to the bottom of the file by pressing escape, G, A, and hit enter. We're going to add a line here to disable DNS lookups. Type in disable _DNS _lookups space equals space yes, and then save and exit by pressing escape, X, ! And hitting enter. We would not do this last step in a lab environment with DNS working. Now restart and enable the postfix services. Type in sudo space systemctl space restart space postfix and hit enter. Bring your line back and change restart to enable to ensure that postfix starts at boot. Normally a configuration reload would be adequate here, but if you change the value of inet_interfaces, you will need to restart the service. Now we will send a test email from here. Type in clear and then type in date space pipe space mail space -s space double quote. This is a null client relay test double quote. Space user1 at localnet.com and hit enter. If successful, our local postfix installation should relay the mail to our main mail server on RHOST 1. Now switch to your mail server on RHOST 1 and log in. Open a terminal and then check mail as user1 by typing in mail and hit enter. If successful, we should see our null client relay test mail. Press Q to quit. As a recap, we had a fully functioning mail server on RHOST 1. We created a mail relay on RHOST 2 and sent an email from it. The relay on RHOST 2 forwarded the mail to our mail server on RHOST 1. This chapter covers secure shell or SSH services. In this chapter, we install additional SSH packages that are not automatically installed. We learn about SSH client and server configuration options. We learn how to create individual user client configurations. We configure key-based authentication. And lastly, we configure host and user-based security. Before you start, you might want to download and print the SSH cheat sheet I've included with this chapter. The SSH client and SSH server should be installed by default in Enterprise Linux, but if they're not, we'll do it now. To install the client, open a terminal and type sudo space dnf space install space -y space open SSH -clients and hit enter. If it's already installed, it won't hurt anything. We install the SSH server the same way. Type in clear, then type in sudo space dnf space install space -y space open SSH -server and hit enter. If you have to install the server, it will have to be enabled as well. We'll use systemctl for this. Type in sudo space systemctl space start space sshd.service and hit enter. To make this persistent, bring your line back and change start to enable and hit enter. Now we're ready to proceed with learning about Secure Shell. SSH has many options including which ciphers to use, which hosts a client can connect to, and how it operates. However, usually a client configuration uses the defaults and is much easier to work with than the SSH server configuration. There are three ways of passing configuration options to the SSH client. They're processed in the following order: command line options, the per user configuration file stored in the user's home directory, and lastly, the system-wide configuration at /etc/ssh/ssh_config. For each parameter, the first value will be used, so any option specified on the command line override the configuration files. Any option in the user's configuration file overrides the system-wide configuration file. Let's start by looking at our system-wide configuration file. Later in this chapter, we'll talk about the per-user configuration as well. Let's load the system-wide configuration file into less. In a terminal, type in less space -q space /etc/ssh /ssh_config and hit enter. I've added the -q option to quiet the error bell in less. Configuration options in these files are stored in key value pairs on individual lines. Any line that starts with a hash symbol is a comment. In the case of the SSH configuration items, it will be the name of the item and the default value. To edit this setting, we'd uncomment the line and change the value. There are not very many uncommented lines. The first one is the host line, followed by the pattern of host a client is able to connect to. In my case, it's an asterisk meaning all hosts. The next line that's uncommented is the GSS API authentication line. The value is set to yes to use the Generic Security Services API. This is an IETF standard for doing strong encrypted authentication in network-based applications. It's what we use to use Kerberos with SSH. The next line that's uncommented is the forward X11 trusted line. This is set to yes. If set to yes, then the remote clients will have access to the full original display. If set to no, the remote client will not have access to the entire display, and the XAuth security tokens will expire after 20 minutes. After this time, remote clients will be refused. The last uncommented lines are locale-related variables. To see what settings we can modify, let's take a look at the man page for this file. Press Q to quit. Now type man space /ssh_config and hit enter. This man page explains all possible options including ciphers, optimizations, and generic configuration items. Keep this man page in mind when configuring the SSH client, as it explains every option. Configuring SSH servers is a bit more involved than the client. We won't cover all configuration items here as this is beyond the scope of this program. However, we will look at some more common options and I'll show you where to find the answers to all of your SSH server questions. The SSH server configuration is in /etc/ssh/sshd_config. Don't get this confused with the SSH_config, which is your system-wide client configuration. Let's take a look at the server configuration file by loading it into less. We'll need to elevate privileges for this. In a terminal, type in sudo space less space -N q space /etc/ssh/sshd_config and hit enter. I've added the -N option for line numbers and -Q to turn off the error beep. Once again, all lines that start with a hash are comments. Configuration items are written in key value pairs. Lines with key value pairs that are commented usually show the defaults. For instance, look at the port 22 item on line 17. This line is commented because the default port is 22. If we wanted to change the SSH server port, we would edit this line by uncommenting it and changing the value. Also note the message above it. Sometimes when changing server values, we also need to change SE Linux values. It's best to follow the instructions here. Let's scroll down a bit. We can see there are sections for ciphers, logging, authentication, and so on. It's common to change items in the authentication section, including the login grace period and permit root logins. By default, root can log in using SSH. The easiest way to restrict this is to change this to no. Strict modes checks the SSH key and configuration file permissions and ownership. Let's exit less and look at the man page for SSHD_config. Press Q. And then type in man space SSHD_config and hit enter. This man page explains every option for the SSH server configuration. As you're configuring your SSH server, keep this page in mind. For this lesson, you'll need both RHOST 1 and RHOST 2 VMs running, so start them now. You'll also need to be sure that hostname resolution works, or you need the IP address for RHOST 2. With SSH, every user can have a per-user client configuration file for overriding certain SSH client configuration items. This configuration file is stored in the user's home directory at ~/.ssh/config. The .ssh directory doesn't exist until you try to connect to a server for the first time, or after you create SSH keys. Creating it manually is possible, but the ownership and permissions need to be exact or SSH won't function properly. I suggest trying to SSH to a server and then canceling it as a simple method of ensuring it's created properly. We can verify if it exists using ls. Type in ls -la in your home directory and hit enter. The per-user client configuration file allows us to store information about our remote servers to make administration easier. type in clear, and then let's create one with VI. First type in clear and then type in VI space tilde slash .ssh slash config and hit enter. Go into insert mode by pressing the I key and then add host with a capital H space host 2. New line, tab, user with a capital U space user 1. New line, tab, host with a capital H, name with a capital N, space. Note that the name you use for hostname has to be the IP address or resolvable hostname of the remote machine. So we could put rhost2.localnet.com in here. In my case, I will put the IP address of my rhost2 VM, which is 192.168.3.116. You will want to put the IP address of yours in your file. The name you put for host, however, is arbitrary. You can name it anything you want. In this example, I chose host2. I chose to make it different from the host name so we could ensure that it's working. Now let's save and exit by pressing escape:*X, ! And hitting enter. We also need to change the permissions of this file. Type in chmod space 600 space tilde slash .ssh slash config and hit enter. If you don't do this, you'll get an error message when you try to connect. Now let's try to connect to our rhost2 VM using the host2 name. Type in ssh space host2 and hit enter. The first time you try to connect to a host, it attempts to establish authenticity. Say yes here. Because this is just a test, we can hit enter 3 times to cancel the login attempt. By SSHing to host2, the SSH client looks up the information in the per user configuration file and fills in all of the other options based on what it finds. As such, you can put most any SSH option you want in this configuration file. Let's edit it again. Type in clear and then type in vi space tilde slash .ssh slash config and hit enter. Go into insert mode by pressing the I key and hit enter. If, for instance, the remote host accepted SSH connections on a non-standard port, or we wanted to use SSH keys, we could put those things in this file by adding these lines. Type in tab, port with a capital P, space 1022, new line, tab, identity file with a capital I and a capital F, space tilde slash .ssh slash rhost2.key. Keep in mind that for this configuration to work, you'll need to create the SSH key pair and name it rhost2, and then copy the public key to the remote host. You would also need to change the rhost2 server configuration to answer on port 1022. We won't handle making keys in this video. If you want more than one host directive in your per user configuration file, you can just add a blank line and add additional hosts. If you want options that affect all hosts, use an asterisk for the host item. For instance, type in host with a capital H, space, asterisk. New line, tab, user, space, user 1. Now when we SSH to any host and don't specify the user, it will fill in user 1. We can override this for specific hosts by specifying the user on the command line. Just remember that command line options override per user configuration options and system-wide options. There are multiple ways of authenticating using SSH, but the two most common are passwords and private public key pairs. For this exercise, we're going to need both of our VMs booted up, and you'll need the IP address of your rhost2 VM. To set up passwordless logins, I need to generate the SSH key pair using the SSH keygen command in the rhost1 VM. In a terminal in your rhost1 VM, type in ssh-keygen and hit enter. Go ahead and take the defaults when prompted. Since we did not pass it any options, it created RSA private and public keys. Let's verify this by listing the .ssh hidden directory. Type in clear and then type in ls space -l space tilde slash .ssh and hit enter. We can see that we have a file called id_rsa, that is our private key, and we have a file called id_rsa.pub, which is our public key. Let's view the public key with cat. Type in cat space tilde slash .ssh slash id_rsa.pub and hit enter. Now let's copy the public key to rhost2 using the ssh copy id command. Type in ssh-copy-id space user1 at, and then your RH host 2 IP address. In my case, it's 192.168.0.21. You'll want to enter yours instead. Say yes to accept the fingerprint to continue, and then enter the remote user's password. To make sure that the key is added to the local SSH agent that manages the keys, we can type in SSH-ADD and hit enter. This is not always necessary, but doesn't hurt anything if you run it. When using SSH copy ID, two things happen. First, the local public key is copied across the network to the remote end and stored in the user's authorized keys file. And second, the fingerprint of the remote server is stored in the local user's known host file. Type in clear, and let's take a look at the local known host file. Type cat //known_host and hit enter. This file stores the IP address of the remote servers as well as their matching fingerprints. If the remote server ever changes its IP address, you'll need to delete its line from this file before connecting again. Don't worry about remembering this, as the SSH client will refuse to connect and remind you to delete the line. Now that the key is copied, let's try to log into the remote host. Type in SSH user1 @ and then the IP address of RH host 2. In my case, it's 192.168.0.21 and hit enter. We should be able to log in without typing a password. If it prompts you for a password, just go back and do the steps again. I mentioned earlier that the SSH copy ID command copied the public key into the authorized keys file on the remote host. Let's look at this file while we're still logged into RH host 2. Type in clear and then type in cat //.sh/authorized keys and hit enter. This file contains the public key from RH host 1 that we viewed earlier. We can manually append any SSH public key to the authorized keys file using a redirect, but it's best to let the SSH copy ID command do it, as SSH can be picky about file permissions and syntax. It's generally a bad idea to log into a server as the root user. Logging in as a regular user and then elevating privileges via sudo or the su command is a much better strategy. If we allow root logins, even if the password is very strong, then hackers will target that account. The solution is to restrict root logins by way of SSH, which is fairly easy to do. It doesn't matter which VM you do this on. I'll be using my RH host 1 VM. Let's make sure that we can log into our VM now as root. Type in SSH root @ localhost and hit enter. Type in root's password and hit enter again. This shows we can log in as root. Having a strong password is a good idea, but not allowing root logins is better. Type in exit to log out. Now let's open the sshd_config file in VI. Type in clear and then type in sudo /etc/etc/ssh/sshd_config and hit enter. Type in your password if prompted and then hit enter. Now let's search for the word permit by pressing the / and typing permit with an uppercase P. The line we're looking for is permit root logins yes. Go into insert mode by pressing your I key, delete the hash, and then change the value to no. And then save and exit by pressing escape, X, ! And hitting enter. Now that we've changed the configuration, we need to restart the service. Type in sudo systemctl restart sshd and hit enter. Now let's test it again. Bring your SSH line back and hit enter. Now type in root's password. There should be a delay when trying to log in, and it should deny us. Notice it gives no indication that something is restricted, but rather acts like we typed in the wrong password. This is important because it doesn't let the hackers know what the problem is. Restricting root logins is easy, but we might want to go further than that and restrict which users can log in and from where. We can restrict SSH so it will only answer requests from specific networks by using the listen address option in the sshd_config file. Let me show you what that looks like. Type in clear and then bring your sshd_config line back and hit enter. Now we're going to go into insert mode and we want to go down to the listen address line, which is near the top. Delete the hash, and then for the IP address, I would put in 192.168.1.0, which is my network. This would restrict access to hosts from my network. Another way to restrict access is by using the allow users option. There are no allow users lines in the default file, so we'll need to add one. I like to add options like this to the bottom of the file so I can find them easy later. Press escape to exit insert mode, and then press capital G to go to the bottom of the file. Now press capital A to append a line and hit enter. Add the line allow users with a capital A and a capital U space user1. This list of users is an exclusive list. Only user 1 can SSH into this host. Be very careful with this functionality. You may lock yourself out while testing it, so always open another terminal and log in with that one to make sure it works. If we want to go one step further, we can restrict who can log in with SSH and from which network. Change the line to include the network and subnet mask. This is a fairly easy way of restricting who can log in and from where. I can't stress enough that you need to test this with a second terminal to make sure that it works before logging out of your existing terminal. This brings us to the end of this course. No matter why you took the course, it will be advantageous to you to complete every exercise more than once in order to gain proficiency. An alternative next step would be to study for a Linux certification test such as LPIC 1, Linux Plus, Red Hat Certified System Administrator EX200, or the Linux Foundation certifications. Importantly, use your newfound knowledge. Together, people like you utilizing open source can change the world.